Harvard.
Let's go, Harvard!
Pass them down.
Great. Hey, let's go, Harvard.
We're nice.
You see that? Look at them. They have the over. It's going to happen. It's actually going to happen. I can't believe this.
What do you think of Yale?
They don't think good.
Does everyone have it? Does everyone have their stuff?
Okay.
Does everyone have their stuff?
Probably that it's going to be legible. It's very small.
I agree.
I know, but it's too complicated.
What houses?
How many extra? How many extra are there?
Sometimes.
Yeah. You guys are from Harvard.
No, Foho. Fortheimer.
Yeah, but you said Hope.
Just make sure everyone
Well,
has
probably
it.
drunk.
It looks like they're still passing. Are all the cards distributed?
Yeah.
All right, we can do it now.
What do you think of Yale, sir?
Go on the wing. Do it one more
They
time.
suck?
One more time. One more
Do it
time.
again.
Oh, and there it goes again.
All right. This is CS50. Welcome to week 8. Last week, we learned how to create, read, update, and delete databases using SQL. But this week,
Adam, everyone, happy Halloween. All right, so this is CS50, and this is week 8 already. My thanks to Adam on today, this happy Halloween. In the coming moments, we're going to learn all about how the internet itself works, which of course is a technology that we all use every day, probably using in some form right now. But we'll see that if you start to understand some of the underlying building blocks that power the internet itself, we can actually start to build interesting things on top of it. And a lot of the apps, the websites that you all use every day should become all the more familiar, things that you yourselves can create. And honestly, when things go wrong, you'll have all the more of a mental model for how things work or are not in fact working, so that you can ultimately diagnose all the more issues yourselves. So if we take a look at the internet in the early days, it pretty much was just this. This happens to be, of course, the geography of the United States, and just some of the first points on the internet were these here. This was so-called ARPANET back in 1969, and indeed the internet had its origins here in the United States with just a few computers interconnected somehow initially. That, of course, began to grow over time, such that we eventually had the West Coast connected to the East Coast, and nowadays what you can think of, these dots on the screen as representing, are these things called routers, sort of computers, or really servers, that somehow have wires or maybe wireless connections between them that allow data to flow from point A to B to C. And then this, of course, has been now magnified across the entire globe, and even above ground as well, so that we can connect all the more readily to systems anywhere. Now, in order to route the data from one router to another, we need to somehow make routing decisions. And this is the kind of thing that the internet service providers, the ISPs of the world, just handle for us. You and I plug our Macs, our PCs into the network here at Harvard, or equivalently at Yale, or we somehow get online via Wi-Fi or cellular technology. And then some of these larger entities, these bigger companies or countries, handle most of the data getting from point A to point B. And if you think about what these routers represent, they're indeed just servers somehow interconnected, not unlike unlike this grid of tiles here, for instance, back in the Zoom days. And in fact, here we have, I claim, a grid of routers implemented here by the course's teaching fellows and course assistants and TAs. And if the goal at hand, for instance, is for Phyllis to route some piece of information, maybe it's an email, maybe it's a request for a web page in the bottom right-hand corner, all the way up to, say, Brian here in the top left-hand corner, suffice it to say, each of these tiles represents a router, a server that can move the data back, forth, left, and right. That packet of information, so to speak, from Phyllis to Brian could take any number of different possible routes, up, down, left, right, to go from the one corner to another. So let me go ahead and hit play on this video here, wherein the teaching fellows play this same role. All right, so in this particular case, the data was routed pretty straightforwardly up and then to the left. But suppose that one or more of the staff were a bit busy. Maybe one of the routers is congested. That is to say, just got way more envelopes at a moment in time than it can handle. Thankfully, the design of the internet is such that there's often multiple ways that data can get from point A to point B, maybe going through point C or point D instead. And so there's a resilience there, even as some of these servers themselves might go down. So allow me to propose that we use the same grid of routers now to route the data in a slightly different way this time. So success. You'll see perhaps later just how many takes it took us to actually get that routing right. But it does, in fact, manifest that you can travel different paths in order to get the data from point A to point B. So as we talk about routers, as you think of the internet, I mean, think of those humans as just representing these routers, points A to P and everywhere in between. Now, how did the teaching staff know to route that packet up and then down or left and right in order to get to the destination? Well, all of them were programmed, so to speak, to understand protocols. It's called TCP and IP, otherwise known together typically as TCP/IP. And you've probably seen these acronyms at some point in the real world, on the internet, on some kind of documentation, a text, even if you haven't really thought hard about it. But IP is certainly the more common of the two, perhaps, in common culture. So what does TCP and IP do for us? Well, really two primary things. Any computer or any teaching staff member who understands TCP/IP knows how to get data from point A to point B. But how? Well, let's break down what that problem to be solved is. IP, otherwise known as Internet Protocol, is a protocol that computers speak that allow them to know how to address computers on the internet. And a protocol is just a set of conventions that computers adhere to. So someone wrote code that probably has a whole lot of conditionals that tells the computer what to do if something happens. Like, if I receive a packet, then send it to the next server, or something like that. In the human world, we have protocols too. You know, in healthier times, it was quite common to sort of extend your hand to another human in order to greet them. And if they're following human protocol, they would presumably grab your hand and shake it, at least in a culture like this one here on campus. And now that is a human protocol in that someone initiates it, someone responds to it, and you both sort of know what to do. You're programmed to know what to do. So same idea with Internet Protocol. Computers just know what to do when they've been programmed to do so. So what does this mean? IP decides that every computer in the world will have a unique address, just like the Science Center around the corner might have a unique address of 1 Oxford Street, Cambridge, Massachusetts, 02138 USA. IP dictates that every computer on the internet have a unique address of this form. And this, too, is probably something you've seen in the real world, even if you haven't thought too hard about it. It's a number in what's called dotted decimal notation, which means it's a decimal number, dot something, dot something, dot something. So 4 digits separated by convention by decimal points, although there are newer and bigger versions of the same. And these so-called IP addresses that might be as simple as 1.2.3.4 uniquely identify a computer on the internet. The numbers have to range from 0 to 255 each. And that's a bit of a hint just as you start to think more computationally. If each of these is a number from 0 to 255, how many bits does that suggest each number is using? Feel free to shout it out. How many bits gives us 256 total possibilities? So 8 bits, that should just be sort of a heuristic in your mind anytime you hear something that's in the range of 0 to 255 or 256 values total. Think back to week 0, which gives us 8 bits plus another 8 bits, another 8 bits, and another 8 bits, which is to say an IP address typically is 32 bits in total. Now, if we do another bit of quick mental math or think back to week 0, if every IP address is 32 bits, how many computers can we have on the internet at once, give or take? Roughly 4 billion is the ballpark. And we don't need to be super precise for discussion's sake, but roughly 4 billion is how high you can count, assuming no negative numbers, if you have 32 bits in total. Now, that's not terribly many numbers of addresses, especially considering the number of humans in the world, the number of us that do have laptops or desktops or devices more generally, phones in our pockets and the like. So let me just stipulate for today's purposes that there's even a newer and improved version of IP, otherwise known as version 6. This is version 4, but still super popular. Version 6 uses 128 bits, which is a huge number of possible permutations. I dare say I can't even pronounce that number. It's so big. So there are ways around even this limitation already. So every computer has an address like this. What does that really mean? Well, suppose that I was Phyllis in the story told visually earlier, and I want to send a message to Brian. Well, both Phyllis and Brian have IP addresses. And suppose that Brian's IP address happens to be 1.2.3.4 in that top left-hand corner. Well, Phyllis's Mac or PC or phone would essentially do the equivalent on this human envelope by writing the to address in the middle of the envelope, as is our human convention, like this. So this is an envelope, a piece of information, an email, a text message, whatever, destined for Brian. And so she would have her computer put Brian's IP address in the middle. Her IP address is maybe 5.6.7.8. So just like our human convention, I might write 5.6.7.8 at the top of the envelope. 5, 6, 7, 8, thereby indicating what the return address is. And this is helpful because if Brian's computer needs to acknowledge receipt, if he needs to reply in some form, this way the envelope has all the information we need. But in the real world, servers do a lot of things nowadays, not just email, but maybe chat, maybe video conferencing, maybe any number of other services as well. And so it turns out that an address alone might not be sufficient, because how does Brian's computer know when he opens the envelope, so to speak, that this should be interpreted as an email or interpreted as a chat message or interpreted as like a video attachment that Phyllis has sent? Well, we need some other mechanism, some other hint on this envelope to distinguish one type of internet service from another. And so that's where the other acronym in TCP/IP comes in, which is TCP. So this stands for Transmission Control Protocol, which is just a different set of conventions that computers adhere to in order to solve a couple of different problems. One is this problem of distinguishing one type of service from another. Now, what does that mean? Well, humans decades ago decided, as they started inventing all of these various internet services, the web being the first one, how they might, or the web now being one of the most popular ones, they decided to assign different services that can be used on the internet unique numbers. And so two of the most common are these. 80 is the number that a bunch of humans decided years ago will represent what you and I know as HTTP. And we'll talk more technically in a bit about what HTTP is, but obviously it's the thing that's in the beginning of every URL nowadays. Or HTTPS, which of course has the S added to it, and that has its own unique number. And for now, the S just means secure. One is encrypted or scrambled somehow for privacy's sake, and the other is unencrypted. It's a little more vulnerable to interception. So these two numbers are what the world decided when implementing TCP shall uniquely identify those services. So what does this mean? Well, this means that if Brian's computer in the story from before is hosting not like an email server, but maybe he has a website, and Phyllis is requesting Brian's homepage or something like that, she would have her Mac or PC or phone not only write Brian's IP address in the middle of the envelope, but also the number, otherwise known as a port number, that she wants this envelope to be routed to. Now, 80 would be insecure nowadays. HTTP:// is sort of passé, and we almost always see HTTPS:// now. So I'm just going to go with best practice, and I'm going to add a colon and then the number 443 at the end of Brian's IP address. So now I have an IP address for Brian, the port number for the service that this is relevant to, and I'm not going to bother writing it, but it turns out that Phyllis's computer would also choose a port number, maybe a random port number, so that Brian can conversely reply. And then the computer can know which response is coming back for which request. But the most important one is this one in the to field, whereby this distinguishes this from like an email, a chat message, a video conference session, or a Zoom or whatnot from anything else happening on Brian's computer at the same time. So all this time, if you've seen these terms TCP and IP, those are really two of the most important things that they do. But TCP does one other thing that's super useful too. It turns out that it's super common nowadays, especially, to transmit a lot of media on the internet, whether it's an image or maybe it's a movie file. And it would be a little obnoxious, to say the least, if you're downloading a really big file meant that no one else in your dorm room or your household could actually download anything until you're actually done. So of course, multiple people nowadays can be on the internet at once, even if all of the connections are a little slower, but like one person's usage does not block someone else's. Now, how does this work? Well, TCP in conjunction with IP can also allow you to take like a really big image of a cat, which is the internet, of course, is filled with, and take a big image of a cat or a big video file of a cat and fragment it into multiple pieces. So I'm just going to sort of roughly tear it down the middle and then maybe tear it down the middle again. So now it's 4 different fragments. And I'm sorry, but the computer will be reassembling these for us. And what Phyllis's computer could do now, if she's like uploading this picture of a cat to Brian's web server, well, she could put one fragment in this envelope and then have 3 separate envelopes for the other 3 fragments. And what she could then do on the outside of this envelope is just kind of number them somehow. And in fact, this is something else that TCP and IP together would do for us. This first envelope now might say something like 1 out of 4 in the memo field, so to speak, of the metaphorical envelope here. Now, this should be enough information, because now if Brian gets all 4 of these envelopes, he presumably knows how to reassemble the picture of the cat in order, top to bottom, left to right. But more importantly, suppose that one of the routers, one of the TFs in the video, is sort of distracted and they sort of drop one of the packets. And that's a metaphor actually in practice for when a router gets really busy, it's got way too much data coming in, it might metaphorically drop packets. What does that mean in practice? I mean, it literally just ignores the zeros and ones. It doesn't save them to its memory because there's just no room left. So it's equivalent to sort of dropping the packet. So suppose now that Brian gets 1 of 4, 3 of 4, and 4 of 4. What can his computer infer now after receiving those 3 packets? 1 of 4, 3 of 4, and 4 of 4. What's the use there? Yeah, I think you're signaling with your fingers. Which one can I call on you? Yeah, so he's missing 2 out of 4, the second of the packets. And this is useful now because you could imagine he can send some message back to Phyllis saying, hey, please retransmit number 2 of 4 without having to re-download the entirety of the cat. So there's an efficiency there as well. So TCP/IP allows data really to go from point A to point B while solving a bunch of these problems along the way. So nowadays, if you ever see mention on your Mac or PC of your so-called IP address, that is the sort of problem that's being solved. Questions now on these protocols, these conventions called TCP and IP. That's the extent to which we'll need to understand them. Won't have to implement them per se. We'll just take them hereafter for granted. Any questions that you've ever been wondering about your home network? Yeah? A really good question. How does TCP know that a user got a message? Another aspect, another feature of TCP is that Brian's computer, by design of this protocol, will also acknowledge the packets that he's received. And it will do it efficiently. If Brian receives all 4 packets in a pretty narrow window of time, his computer will send to Phyllis's computer a quick message saying, essentially received all 4. Otherwise, he'll say the opposite, which is that I'm missing, for instance, 2 out of 4. And that just ensures ultimately that all of the data is indeed arrived so that you're not missing like a quadrant of the cat in question. All right, but that's not the only problem that needs to be solved ultimately. We also need to make the internet user-friendly, if you will. And it would be really tedious if you had to visit websites, for instance, by way of their IP addresses, right? 1.2.3.4 is pretty memorable, but there's like 4 billion other possible addresses available, and it would be super tedious to remember those. It would be bad marketing to advertise those. In fact, most of you probably don't even know the phone numbers of your closest friends and family members anymore because you instead store them in your contacts or your address book, associating with numbers that are completely opaque with actual names or strings, if you will. The same goes for the internet too. Even though every computer does have and must have a unique IP address numerically. Why? Well, routers are computers. Computers just crunch numbers very readily, but we humans work better with strings of text. We need some system for converting user-friendly strings like harvard.edu or yale.edu or google.com to the underlying IP addresses. And that's where the next acronym comes in today, which is DNS, Domain Name System. So this is just another technology that's been in use for some time now. And it's a collection of servers on the internet whose purpose in life is to convert domain names to IP addresses, and maybe vice versa as well. So let me stipulate for today's purposes, there are some root DNS servers in the world that, long story short, know about all of the .coms, all of the .edus, all of the ... all of the other top-level domains around the world, as well as in the US. And then there are some smaller DNS servers owned by companies, owned by universities, and even in your apartments or homes, most likely. Indeed, if you have a home router plugged into the wall somewhere, that's not only routing your data in and out of your apartment or home or dorm room, it's also typically serving as a local, therefore faster DNS server, a cache, if you will. It's sort of locally saving your most frequently accessed websites and their IP addresses just to avoid bothering the bigger, more expensive, busier servers all day long. So there's DNS servers all over. If you poke around your settings in Windows or Mac OS or Android or iOS, you'll see mention of DNS, and you'll probably see the IP addresses of the servers whose purpose in life is to do this conversion for you. But this is a requisite feature if we just want the internet to be user-friendly and allow us to use words instead of numbers alone. What's inside of these DNS servers? You know, it's essentially a spreadsheet, or if we can say it more geekily, it's essentially like a hash table of some sort, which it has keys and values. Like the key is the domain name, harvard.edu, yale.edu, google.com, and the value is the corresponding IP address, or in many cases, IP addresses, plural, of the corresponding servers. So here already, even though I've drawn it fairly abstractly, like you would on a chalkboard, it's really probably implemented as some kind of table, maybe a hash table, maybe a database table, maybe SQL or something like that, or maybe it's even just a linked list or an array. We just have to somehow enable this computer to convert one to the other. Now, just to be super precise, DNS servers actually convert what are called fully qualified domain names, which is generally not just harvard.edu, but more verbosely www.harvard.edu and www.google.com. So the whole thing that you would see as a substring of the URL. So that's what DNS does, and that's what your university, your company, your home router are doing for you. Let me pause here to see if there are any questions. This, too, is just a technology now we'll take for granted, just works. Questions at all? No. All right, so let's now transition among our protocols really to the last for today, which will set the stage for actually solving problems with these and writing some code ultimately. HTTP. This is something that you see or hear all day long, even though you rarely have to bother typing it anymore. Odds are if you go to harvard.edu, yale.edu, google.com, you don't bother typing HTTP, let alone HTTPS manually anymore. Why? Because your browser auto-completes, that kind of thing, just to make life easier. But it is officially at the beginning of every URL you visit, either HTTP or the more secure HTTPS, whenever you're using your browser to access some website. So HTTP stands for Hypertext Transfer Protocol. And it's easily one of the most popular, dare say one of the most powerful features of the internet nowadays. But the mental model to have here is that HTTP, or the web more generally, is kind of a service that runs on top of the internet. And maybe Zoom or Microsoft Teams is another service that runs on top of the internet. And iMessage and technologies like it is another service that runs on top of the internet. So the internet is really like the lower level plumbing, the TCP/IP stuff, the DNS stuff that just gets data from point A to point B. But now, and we're in a software development class ultimately here in CS50, HTTP is the application level protocol. It's sort of what programmers use, what companies use, what developers use ultimately to use the underlying plumbing, to build interesting and powerful things. So what does this mean when it comes to accessing services via HTTP or the more secure HTTPS? Well, here is a representative URL. Even though you might not type the whole thing, if you poke around your address bar, this is what's up there. With that said, a lot of browsers nowadays are kind of simplifying, if not dumbing down, what you see with your human eyes, just to shorten the strings, especially on mobile devices. But almost always, if you click the URL or highlight it, then you see the whole thing. But on many browsers, you might only ever see example.com, but all of this information is there. It's just getting more and more hidden just for user interface's sake. Well, it turns out when you visit a URL, by default, especially if you type nothing after the .com in this case, you're technically implicitly adding a single slash. So a single slash denotes the root of the server. That is the default page or folder in the server, and the slash, whether or not you type it or not, is implicitly going to be there. And that just means give me the default. Whatever's at www.example.com, give me that page or that folder. But URLs can be longer than this. And more generally, there can be a path, so to speak. And this is a term of art. A path is some sequence of folder and or file names after a URL like this. And so you might see more specifically that a URL contains a very specific file. This isn't as common nowadays anymore, though we will begin today by using this technique. But if there is a file called literally file.html or something else on the server, that file is going to be what this URL pulls up on the computer. Meanwhile, you might have /folder/, which just means show me whatever's inside of this folder. Or you might have more verbosely /folder/file.html, which will show you that file in that folder. And meanwhile, just to give some other terms of art, this is the so-called fully qualified domain name. And again, these vocab words don't matter all that much, but you'll hear or see them over time. We generally, colloquially, just refer to this as the domain name, which is a little less precise, but gets the job done, certainly in conversation. And this part here, I described briefly earlier. What's the name for this suffix at the very end of the fully qualified domain name? Top level domain, or TLD. And this is just some form of categorization of the URLs. Now, the internet got its start within the United States, and a lot of the first websites, of course, came from the US. And so, for better or for worse, a sort of stake was planted in the ground. So generally, .com indicated, at least early on, that it was some kind of commercial enterprise, a business that owned a domain name. .edu is an educational institution. .net was some kind of network. .gov was the US government. Now, there are also country code TLDs, CCTLDs, like .uk or .jp. Every country in the world has its own two-letter TLD that might very well be restricted to only servers or companies or people in that country. Many of them can be used by anyone. You've used a lot of URLs in this class ending in cs50.io. That doesn't mean input, output. It actually is a TLD from another country that lets anyone on the internet pay for and on an annual basis using that domain. .tv, for instance, you might see in some cases, like twitch.tv and the like. That, too, is owned by another country that allows others in the English-speaking world, in this case, to use it as though it connotes TV. But those are just different types of TLDs that roughly categorize where the domain lives. But it doesn't necessarily mean it's commercial anymore. It doesn't necessarily mean it's a network anymore. For the most part, there are hundreds of TLDs now, for better or for worse, most of which are less common than these big ones. But most anyone can buy most of them, with just some restrictions on things like .edu and .gov that are still very much regulated. This, meanwhile, is what we might call the host name, www. It's obviously a super common convention. Like almost every website uses www as its host name. But that's a human convention. It's not a requirement. And indeed, some websites don't even bother having a host name. They just use their domain to advertise their website. This now is going to be the scheme or the protocol. And this is just going to indicate via what protocol the computer, your Mac, your PC, your phone, should use when accessing content at that address. Because indeed, there are other protocols you can use. But for the most part, we'll only focus on HTTP or equivalently HTTPS. All right. Any questions now on those just definitions, building blocks of URLs, just so we all sort of share a common vocabulary? Any questions at all? Yeah? Sure, we'll come back to this actually later today. There's a technical term known as localhost, which is a generic name for your computer, your Mac, your PC, your phone, especially when you're doing software development. And by convention, your own computer has not only whatever IP address you get from your university or your internet service provider, it also has a reflexive IP address, one that just always refers to itself, which is 127.0.0.1. And that's just a human convention. Humans decided that shall refer always to your computer. And it's actually going to be useful today and onward because we can use that when doing development on our own computers ultimately. Other questions on URLs, IP, DNS, or any of these building blocks? All right. So what do we mean by HTTP being a protocol? When I extended my hand earlier as a human handshake, you know, a typical human in healthy times would know to respond in turn. Well, how does Brian's computer know to respond to Phyllis's envelope, whatever message is therein? Well, assuming that Brian is indeed still a web server in the story, and Phyllis was trying to upload a cat or maybe download a cat from Brian's web server, inside of Phyllis's envelope would have been a message, literally in text, and it's English for the most part, and it would contain at the beginning of that message literally one of these English verbs, either get, which means just that, get me the home page, get me a picture of a cat, get me a picture of a dog or a video or anything else, or post, which often means post, that is upload a picture of a cat or a dog or something else to the server instead. That's not strictly the only use cases for these, but you can generally think them as one is just getting information and the other is posting from the client, from Phyllis to the server, in this case, Brian. So those are the two keywords that we might see. And why is this useful? Well, it turns out we can start to see in our own Mac or PC some of these very same messages. For instance, if Phyllis were visiting not Brian's, but example.com, that web server, inside of her metaphorical envelope, there would be a textual message that literally starts with get slash, then the word HTTP, then the version she's using. 1.1 is very common. 2 and 3 are becoming more common, but HTTP generally looks like this. The next line of text in her envelope would probably say host : then literally the fully qualified domain name of the server she's accessing, just in case, and this happens super commonly, especially on small websites, if one server is hosting multiple domain names, multiple websites, this just distinguishes which one she actually wants. And then there's usually a whole bunch of other lines of text as well. So where can you actually see this? Well, let me actually go ahead and do this. Give me just a moment, and I'm going to open up on my computer here an empty Chrome window in incognito mode. Generally speaking, incognito mode or private mode is used when you don't want there to be left remnants of what websites you visited, and it has the effect for software developers of just forgetting any things you might have tried already within your browser, including things called cookies, more on those another time, your autocomplete history and the like. So for development purposes, incognito mode is especially helpful because it's sort of like starting with a clean slate every time you open a new private or incognito mode. So there's not going to be like any remnants of previous testing or code that you've been playing with. And I'm going to go ahead and do this. I'm going to go ahead and right-click or control-click on Chrome. I'm going to choose Inspect, and it's going to pull up this window, sometimes on the side, sometimes on the bottom. I'm going to move it to the bottom just so we can see it a little more readily. And I'm going to zoom in. And it's going to look a little arcane at first. And I'm going to just highlight a few of these tabs. We'll see here along the top that there's elements, console, sources, network, and a whole bunch of other things as well. This is sort of the advanced mode in Chrome. And Safari and Firefox and Edge have their own equivalents of these features. They've always been there, even if you've never clicked the right button to enable these features. And I'm going to focus for a moment on network like this. This is a feature of the browser that's going to allow me, the programmer in this case, or the engineer, to just kind of look at what messages my browser is actually sending to a server. So let me go ahead and do something like this. Let me go ahead and visit, for instance, in my browser here. And I'm going to shrink the window just a little bit so we can see it exactly. I'm going to visit https://www.harvard.edu. And now I'm going to hit Enter. And a whole bunch of stuff just happened along the bottom of my screen. And I'm going to try to pull my window up just a little bit so we can focus on a subset of this. Let me pull this up, covering up really the content of the page, focusing on these lower level details down here. And what I want to see first is, let me go ahead and reload this page here after retaining the log so that we can see absolutely everything on the screen. And to be clear, I just checked because I forgot earlier, preserve log, because I wanted to preserve everything on the screen. I want to see everything all at once. And we'll see this. The very first line of output is completely overwhelming with detail at first glance. But what you'll see here, if I start to scroll down and down and down and down, are the so-called request headers. And let me zoom in here. And what you're seeing inside of Chrome, inside of its network tab, in its so-called developer tools, again, this is just for engineering types, you'll see all of the headers, all of the lines of text that magically were sent by my Mac to harvard.edu, much like from Phyllis to Brian's server in that story, so I can see exactly what messages are being sent. And a lot of this we haven't talked about yet, but we do see some mention of get, and we see some mention of slash, and a bunch of other arcane details. But notice they're all sort of key value pairs, with the colon here indicating what the corresponding value is. Now, most of this is not going to be interesting, and we're not going to focus too much on the weeds of all of this, but it indeed gives us a sense of what's inside of that virtual envelope. Now, harvard.edu is one thing, but there's other websites we might visit as well. And no matter what they are, we're going to expect ultimately an HTTP response. So in addition to a computer like my Mac or Phyllis's computer sending a request containing get and host and those details too, you'll see here in my slide form just representative response from the server. And notice that key here is that the server is responding in the same version of HTTP in this example. It's sending back this so-called status code, just a numeric code that indicates, in this case, that everything's OK. And it includes this header, this HTTP header, which again is just a key value pair saying that the type of this content that's coming back from the server is text/HTML. More on HTML in just a little bit. But for our purposes now, this just means that harvard.edu is sending me back a web page. And indeed, if we hide all of this technical stuff, that's the web page that we saw up here with all of the usual imagery and the like. And in fact, I can see this if I scroll back up, not to request headers, but response headers. You'll see up here that we get back responses, including the date that the server responded and a whole bunch of other details as well. And honestly, this has always been under your fingertips, and it will soon be useful as we start making web-based applications ultimately. But this very quickly gets overwhelming quickly. And so better than this might actually be a tool that we can use within our code space itself. So let me go back to VS Code here. I didn't open any code tabs. I'm just going to use my terminal window for a moment. And I'm going to run a couple of commands that are going to allow me to actually see what is going on when I request one website. Let me go ahead and use a command called curl for connect URL. And this is like a command line, black and white program that's going to pretend to be a browser. And it's going to connect to the URL, show me the headers, but it's not going to show me the images or the graphics, which might very well be useful to the humans, but not to me right now as the developer. So I'm going to do curl. I'm going to do -i. And then I'm going to do https://www.harvard.edu/ as though I'm pretending to be a browser requesting the home page. And what's nice about curl is, albeit overwhelming too, you'll get back a whole response from the server containing only those header values, the key value pairs inside of the envelope. And we'll ignore almost all of these, but here is the response from the server. It responded using a new and improved version of HTTP, in this case version 2, and it gave me back a 200. There's my content type, text/HTML, and then this char set happens to do with the encoding, if it's Unicode or ASCII or something else. And then there's all this other overwhelming detail for now. But this is the beginnings of my ability to just kind of poke around and see how the server works. And it turns out, too, that we'll be able to see other potential responses as well. So for instance, HTTP might not only return 100. What if I do this instead? Let me go ahead and visit curl-i http:// www.harvard.edu. So notice I deliberately use the insecure version of the URL, which maybe Harvard's administration, system administration doesn't like anymore. Well, how can they ensure that I, the end user, the student, nonetheless use HTTPS, even if I didn't type it myself? Well, let me run just that command with just HTTP, not HTTPS, and you'll see that everything is not OK. It didn't come back with a 200. It came back with 301 in this message saying Harvard moved permanently. But here's where you can look for another clue. Among all of these lines, most of which I don't care about, there's a location header, colon, that's a little hint to me that says where Harvard University has apparently moved to on the web. And what's different about this URL, just to be clear? It has the S included. And what your browser will do by default, because Google and Microsoft and Mozilla programmed it this way, whenever it sees a 301 response instead of 200, it won't show you any web page. It will look for a location header, find that URL, and then automatically, quote unquote, redirect you there too. So this is why it doesn't matter what we type in the browser. Harvard can have its server send these semi-secret messages to our browsers, and then it will just visit a second URL all automatically. And you can do this with host names as well. Suppose that Harvard does not want to standardize on harvard.edu. Why? They just want it to always be www. Maybe it's a branding thing. Maybe it's a technical thing. We can see the exact same response here. This first tells me when I visit http harvard.edu with no www, Harvard minimally wants me to be using a secure connection. If I then, OK, fine, cooperate, let me go ahead and clear my screen. Let me add the S, but not the www. You can see here that it again responded with a 301 up here. And the location now adds the www. So it's just a way of bouncing users from one place to another. And this is all thanks to HTTP boiling down to relatively simple messages inside of the envelope that tell the computer, the browser in this case, how to respond. Now, odds are you've seen others besides 301, even though you've probably never seen that actual number unless you've done this kind of thing before. But there probably is a number that like everyone in this room has seen, even if you've never really wondered, why is it that number? I think you're smiling. What number are you thinking of? Yeah, so 404. Why is 404? Well, 404 indicates, by convention, not found. And now why the world decided years ago to show us normal humans on the internet 404 is anything significant is unclear. That's sort of like bad design. Like, what do I care if the status code is 404? But it's common enough on the internet that probably all of us have seen it. But that just means that some server, when you visit a URL that's incorrect, maybe it's outdated, the URL has been changed, if you see a 404, it just means that the virtual envelope that came from the server back to your Mac or PC or phone contains not 200 OK, not 301 moved permanently, but 404 not found instead. And it's usually accompanied by a technical message, maybe a cute picture of a cat sort of hiding because it means not found or something like that. The aesthetics are entirely up to the server. But that's what the 404 means. And there's other codes too, a few of which you'll use in the coming weeks as we transition from command line programs in C and Python to web-based ones. We've seen a few of these already, and several of them are kind of variants of the same thing, like these 300 ones here. But we'll see others, like 403 forbidden means like you probably forgot to log in or you need to log in or something like that. Internal server error, right now, no. In the coming weeks, you will absolutely encounter 500 errors, and they're always your fault. It's going to be the equivalent of like a segmentation fault in C. A 500 error means like you or I screwed up when writing some code. So we're going to see that. But it's just going to be an opportunity for us to fix it. If a server's overloaded, you often see 503, like something's unavailable because something's too popular or is maybe worse, getting attacked. This is an old April Fool's joke. 418 is not actually used in practice, but someone like took the time to write up an entire formal technical proposal so that servers can respond saying, I'm a teapot. So it's kind of part of internet lore, and there's other ones of these status codes as well. But this is useful because eventually we'll see in code you can use this understanding, high level as it might be, of HTTP to do some interesting and powerful things. So for instance, we can even send fancier URLs to servers. It turns out, as we'll soon see, if you send a message like this, get/search Q equals cat, and then HTTP 1.1 or whatever version, and you send that message to Google server, www.google.com, this is how you can specify not just the path of a web page that you want, /search in this case. The question mark, it turns out, is going to be a convention in the internet, in the web specifically, for passing human user input to the server as well. In fact, you've probably never paid close attention to URLs, but they very often have question marks. They very often have equal signs. And indeed, even Google.com supports a certain key Q in this case for query, and you can put anything you want after that in order to search for actual cats. So if I actually go back to Chrome itself here for a moment, let me pull back open my Chrome browser here. Previously, I was using incognito mode for harvard.edu. I've gone ahead and closed that window and opened a new one so we can start fresh by visiting Google. Normally, you and I are in the habit of going to google.com and searching via the form. Or nowadays, you just type like your search query in the browser itself, and it brings you automatically to Google or Bing or something else. But I can really be pedantic here. Let me go ahead and zoom in, and I'll manually go to https://www.google.com/search. Question mark Q equals maybe cats. Now, this would not be a very user-friendly experience if all of us had to manually type out something crazy like that. But that's what the form is redirecting you to when you type in more user-friendly cats into like a text box. If I hit enter here, we'll get back, indeed, a whole bunch of search results about cats. If I zoom back in and maybe I change it from cats to dogs, that too is going to change. And notice it's pre-populating the text box because Google has written its code in order to do so as well. Now, apropos of the video with which we began today from yesteryear, one of the better Yale pranks over the years, has anyone actually ever been to safetyschool.org? And to our friends at Yale watching live, hi. Safetyschool.org. So it's kind of fun if you actually visit it, depending on who you are. So if I open up a new window here and I go to http://safetyschool.org, zooming in, enter, my oh my. Look at where it goes. Now, how does that, OK, thank you. This is not a CS50 thing. Someone out there who I don't know who they are for like 20 years has been paying annually for that domain, safetyschool.org, for just this joke. But if I now go back into VS Code here in my terminal window and a little more, sophisticatedly, let me do curl-i http://safetyschool.org. The browser, of course, immediately redirected me to the website. But what's going on underneath the hood? Well, 20-some years ago, someone bought the domain, configured the server quite simply to spit this out. Safetyschool.org for years has moved permanently to www.yale.edu. So just a little demonstration of what you can do with just a little bit of understanding of HTTP. That's been a lot already. We've laid the foundation for understanding how the internet works. Now we're going to use it with a language called HTML, hypertext markup language, CSS, cascading style sheets, and JavaScript, a proper programming language. But first, it feels opportune to take a 10-minute break. We have some wonderful Halloween candy in the transept, and we'll be back in 10 with those languages.
We're headed up to Boston, checking out the stadium for the prank. A few years ago, I was at a math conference, and I was sitting around at a table at dinner with a few other mathematicians. And one of them went to Harvard and started telling the story of this amazing prank that was, against Harvard. And at that point, I felt I had to interrupt and said, well, actually, I can tell you a lot more about that.
Okay.
The idea was perfected in a dorm room.
Came up with the idea, actually, to prank them with signs at the football game. We threw some ideas out there as far as what the signs would say. We eventually settled on "We suck."
And my immediate reaction was, no, this will never work. However, the problem solver in me started thinking, well, maybe we can make this work.
Problem? They had to infiltrate Harvard Stadium without getting caught, sneak in 1,800 placards, distribute them to unsuspecting Harvard fans, and then convince those fans to prank themselves.
That's great. We thought about basically every possible thing that could go wrong and tried to come up with a solution for it.
And then you put 2 reds on top of it.
They made fake Harvard IDs and fake backstories, fake placard designs, and a 28-member fake pep squad. On November 20th, 2004, the fake Harvard students smuggled the placards into the game.
What do you think of Yale, sir?
But then, trouble.
What houses?
How many extras? Sometimes.
Yeah.
No,
just showed him the front of this ID, and all of a sudden he just ran away, and he felt so embarrassed.
Having escaped one confrontation, they couldn't risk another. It was time.
This just looks like a total mess. We have absolutely no idea if this is going to work.
Look at them, they have the over. It's gonna happen. It's actually gonna happen. I can't believe this.
What was once a prank became a legend.
And immediately we started hearing chants from the other side, "You suck." And I think it was at that point in time that we knew we had pulled it off.
There it goes again!
I really think it didn't matter that Harvard won because of the prank. For a lot of Yale students and alumni, we definitely won that year.
Thank you all. Okay, thank you. Oh, here. Oh, all right. Here. A little Halloween candy. All right. Thank you all. So glad I wore the same thing today. So, in just a moment. Thank you. Okay, so in just a moment, we'll transition to understanding all the more now what we can do with this underlying infrastructure. So again, HTTP and below it TCP IP is all about just getting the data from point A to point B in some standardized way. But now let's talk about HTML. This is the language in which web pages themselves are written, hypertext markup language. Now, some of you might have used this before to make personal home pages. Some of you might have dabbled, even if using some website to create your own home page. But understanding this language is useful certainly for creating the aesthetics of a web page, conveying data that's of interest. But at the end of the day, it and the language we'll look at next, CSS, are not programming languages. There's going to be no functions, no loops, no programming logic. But we will end today with a teaser of a proper programming language called JavaScript, via which you can manipulate all of these various other languages as well. So ultimately, HTML has like two features. And this is a language that we spend very brief amount of time on because it really boils down to just a couple of basic ideas and then vocabulary that you'll build out over time just by Googling, looking up references, looking at other pages, source code. But tags and attributes are what characterize HTML. Now, what do I mean by that? Here, for instance, is the HTML code via which you can make probably the simplest of all web pages, one that quite simply says in the browser window, hello title and hello body, for instance. Now, what does this actually mean? If you imagine opening up this code in a browser, be it on a Mac or PC or phone, you'll see typically like some kind of rectangular window, and there's usually a tab that has the title of that page, and then most of the rectangular region is the web page itself. What you're looking at then is the code that's going to put hello title in the title bar, in the tab at the very top, and down at the bottom, hello body is going to be all that's in the big black and white box that composes the rest of the browser window itself. Now, what are the salient characteristics here that we'll now start to take for granted? Well, first, let's go ahead and give me just a moment here and actually do something with this code. So I'm going to go ahead and do this. Back in VS Code here, I'm going to first create a file called, say, hello.html. And in this tab, I'm going to go ahead and really repeat exactly that same code. Now, I had this line first, doctype HTML. Then I had this line, HTML lang equals quote unquote en, close quote. Then I had inside of that head. Then I had inside of that title. Then inside of that, I had hello title. And I'm doing this quickly because we'll tease apart in a moment what it actually all means. And then down here, below that so-called head, I had just the text hello body. So at the moment, that I claim is the entirety of a web page. But it currently lives in my code space, so to speak, in a file called hello.html. That's fine if I want to create it, but how do you, how does anyone on the internet actually view it? Well, to serve a web page, you indeed need a web server. And it turns out that Codespaces comes with one of these pre-installed because we, CS50 staff, did so for you. And what you can do in a terminal window, once you have an HTML file ready to go that you want the world to see, you can literally run in your terminal window http-server. Single command. And what that's going to do for you is start a web server. That is to say, a program whose purpose in life is just to serve web pages. And even though probably up until now for years, you probably, if you're like me, equate server, quote unquote, with a physical device, server is really a piece of software. It just tends to run on big fancy devices. So when we say server, we often all think of, in our mind's eye, big expensive devices perhaps. But a server is just a program whose purpose in life is to respond to requests with responses. And that's the vernacular there. Now, once you run HTTP server, and I'm going to do a bit of magic because I set this up before class just to make sure it goes smoothly, you'll see some output like this, whereby your server is now available on a very long URL. Mine here is a very long URL that will be different from yours. But what this is a unique identifier that your code space has temporarily generated so that you can now access, and ideally only you can access, that file using your browser. Now, if I flip the URL or you flip the URL to public by right-clicking or control-clicking the right features of VS Code, you can enable anyone in the world to visit it. But we're not going to ultimately host our websites in your code space because as soon as you log off for the night and the thing shuts down, like the website will go down. But at the end of the semester, particularly for final projects, we'll show you ways that you can put your own website, your own code on the actual internet 24/7, 365, even with your own domain name if you want to get one, so that it lives independent of your own sleep schedule and usage schedule of VS Code here. So I'm going to go ahead now and visit this URL in another tab of my browser. And what I'll see here is this. This is the output of that program called HTTP server. And essentially what it is doing is it's using TCP and IP in conjunction with HTTP to just run your very own web server on GitHub's own servers as well. And that's because of different ports. Again, we won't go too much into the weeds of the TCP, the IP, and all of that stuff. But recall that different port numbers can allow you to distinguish one service from another. Now, one of the services is, of course, your code space, VS Code in the cloud that we've been using for weeks. But if you want to use the same physical server that GitHub controls, but actually visit your own web server that I just ran in my terminal window in another tab, that's fine. They're just going to be using different TCP ports. And you and I don't have to care what they are, but just that this is a feature that TCP supports. So what you see here is somewhat arcane. This is not like a thing that most people on the internet should ever see. I'm just doing this for development purposes. But this is the index, that is, the directory, the folder contents of my code space. And because I deleted everything from prior weeks already, all we see right now is hello.html, which I just created. So if I click on hello.html, within this folder listing, you'll be a little underwhelmed. And I'll zoom in just so there's something more interesting there. But now you see hello, comma, body. But what's interesting, perhaps, is that after this long, very cryptic and uninteresting URL, notice at the very end of it, and I'll zoom in a moment, what do you see? /hello.html, which follows the convention I claimed before break is how a browser would allow you to access a specific file on a server by doing / and then the name of the file name. Everything before it is very cryptic. It would be better if I buy a domain name that's a little more easy to remember and set that up some other time. But for now, let's just focus on only the file names that I'm actually creating. All right. So the code is up and running, underwhelming though it might be, with the body in the middle of the page. And let me zoom in up here too. Hello, comma, title is indeed in the tab, just as promised. So what's actually going on with code like this that we just created? Well, let's go back to the slide version of the same. And let me just highlight a few of these lines. The very first line is what's called your document type declaration. It doesn't really matter to remember that by phrasing. And this is just something you copy, paste, or do from memory at the top of any .html file that you create when making your own web page. It's an implicit indicator to the browser that you're using the very latest version of HTML HTML, which is version 5. You don't mention the number 5. Just browsers nowadays are programmed to look for this to know that you're using the very latest version of the language. Languages, just like human languages, evolve over time. We're up to version 5 of HTML, but new features get added every few years. So indeed, this lecture, this class, has been evolving over time too. So let's now focus on the next line as well as the bottom line. And you'll notice some deliberate symmetry here. This here is what we're going to call a tag. And it's technically different from this. This is a document type declaration. It's got the weird exclamation point. That's the only anomaly. Everything else follows a pattern. This is a tag in HTML, and it's the HTML tag. And a tag generally both starts and stops, or opens and closes at some point. So this is the so-called start tag or open tag. And this just means essentially to the browser, hey, browser, here comes some HTML, the language in which web pages are written. This here, with the / after the angled bracket, means, hey, browser, that's it for the HTML of this page. So that's what I mean by symmetry. I started a thought here, finished it down here. What's in between those two thoughts? Well, here, browser, or rather, let me clarify one thing. This thing here is that other keyword, an attribute. An attribute is something that modifies the behavior of a tag. So it's similar to an argument in C or in Python, like a parameter to a function. These aren't functions, but it's the same idea. It just modifies the default behavior of something instead. Lang equals en, you can probably guess, just means that, hey, browser, assume that everything hereafter is in English. And that might be useful for like Google Translate or just search engine optimization, so that just the server, the browser know like what human language you have actual content in, like hello title, hello body, even though a good computer can probably infer from context often. All right, so that's an attribute. That's a tag. And the whole thing here, everything in between the start tag and end tag, we would also call an HTML element. That just means everything related to that open and close tag. All right, now notice, indented inside of, so to speak, the HTML open and close tag are another pair of tags, the head tag and the body tag, or the head element collectively and the body element collectively. And same idea. Hey, browser, here comes the head of my page. Hey, browser, that's it for the head. Hey, browser, here comes the body of my page. Hey, browser, that's it for the body. The head is essentially the tiny little strip at the very top, including the tab itself. The body is like 95% of everything else, the big rectangular region. What's inside of your title of your head? Of the web page, at the moment, just the title. So this indicates, hey, browser, here comes my title. Hey, browser, that's it for the title. The title, of course, is literally, quote unquote, hello, comma, title. Meanwhile, if we bounce back out, here is the second element inside of the HTML tag. This says, hey, browser, here comes the body. Hey, browser, that's it for the body. And hey, browser, this is the contents. These are the contents of the body itself. Now, the indentation is a stylistic thing. I did it just to be sort of neat and tidy because it suggests what is inside of what. But it also suggests a sort of hierarchy. And in fact, we'll use terminology from like the world of family trees. If this is like a parent, so to speak, head and body would be the child elements of the HTML tag. Meanwhile, title is a child of the head tag, or equivalently, title is a grandchild of HTML. So you can use the same sort of vernacular as in the human world when it comes to familial relationships too. And that just hints at, again, this same hierarchy. So we have tags, and they include HTML, head, title, body, and that's it for now. We have attributes. We've seen one example of them, lang. But we'll see many other examples of the same idea. But these building blocks are exactly the same. Generally, you start a thought, you finish a thought, and you might do something in between. Questions on this basic structure of any web page? Any questions at all? No? All right. So let's now allow things to ramp up a little more interestingly and do something with these building blocks. But so that you have a mental model for everything that's going on here on after, think of this same HTML being related in spirit to week 5 when we talked all about data structures. If I really wanted to, I could take to heart this idea of children and parents and grandparents and really depict this thing graphically. And in fact, this tree here, if you will, and it's not a binary tree, it's not a binary search tree, it's just a tree, using week 5's terminology. If this special node here represents the whole document, well, the root element, as I called it, is HTML. HTML has two children, head and body. The head tag has, in turn, a title child, and in turn has some text, just as the body has some text. And so this is what your browser is doing. You and I, the programmers, write this stuff. The browser reads this code top to bottom, left to right, whenever you visit a website. And inside of the computer's memory, Chrome, Edge, Firefox, Safari, whatnot, they build this data structure in the computer's memory so as to know what it is you have told them to do. And we'll see over time, at the end of today, you can write code in an actual programming language, JavaScript, to maybe dynamically add or remove things from this tree. And this is how things like Gmail work. When you open up your Gmail inbox, if you're a Gmail user, if you just stay there long enough, you'll probably get more and more mail. And what happens? You don't have to like reload the page or rebuild the tree per se. It just all of a sudden appears at the top, at the top, at the top. What's happening there is that Google wrote some code that just keeps adding more nodes to this tree every time they realize you've got a new message again and again. So that's the relationship now, even with this world of HTML, with all of the programmatic ideas we looked at in the past. All right, so let's go ahead and do something with this that's a little more interesting than just hello itself. I'm going to go ahead and hide my terminal window because the server is now running. And all I want to do now is experiment with hello and other examples as well. Let me go ahead and, actually, before I do that, let me go ahead and run code of paragraphs.html just so I can keep my code separate. And now I'll hide the terminal window again. Paragraphs.html, I'm going to do almost exactly the same. Let me go ahead and start with something familiar. And eventually I'll start copying and pasting just to save time. So doc type HTML is always there. Open the HTML tag. And now notice, I didn't type the rest of that. Just like with C, just like with Python, we try to save you some keystrokes by closing parentheses, adding quotes. The HTML support in VS Code is pretty good too, and it tries to finish your thought when it comes to tags as well. It can screw things up if it does something you don't want it to do, so sometimes you have to delete, but it's just autocomplete, as we've seen before. Let's go ahead and let me add lang equals en, as all of my examples today will be. Let's add the head tag. Let's go and proactively add the body tag. And now let's go ahead and give this a title tag, which has a, I'll just call this paragraphs, just so I remember which example is what. Now notice all of this white space and all of this neat and tidy indentation, the browser ultimately is not going to care about. This is just for us humans to kind of keep ourselves sane. When we look at the code, it's just easier to read. But strictly speaking, I could minimally delete all of this white space, and I could just move all of this tag up to the same line. Both, I think, are fine. I'm just going to follow a certain convention. But this, too, would have the exact same meaning. But we'll see where that detail about white space could potentially get us into trouble later. In my paragraphs tag, let's do this. In advance, I've written up some Latin-like text, a really long paragraph of Latin-like text like this. It's actually random nonsense. It's not real Latin, even though a couple of the words might look familiar. And so here we have 3 paragraphs of text. And I've deliberately hit Enter in between them so that just like an essay in Google Docs or Microsoft Word, hopefully I'll see 3 separate paragraphs. Let me now change tabs. And I'll close hello.html from before. I'm going to go back to my other tab here. I'm going to click back to go back to that index of all of my files, which I started at earlier. And you'll see now that I have 2 files, because I obviously just created a second file called paragraphs.html. So let's click on this to see our 3 paragraphs of Latin-like text. And voila, I'll zoom out. All right, first bug, if you will. This just looks like one massive blob of text, not 3 blobs of text. And why might that be? Borrowing the hint I offered a moment ago. Why are we not seeing break? Yeah, so we need some kind of line breaks here because the browser, turns out, is only going to take us literally. And if you just give it text, 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 it's just going to show you text. And anytime there's more than a single white space, whether it's 2 or 20 or 200, it's going to just assume that you did that just to be neat and tidy, and it's going to collapse them into just one space visually, like this. So there are, in fact, a couple of solutions. One is this here. I could add some explicit line breaks. And it turns out that there's a BR tag like this. And just for visibility's sake, let me do 2 of them. So like hitting Enter, Enter on my keyboard. I'll do it here too, BR for break, break. And now let me go back to my other tab. Nothing's changed yet, but that's because I have to reload. I've changed it on the server, but now I need to change it in the browser by reloading. And now it looks a little better, albeit nonsensical. But you'll notice a curiosity. Per this BR tag, this is kind of poorly designed. It's a little hackish to just say enter, enter, and make the browser do this. breaks, line breaks, don't actually require close tags or end tags. So not all tags need to be closed, at least those that it just makes no semantic sense to close them, right? Like the break is there or it's not. You can't imagine like starting to move to the next line and then eventually getting around to finishing. Like it's either there or it's not. So some tags do not have close tags as necessary. But there's a more elegant way here, I dare say, not just sort of hackishly putting in these line breaks. Let me do this instead. I'll delete those. And let me go ahead and, as the name of this file suggests, let me add a paragraph tag. Now here I need to fight with VS Code's autocomplete because I don't want to finish the sentence, the thought there. Let me go ahead and open the paragraph tag and close a paragraph tag. And just to keep things tidy, I'll go ahead and indent too, even though the indentation itself doesn't matter. Let me go ahead and create another tag for opening this paragraph. And I'll close this one here. And now let me see, sometimes it's fighting with my autocomplete, but that's fine because I did this sort of the wrong way at first. And now let me go ahead and finish this thought by closing this paragraph tag here. And I've manually fixed all of my indentation. So now on line 10, I have the equivalent of, hey, browser, start a paragraph. And then it does the Latin-like text. Then on line 12, hey, browser, that's it for this paragraph. And repeat, repeat. If I now go back to my other tab, and reload again, shouldn't be all that different, but semantically, it's a little bit better. Why? Because just saying break, break doesn't really mean anything. But by saying paragraph, 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 now there's some more semantic information there. Now if like Google is analyzing your page, or if the programmer is trying to understand what it is you did in the past when writing this code, you just know semantically, oh, this is a paragraph, this is a paragraph, this is a paragraph, just like in a book or an essay. So it's a little more clear, focusing more on what it is, not how you want to display it. Any questions then on these paragraphs? Now, all right, so a few more tags. And indeed, these first few examples will really just be like sort of bang, 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 just a bunch of different vocabulary words in the form of these new tags. But we won't go through the entire laundry list of tags. This is indeed the thing for which web references and books and the like are ultimately helpful, just like a dictionary in the real world. So I'm going to go ahead and do this. Let me go ahead and copy this. Let me create a new file called headings.html, just so we have a new file for this. To save time, I'm just going to paste that exact same code just to get me started. I'm going to change the title of it for clarity, for the code online, to headings. And now, just like a book or an essay or a thesis, let me actually put some actual headings here. Now, if my first heading, like chapter 1, I could do something like this up here. I could have a paragraph, like I just learned, and I could say something like chapter 1 here. But that's not really a paragraph, and so it's sort of better designed to tell the browser and really tell the world what it is. So it turns out there's another tag I can use, like h1, for heading and like most important heading. And in here, I'm just going to keep it simple, and I'm going to say something like 1. And in fact, this is so short. Here's a good candidate for just keeping this all on the same line. But this has no functional difference, but it'll just make it a little more terse on the screen. Now let me go ahead down here. And I could have multiple headings, so h1, 2. And down here, I could have another one, h1, 3. And if I go back to my other tab, I reload it now, we should see, just like a book or an essay, now we have some proper, oops, I have to go to the right file, sorry. If I go back to the index, now we see the new third file called headings.html. And now we indeed see some fairly pretty, if simple, headings as well. Now, if these aren't 3 chapters, 1, 2, 3, but maybe it's a chapter, then a section, then a subsection, such that just visually you want things to get smaller and smaller, well, those exist too. And in fact, you can do h1 through h6. h1, a little paradoxically, is the biggest and boldest. h6 is the smallest, but still bold. So it might make sense to make this h2 both open and close, and maybe this h3 open and close if, again, this is a section or a subsection inside of that chapter. If I reload now, notice, it just gets a little smaller. So it's more similar to what you'd see on the printed page. But this now is just another 3 tags that I might use in my own code. All right, well, how about lists of things? I have 3 paragraphs here, but let's do this. Let me go back to VS Code. I'm going to copy this code so I have a starting point. I'm going to create a new file called, say, list.html. Here, I'm going to copy paste. I'm going to change my title to be list, just for clarity. And in here, I'm going to go ahead and get rid of this whole body, because let's move away from these massive paragraphs and keep it simpler for now. If I want to have a list of things, for instance, if you haven't seen these already, a computer scientist, when they're fishing for just some arbitrary, meaningless words, they often use foo, bar, and baz, just as their go-to, just like a mathematician might use x, y, z for variables. So foo, bar, and baz are on 3 separate lines, and maybe this is like my to-do list or my shopping list. But you can probably imagine if I go back to my other tab, go back to the index, I now see my new file, list.html, but it's probably going to look wrong. I think I'm just going to say, yeah, foo, bar, baz, all in one breath, if you will. They're not on new lines. And you can try to fight this. Like, you can be like, really want to put some line breaks there, go back and reload. It's still not going to make any change. How do I want to fix this? Well, I can do this in a few ways. I could make them paragraphs, but they're not really paragraphs. They're a list. So I'm going to use a different tag instead. I'm going to create, for instance, an unordered list using the ul tag, open and close. Inside of that, I'm going to use the list item tag, li, and I'm going to say foo. Inside of another tag, I'm going to say bar. Inside of a third tag, open and close, I'm going to say baz. So it's getting a little verbose, but it's still relatively succinct. Li is all you need type for list item. Ul is all you need type for unordered list. So there's some shorthand syntax here that's adopted. If I now reload, you're going to see a so-called unordered list, like not sorted, which means by convention to show it as bullets, though it could be displayed in different ways visually as well. If you actually change your mind and you realize, oh, I'd really like to number this, well, you could obviously like just add 1 and 2 and 3, but that's going to get annoying, especially if the list grows. You want to change something, insert something in the middle, then you have to reorder it. I mean, we're using computers here. They can do this for us. So we can change the ul to, any guesses? OL, maybe, for ordered list, which is sort of the opposite here. So let's try changing that to OL. Let me go back to my browser. And I'm just hitting Command R or Control R to reload the page instead of clicking the button every time. Now, I automatically get 1, 2, and 3. And you can even override the aesthetics using different numerables or symbology instead. But that would be perhaps the most common there as well. All right. It's a lot of tags quickly, but any questions on lists, paragraphs, headings, or the like? No? All right. So let me go ahead and propose this here. Let's go ahead and create what we'll call a table. So let me copy and paste this into a new file, code of table.html. And in table.html, let me again rename the title to table. Let me get rid of that ordered list from before. And let me now use a table tag, open and close. This one's a little weird, but inside of a table, you typically have a head of the table. So I'll say, well, let's say the first row. We'll keep this one simple. A table row, or tr. Inside of a table row, you would ideally have columns, but that's not the nomenclature. Instead, you have data. So td for table data. And let me go ahead and just have the first datum be 1. I'm just going to arbitrarily do 1, 2, 3, just so we have something to play with. And you know what? Just for demonstration's sake, I am going to deliberately copy paste this twice. And I'm just going to manually change the numbers, just so we can see what I'm creating. 7, 8, 9. And then maybe just for good measure, if you're seeing where this is going, let me copy this one more time and give myself a final row with an asterisk, a 0, and a pound sign, if maybe you see where this is going. Let me go back to my other tab. Let me go back to the index. There's my new file, table.html. I'll click that. And while it's not very pretty, I'll zoom in. It's indeed a table of data. I happen to mimic like a telephone keypad, but you could imagine this being much juicier, much more interesting scientific or financial data or the like laid out into these rows, TRs, and these columns, aka table data as well. So we have that ability as well for structured data. Now, of course, the internet has lots of images on it. And in fact, this is all just text. How can we introduce images? Well, let me go ahead and do this. Let me first sort of semi-secretly copy an image file that I brought from earlier, just so we have something to play with. And I have in my account here now an image called harvard.jpg. And I uploaded this semi-secretly a second ago into my account so that I can reference a second file. Let me go ahead and copy this HTML just to save myself some keystrokes. Let me go ahead and do code of image.html. And let me paste that code and hide my terminal window. I'm going to get rid of all of this table as just uninteresting now. We're going to make this even simpler by changing my title to image to keep all these demonstrations separate. And now, if I want to make a web page that when visited shows us a picture of Harvard, well, there's an image tag, abbreviated IMG for short. I can specify what the source of that image is. And if my file, a JPEG in this case, is literally in the same folder, I can just say, quote unquote, harvard.jpg. If it's in a folder, I should mention the folder name and a slash or something like that. If the image is on the internet somewhere with a URL, I could also have a whole URL, https:// and then the URL of the image. But I upload it in advance. Now, this is just going to visually display on the screen, but not everyone, of course, can see images. Screen readers might need a bit of assistance, and even search engines might want to analyze the page and know what this is an image of. Now, machine learning and artificial intelligence are maybe getting better, to be fair, at figuring out just by analyzing images what they are, but they're certainly imperfect. I am a human. I know pretty well what I took a photo of, for instance. So maybe what I should do proactively, which would be good for accessibility, is have this alt tag for alternative text, and then literally say like Harvard University, so that someone who can't see or so that a server can actually know with higher probability what it is they're looking at. And I could be even more detailed than just a phrase. I could describe the image as well. All right, let me go back to my index in the second tab. Let me go back and zoom back out. There's my new file, and there's my new JPEG that I quickly uploaded before. I can click now on image.html, and albeit a little overwhelming, that is a really big image of Harvard. Now, apparently, it's too big to fit on the screen, so this isn't the best user experience to have to scroll up. OK, so there's the image. Horrible, horrible design, if you will, at least in terms of my code. But there's going to be ways where I can sort of rein that in and affect the height or the width as well. But for now, it's just deliberately a little overwhelming instead. Now, we can do something a little more fun and topical today, which might be to use a video instead. So let me go ahead here and very quickly grab another file today, which is I brought in advance, and then you might have seen briefly earlier, which is an MP4, an actual video file. And what I'm going to do here, by revealing VS Code again, is I'm going to code a file called video.html. Yet another demonstration here. I'm going to change my title to video, just to keep these things straight. And instead of the image tag, you might imagine using now, indeed, a video tag. And this is a relatively newer tag that has increasing support among browsers, so it's good now to use. And inside of this, the syntax is a little different. You specify, and this is weirdly, annoyingly inconsistent, not src for source. You literally say source. And then in source, you use a source attribute. Horrible design semantically, but like this is what we're stuck with. Halloween.mp4 is the name of the video we upload in advance, made by some of Harvard's digital artists. And the type of this video, so that the browser knows for sure, is video/mp4. That's a so-called content type that you just know or you look up to figure it out. And just so that this is as animated as possible, I'm going to tell the video tag with a few attributes to autoplay. And it turns out that attributes often have key value pairs, whereby it's the key, the attribute name, equals quote unquote some value, just like lang equals quote unquote en for English. But not all attributes need values. In fact, if you read the documentation for HTML's video tag, there's an autoplay attribute where you can literally just say the key and it needs no value. It's just going to mean autoplay. And if you don't want to autoplay, you just omit it altogether. So you don't necessarily need a value on or off. I want the thing to loop just so it keeps going. I want it to be muted so that we don't hear any sound. In fact, there is no sound, but browsers nowadays, for anti-spam and advertising reasons, often will not play a video if it has sound, because it's just kind of obnoxious if you visit a page and all of a sudden your speakers start blaring. So I know this from having read up on this, that I should mute it so that if I want it to actually autoplay for real. And then I'll set the width manually for now to be like 128 pixels across, just from some trial and error earlier. And that width attribute does have a value. Now I'm being a little uptight here by alphabetizing all of my attributes. Not at all necessary. I do it just so I can skim things faster and know if something is there or not. So for me, it's just a matter of style. Let me go back to my other tab, go back to my index, and you'll see two new files again, the MP4 file and video.html. I'll click on the latter. And if I did this well, here we have, thanks to our friends in Harvard, our artistic friends at Harvard, very Like an ooh would help with the drama here. But OK, but we have a very dramatic, nice Halloween type view here as well. So we have videos embedded as well. And suffice it to say, there's ways to embed YouTube videos or Vimeo or other services as well using yet more tags too. But the web is, of course, all about hyperlink, hypertext markup language, where you click on something and you end up somewhere else. And this is how the web is so powerfully interconnected. So how do we start creating links from one website or web page to another, either that I made or someone else? Well, let me go ahead and open back up my terminal window. And let's create a file called link.html just to demonstrate what you and I know as a link. I'll hide my terminal window now. Let me copy paste just to save myself some keystrokes. And let me get rid of the video tag so we can focus now on links. Suppose that I want you to visit Harvard virtually. Well, I could say something like visit Harvard, period. This is uninteresting because it's just going to be text. I probably want you to actually visit harvard.edu instead, more specifically. And I'll lowercase it just to be consistent with what browsers do in the address bar. All right, let me go now to the video, back to this video tab and go back where we now see my index. I'll zoom back in, and there's link.html. Unfortunately, when I click this, and I'll zoom in, you literally just see the text that I wrote. And yet, on every social media platform nowadays, except like Instagram, when you type a URL or what looks like a URL, even if you didn't bother with the HTTP or HTTPS, it usually automatically links it for you on Facebook, on Twitter, and other sites as well. That's just a convenience. Discord and Slack do that too, but they're just doing it to make things more user-friendly. But they have to generate HTML with the proper tags and attributes. So to get this to actually work, it's not even good enough to say https://www.harvard.edu, because if I go back now and reload now, you'll literally just see all of that as text. If you want the browser to treat this as a link, you need to use the anchor tag. It'd be great if it were called the link tag, but it's not. It's called the anchor tag, or A for short. And the way you reference the URL to which you want to lead the user is via href, for hyperreference. This is one of the earliest tags, perhaps among the most arcane now. But if I then put that whole URL in quotes and close my tag, I now have an opportunity to finish my thought in between the start tag and the end tag for this anchor. And what I put in between the start and end tag is whatever the human's going to see. So here I can say Harvard. I can go back to my other tab. I can reload the page. And now you see the familiar blue underline. This now is an actual link. And if I click it, I'll be whisked away to the actual Harvard website. But there's a risk here. Can anyone imagine, pretty simply, after like, 60 seconds of the of the anchor tag, how could someone, an adversary, misuse this tag alone? How could a website run by an adversary, how could a spammer misuse this tag, do you think? Yeah. Yeah, absolutely. You could have it say one thing but lead elsewhere. So I could say Yale in here. Nothing's stopping me as the developer. Go back to the page, reload. Now it says visit Yale. You click on Yale, and voila, you end up applying to the wrong place instead. Now there's some hints of this. I could hover over this, and super small, like this isn't very good for your anti-hacking techniques, but way down here you can actually see the URL that it's going to go to, and most browsers indeed do this, at least on desktops and laptops, so it's a little bit of a hint. But what you're seeing here, even though this is kind of a silly, playful example, this is exactly how phishing attacks work, phishing work, whereby an adversary tells you to log into your PayPal account, but it doesn't go to paypal.com. It goes to some other random website that they bought and built that then tries to collect your username and password and store it in their database, so now they can log into your PayPal account as you. And it boils down to that simple primitive. And you can be even more manipulative too. You can even say the whole URL for Yale, like yale.edu, or worse, https://www.yale.edu. Reload that, and now who among you and people in your lives are necessarily going to be so paranoid as to not just blindly click on that URL? This is why just being a defensive, real-world person nowadays digitally is just ever more so important. So these same things that can be used for good or benign use cases can also be used for ill purposes too. And it is literally that simple. Questions now on any of these tags thus far? Just a few more to offer up. Any questions on this here? No? Well, let me open up a couple couple that I brought in advance just so we don't have to type all of them here. If you, for instance, have a web page that's got quite a bit of code, let me go ahead and grab from the website a couple of examples real fast here, namely one that we'll call, how about meta.html. And in this example here, give me just a moment to full screen it, we're going to have a file. So code meta.html. I'll open this up next. No relationship to what we now know as Meta, the company, but rather this is going to be a page that I copied and pasted the same chunk of Latin-like text from earlier. So it's going to be a really big paragraph of text. And this is an example where if you were to open this web page, not on my own Mac or your PC, but on your phone, the font might actually be really annoying and difficult to read. Why? Because your phone's going to try to squeeze all of the content onto the tiny viewport, the rectangular region of your phone instead. So it turns out there are ways, pretty easy ways, to make your website mobile friendly as well, otherwise known technically as responsive. And the easiest way to do this is to include this tag here, a meta tag. Again, no relationship to Facebook. This has been here much longer. And in this case here, this meta tag on line 5 has its own sort of approach to key value pairs. This is a good example of where it'd be nice if it looked just like everything else, but this is what we have historically. You can have a meta tag with an attribute called name that refers to the name of some feature of the browser. In this case, viewport is the technical term for like the big rectangular region to which I keep referring, the body really of your page. The content for the viewport, you can say some esoteric details like this. The initial scale should be 1. That is, no matter who visits your site, it shouldn't start zoomed in. It shouldn't start zoomed out. It should start at just the default sizing. And then this here, width equals device width, is a very arcane way of saying if the user has a small screen, show the text proportional to that size. Don't just try to cram it all into a tiny little window. So it's super simple. But if, for the next problem set or future projects as well, you find that just things look really bad on mobile, like this kind of tag is the place to start Meta. There aren't terribly many of these that you'll use, but they're useful for other mechanisms as well. In fact, let me go ahead and semi-secretly pull up one other example as well, whereby I'm going to grab another example that uses more of these tags. And in just a moment, I'll reveal it here. Give me just 1 second here. I'll propose that in this example of Meta, we now add these properties instead. So I copy pasted this from an existing file just so as to not waste time typing all of these out. If you've ever shared a URL on Facebook or Twitter or Slack or Discord or any number of websites nowadays that automatically show a nice preview where you suddenly see like the default image of the page, maybe a few sentences or words of text or something like that, sometimes those applications, those websites, will just choose like the first image it finds on the website or the first sentence it sees and show that. But that might not be very user-friendly or search engine friendly. And so a developer might want to control what it is that Slack, Discord, Facebook, Twitter, and other such sites show by default. For that, you can use nowadays what are called open graph tags, which is to say there's other uses of the meta tag. And you just look these things up. Even I had to look this up to remember what the key value pairs are. The meta tag can also have a property attribute that can be these very specific strings: OG title, OG description, OG image, which denotes open graph, which again is this standard that's evolved in recent years. And what you can do here is tell browsers and in turn servers what you want them to show as the default title of the page, the description of the page, and even the default image, just so you can exercise more control when sharing things socially nowadays as well. Again, it just boils down to these key value pairs. This is absolutely the kind of thing you look up as needed to cross-check, but those capabilities are there. And so literally, the next time you paste a link into Slack or Discord or any online site that then displays it in embedded fashion, just know that all this time, a little bit of textual code like this in HTML has been there by whoever authored the site. All right, let's do one final example in HTML alone before we transition to just cleaning up the aesthetics and improving the visuals of everything we've been creating. Let me go ahead here and close meta.html. Let me code up a new file called how about search.html and see if we can't draw some inspiration from our cursory understanding earlier of how URLs work to see if we can't reinvent google.com itself. So recall that a canonical URL might look like this here. And in particular, if you want to pass in user input to that URL, again, you can potentially have a question mark and then a key equals value pair. Or for that matter, you can even have multiple key value pairs that by convention are separated by ampersands. These things are everywhere. Like later today, when you pull up almost any website in your browser, look at the URL, and you'll just see a lot of this. A lot of noise, too, and distractions, but there's going to be some equal signs, most likely, and or some ampersands as well. And those are just separating key value pairs. Now, what can I do here? Well, if you think back to how we manually searched for cats earlier, let me quickly do this. I'll do this one manually. Doc type HTML as my very first line. HTML tag with, how about my lang attribute for English up here. And then inside of this, I'll have a head tag. Inside of this, I'll have a title. I'll call this example search. And then down here, I'll have my beginning of a body tag. And now, let me introduce you to really a final tag for now, a form tag, which will create a web form, the thing with text boxes and buttons that you and I use every day on any number of websites. Inside of this form, I'm going to have an input, like a text box, whose name is going to be Q for query, because I'm trying to re-implement Google here. The type of that, I want to be a text box, or if I know I'm using this for search, I can actually change this to a search box, and it's going to let me, it's going to generally put a little X there so you can clear it quickly. That's a nice little enhancement as well. And then I'm going to give myself a submit button by doing input. Whoops. I'm going to give myself a submit button by doing input type equals submit. And then I'll leave that as such here. All right, now I need to do a little bit more, but let's see how this looks. Let me go over to my other tab. Let me go back to my index. And if I zoom out, there is search.html. I'll click it. And there's not much going on here, even if I zoom in. But I do indeed have a really big text box and a submit button. But I haven't in my HTML told anyone anywhere that I want this input, whether I type cat or dog, to go to google.com. So for that, I need a couple of more attributes. And I know this from having done this before, and any online reference will say the same. You can add an action attribute, like what do you want the action of this form to be? And you can put the URL to which you want this form to be submitted. And I know from tinkering that it should be https://www.google.com/search. I don't need to put any question marks here myself, but I do want the browser to do that for me. So let me go back to my other tab. Let me reload, and nothing visually has happened. But watch this. When I now type in cats, but before I hit enter, notice that I'm currently at some long, crazy URL /search.html as expected. If I now go down to the submit button and click submit, watch what happens to the URL and the page itself. I'm whisked away to the actual google.com. And indeed, there are those same cats. And if I zoom in here, you'll see that my URL has changed to be indeed /search?Q equals cats. So this is just how web forms work. When you submit any form on the web in this way, the browser automatically goes to that action URL, adds a question mark, puts any key value pairs that you manually typed into the text boxes, and lets the server do its thing. Now, here's where Chrome is starting to simplify things. Safari does this too. If you double click on your URL, now you see the full URL. But if any parts are missing, that's just a UI thing to eliminate visual distractions nowadays. Meanwhile, if I go back to my own form, if I search this time for dogs and hit enter, now again, the URL changes to be Q equals dogs. And it all reduces to this basic building block of using a form tag. Now, I can be more explicit. If I know I want to use get, which is actually the default, I can literally say, quote unquote, get in all lowercase, even though the verb earlier was by design in uppercase. But here now, I'm just being ever more explicit. If I don't want the label of this button to be very generically submit, maybe I want it to be Google search, quote unquote. Well, if you read the documentation for forms, you can actually change the value of the button to be, quote unquote, Google search. And if I now go back here and reload, I get a fresh form. And now I get a button that literally says Google search. And if I tinker with this further, because this isn't very user-friendly, there's even more attributes I can do. I can add on my search input a autocomplete equals off if I don't want to see my own history for whatever reason. I don't want people knowing I'm searching for cats and dogs on this page. I can autofocus on the text box so that it shows the cursor blinking in that box by default. And I can even do something like this. I can have a placeholder attribute that says something like query or some other documentation for the user. And if I now go back and reload, you'll see, notice, it says query, and it's subtle, but my cursor is already positioned there. It gave it focus, and I can type cats now without having to click in the box manually, which is just marginally better for the user's experience. Any questions now on all of this here? Any questions? All right, that too was a lot. Why don't we take a casual 5-minute break, and when we resume, we'll take a look at CSS, add in some JavaScript, and then wrap up. So 5 minutes only for now. All right, we are back. So that's technically it for HTML. Like here on out, it'll be up to like online resources and references we point you to just to fill in your vocabulary for more tags and attributes. But like conceptually, that's it. There's attributes, there are tags, and there are attributes, and the rest of it really is just kind of a laundry list of capable, possible features. But it turns out too, you'll see over time that you can even see the HTML for websites. So for instance, if I go over to harvard.edu in my browser, which I'll go ahead in just a moment here and do https://www.harvard.edu/enter, it again will pull up today's version of Harvard's website. And if I right click or control click on it again and go to inspect, you'll see those so-called developer tools. And earlier, we focused on the network tab just so we could see the HTTP stuff going on. But what I glossed over earlier was the so-called elements tab, which actually shows you the HTML underlying any web page on the internet. And so, for instance, here is the underlying HTML for Harvard's homepage as of right now. And aesthetically, some of it's been collapsed. So if I click on these various triangles, I'll see what's actually inside of. That is the children of some of these HTML tags. But here on out, if you're ever curious as to like how a web page made some feature visually, you can just literally use these developer tools built into your own browser just to see what the web developer actually did. And you can do things too like this. Like if you really like maybe, let's see, if you really like this menu in the top right-hand corner of Harvard's website, you can even right-click that or control-click that specifically, choose Inspect, and what browsers will do is jump to the HTML corresponding to that visual element on the page. And here you can see, though we've not talked about this tag before, there's a button tag, there's an ID attribute, and there's some other attributes as well that define that button. You can do other things too in the web page. Let me scroll down, for instance, here, and let's go to another one, like yale.edu here in today's theme. And suppose we want to do something like change the aesthetics of this website. Well, how about this over here, Life at Yale. Let's right-click on this, choose Inspect. That's going to jump to that part of the page. And notice what you can do here in this Elements tab. We can be a little playful and return today, Life at Harvard. And voila, we've now changed Yale's website, it would seem. So have we really? Like, hopefully hacking is not actually this easy. What did we actually do based on today's mental model? Like, I have changed the page, but yeah, I've just changed how it is for me, right? Because my browser, just like with Phyllis and Brian from the get-go, requested Yale's web page. I got back a virtual envelope containing that HTML, as we've now called it. My browser has a local copy. It's got its own tree, otherwise known as a DOM, document object model, built up in its memory. And yeah, I went to town and changed my copy of it. But of course, hopefully, I've not changed the actual server. And in fact, if I reload Yale's website now, hopefully, it will revert back to, indeed, yep, what it should be instead, Life at Yale. But this ability in your own browser, be it Chrome or Firefox or Edge or Safari, to have these built-in developer tools are very powerful because it's going to enable you to not only diagnose problems that will invariably arise in the coming weeks with your own code, but it's also going to allow you to learn from other sites, like how you can do things and tinker as well. But up until now, we focused only on tags and attributes and on the structure of a web page. Let's now focus more on the aesthetics and fine-tuning that. It turns out that HTML has very limited support for anything aesthetic, like font sizes and colors and so forth. And in recent years, people have used necessarily a second language called CSS, not a programming language, again, a markup language, if you will, to just fine-tune the aesthetics of a page, font sizes, colors, margins, and all of that. So CSS is going to allow us to define a whole bunch of properties, which is just another group of people's terminology for key value pairs. Indeed, ever since week 5, like key value pairs are everywhere in the world, not just at like Sweetgreen and restaurants, but indeed underlying code and languages and technologies like these. So properties is the new word in CSS for what a moment ago we called attributes in HTML. But it's the same idea, just different vocabulary that you get used to over time. A few phrases I might use now and you'll hear in the coming days would be these: type selector, class selector, ID selector, attribute selector, which just refer to different techniques we're about to see that are going to allow you to control more precisely the aesthetics of specific things on the page. And the way we're going to do this is we're going to take our basic HTML, like we saw earlier, and we're going to introduce in the next few minutes just a couple of more tags and or attributes. One, we're going to introduce you to a tag called style, which, nicely named, allows you to control the style, the aesthetics, the visuals of the web page. Or we're going to introduce you to a link tag, which very confusingly does not give you a link that you can click on. It just links to another file that then gets automatically included or imported, to borrow our language from C or in Python. But same idea. This will allow us to include secondary files. And we're going to ultimately show you how you can leverage third-party frameworks, libraries that other people wrote, so as to not get stuck in the weeds of all the fine-tuning of aesthetics and just make pretty things fast so you can focus really on the intellectually interesting part, if that's your choice, of building the content, the site out, the application out yourself. All right, so with that said, let me go back to VS Code here. And let me go ahead and create a simple example called home.html, like a very simple home page for John Harvard, for instance. Let me give myself 3 paragraphs initially, the first of which is just going to have the person's name. The second paragraph is going to say something like, welcome to my home page, to greet visitors. And then the third is going to be like a little footer, like copyright, how about John Harvard 1636, or something like that. All right, let me go back to my other tab as before, reload my index. There's my new file, home.html. And I'll click that. And you'll see, OK, I mean, this is sort of 1636 style web page. Super simple, all text, nothing really interesting going on there. But we can start to style it a little differently. Like if the title of the page is John Harvard, and then it's welcome to my home page, and then this less important footer, why don't we have the text be large, then medium, then small? So something arbitrary, but a little more nuanced. So let me go back to VS Code here. And in my home.html file, let me introduce not yet the style tag, but what I'm going to call temporarily the style attribute. Both indeed exist. This one's simpler, and it's going to be correct, but we'll see in a moment, not as well designed, arguably, as is often our narrative. So inside of the style tag, you can put this language called CSS, key value pairs, otherwise known as properties. The only way you know what properties exist, what keys exist, is by taking a class, reading a book, looking at an online reference, and we're going to give you just a sampling of what's out there. So suppose I want to control the font size of this first paragraph. I can literally say font-size, in all lowercase, colon, and then a word like large. Or I can specify 12 point or 18 point or something more precise like that, like from Google Docs or Microsoft Word. And suppose I want to make this text down here medium. Well, I'll do quote unquote font size colon medium. And down here, I'll do style equals font dash size small. So I'm going to start with just these 3 key value pairs, same key, but different values. I'll go back to my page, and in a moment, I'll reload. And it's going to be somewhat subtle, but watch how the font size do change when I reload now. All right, so it got a little bigger. Middle one's about the same, and the last one is a little smaller. What if I want to center it? Just like many web pages have the text like this centered. Well, I can separate these key value pairs with semicolons. And I'm sorry, semicolons are kind of sort of back with CSS. But I can do text-align colon center. Strictly speaking, I don't need the last semicolon if there's no more key value pairs, but I'll just do it to be consistent. Text-align colon center, and then down here, after another semicolon, text align colon center. All right, let's go back, reload. Now it's going to be much more obvious, the change. And we now have the beginnings of a home page. Still pretty basic, but at least it's a little more interesting. Turns out we can do a little better with the copyright symbol. Like most computers actually have support for a circle with a C in it. But you can't just do that with text like this. There's different ways to do this. You could copy paste it from like a website that already has it, so you don't have to figure out the magical keystroke on your Mac or PC. But there's also in HTML what are called entities. And you can actually specify using hexadecimal or decimal codes numbers like this, #169 semicolon after an ampersand. And this is a special symbol that you can look up in any online reference for like special characters that are hard or impossible to type manually at your keyboard. And this, let me zoom in just so it's obvious. If I reload now, instead of being 2 parentheses and a C character, now it's a proper copyright symbol. So you'll see these out there. They're not necessarily that frequently used nowadays, but it's good to know that they exist. But let me go back now to my code and propose that, while correct, this is arguably not very well designed. And even if you've never seen HTML, never seen CSS before, what instinct might you have for why this is poorly designed? Yeah. There's repetition, right? In general, in the past several weeks, C, Python, SQL, like repetition, generally bad and sloppy, and it's not going to scale well. So the repetition I think you're probably alluding to is text-align center, text-align center, text-align center. Well, we can factor that out in CSS. The C in CSS means cascading. And this means that if you move some properties to like a parent or a grandparent, the children or grandchildren will inherit those properties. That is, they will cascade down the family tree, so to speak. And so let me go ahead and remove all of these, since I claim they're indeed redundant. And let me preserve just one of them by, well, let me do this. It's not quite right to put a paragraph inside of a paragraph. Like, that's just not a thing in English writing or in writing more generally. So I'm going to do one thing first. It turns out that these two are arguably not paragraphs, right? This is like a header, the body, the essence of the page, and then the footer. So if a paragraph isn't quite the right English semantics, you can actually use more generically a tag that's all over the internet called div, for division of the page. And this is just a very generic term for like a big rectangular region that divides the page again and again, just so that you can think about different regions. Now that I have div, which really has no more meaning than that, it's a division of the page, interpret as you will, now I can have multiple ones of these. And let me go ahead and open a div tag here. Let me close a new div tag here. And then just to keep everything tidy, I'm going to highlight everything in between and hit tab, and that just automatically indents everything for me. Now I have 3 divs inside of another div, and that's totally fine. This is very commonly done. Now I'm going to do this. Style equals quote unquote text align colon center semicolon or not. And now I have some cascading capabilities. Now the parent of those 3 children, John Harvard, will come to my home page, and the copyright will now all inherit that property. So when I hit reload, nothing aesthetically has changed. Whoops, sorry. Nothing. Oh, I should have done reload slightly earlier. When you use a div instead of a paragraph, it actually gets rid of the space between those paragraphs. It just sandwiches them a little closer together. I can fix this in another way. But that aside, everything is still centered, and the text is still large, medium, and small. But I should have called out that change in the paragraph spacing. But we could bring that back before long if we wanted. Now, what more could I do to maybe improve this? Well, strictly speaking, I don't really need that parent div, right? Because these 3 divs inside already had a parent. So let me actually get rid of that new div just to undo what I did. I'll highlight this, and if you haven't seen this trick, Shift-Tab will unindent nicely, which is perhaps helpful. I could just put that text align center on the body tag. So text align colon center, quote unquote. This too would work as well, so long as you go up the family tree, so to speak, reload. And now, indeed, there's nothing aesthetically that has changed this time. But it turns out nowadays the web is getting a little more sophisticated. And even though you will see so many examples online in tutorials and books using div, 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 div all over the place, there are newer semantic tags. Semantic just means they have more meaning than this generic notion of a division. And if you look up a documentation for HTML, you'll see that if you want to have a header on a page, not a heading like H1, H2, but a header, there's literally nowadays a header tag. And this is marginally better because it now says what it is. Search engines like Google and Bing can detect, oh, that's the header of the page. Maybe we should use this and give it more prominence in the search results. You can then have a main part of the page, so literally a tag called main nowadays. You can literally have a footer of the page. And again, these are often useful for screen readers to help recite things verbally for folks who might otherwise not be able to read them. And probably these screen readers might highlight the header and the main part, but maybe might not spend time for the user on the footer, which is arguably a little less important semantically usually. Or search engines, again, now know what's the header, what's the footer, what's the main part of the page, so they know what to search and analyze. So this would arguably be a better design nowadays as well. But what else remains as a problem? Well, this is now getting a little bit more subtle and takes some experience, but this practice of putting HTML and CSS all in the same file, it's a little sloppy. Why? Because it means I'm commingling my data with the presentation thereof. Like the juicy stuff I care about, like John Harvard and the phrase, welcome to my homepage, and all of the aesthetics that I might want to change over time. And honestly, because everything is currently in one big file, it's going to make it really hard for me to collaborate with a classmate or a colleague at work so that maybe I do the HTML, they do the CSS. Like, not if you're all working in the same file. It would be a nightmare. Even if you use the VS Code sharing feature like Google Docs and both are typing at the same time, like you're going to mess up somehow. It'd be nice if we could separate these two languages. Well, one way to do that would be as follows. Let me get rid of all of the style tags, style attributes that I've added up until now on all 4 now of these tags. And let me introduce the style tag that we saw on the slide earlier instead. I'm going to go up here into the head of the page, which is where technically these style tags must go so that they're already loaded into memory before the body is even analyzed by the browser. And inside of this style tag, I'm actually going to select the HTML elements that I want to stylize, if you will. So if I want to change the body's aesthetics, I'm going to literally type the name of that tag, body, and then, curly braces are back also from C. Inside of these curly braces, I'm going to put text align center. So the key value pairs are the same. The only new thing I've done is I've moved some of the syntax up to this new style tag in the head. If I want to now control the header tag as well, I can use the same curly braces. This is convention to put the open curly brace on the same line, the closed curly brace on another. The browser doesn't really care, but this is a common CSS style convention. I'm going to do font size large, semicolon. Then for the main tag, I'm going to do font size medium. And then for the footer tag, I'm going to do font size small. So same exact thing, and it's admittedly a little bit more verbose. It's taking up more lines of code. It doesn't all quite fit on the screen. But if you scroll back down now, and you'll acquire an eye for this, this is just better. Like, it's just more compact. It's more readable. The content, the data jumps out, and there's no visual distractions like the CSS properties as before. Upside here, too, is that we don't actually need to this doesn't actually change the aesthetics. If I reload the same page, it still looks the same, but I've taken a step toward some slightly better design. But let me propose that there's other ways to do this too. We just selected things by way of their type. So that was a so-called type selector when I literally just specify the type of tag, body, header, main, footer. But there's other ways that now we can lay the foundation for making reusable CSS that you and colleagues and classmates can use and reuse in multiple files and even in multiple projects. So let me actually go ahead and do this. Instead of just very explicitly saying, I want the body to be centered, let me invent an adjective, if you will, and let me change this to .centered. And this new vocabulary word, centered, will literally mean text-aligned center. Let me go ahead here. And I'm just going to create a new adjective called large, a new adjective called medium, and a new adjective called small. They are deliberately consistent with what the properties do, but these are now my own vocabulary words, and they are called classes. So a class is just a collection of key value pairs, a collection of properties that you get to invent for yourself. And what it lets you do now is this. Now, if I want the whole body to be centered, I can add this tag, which we actually saw briefly in Yale's HTML, class equals centered. Down here in the header, if I want this to be large, I can say class equals quote unquote large. Down here on main, I can say class equals quote unquote medium. And down here, I can have class equals quote unquote small. Now, I have taken one step backward by re-adding some of the aesthetics to the page, but it's not the actual properties. It's not the key value pairs. It's now more semantically nice because now I just know from reading the HTML what these things are going to look like, whereas the implementation details for all 4 of those adjectives is now relegated up above. And these are literally my words. I could change it to .foo and use class equals quote unquote foo, but obviously that would not be the best choice of words in this case. All right. Any questions on this? This now is what we would call a class selector by using literally the dot, even though the dot does not appear elsewhere, but dot means this is a class. These are not always the best syntactic design decisions that the world makes. All right, well, one last trick then. Notice that this is a little annoying that I'm still working in the same file, and if my classmate wants to clean up my aesthetics, make my homepage look way better, if my colleague wants to do the same, wouldn't it be nice if we could actually move all of this code to a different file, like a Python library or a C header file? Well, you can. Let me go ahead and delete that whole style tag. Let me add a confusingly named link tag, the href of which, let's call a new file styles.css. And let's say that the relationship of that file is that of style sheet. So this is a term of art in the world of web development. A style sheet is a text file that contains lots of styles, lots of CSS properties. Let me open my terminal real fast. And let me do code of styles.css, enter. And in this file, I'm going to paste all of those same lines as earlier. But now they're in a separate file. And indeed, if I hide my terminal window and I give this file to a colleague, they can now work on the aesthetics of the page and make things a lot prettier than this, maybe use specific font sizes, maybe add colors and the like, whereas I can focus entirely on the HTML because this file now will reference that other. And if I go back to my other tab and reload, the content's going to be exactly the same, but now I'm using some separate file instead. Any questions now about these techniques here? No? All right, so with that said, let me show just one example now of what I called a moment ago frameworks. And this is where web development gets kind of fun, at least if you like this, especially if you like the sort of logical design, the presentation of information you care about, but you really don't want to struggle with like font sizes and colors and getting everything pixel perfect, so to speak. Let me propose that I open up here an example in just a moment in VS Code that I prepared in advance. And this one is going to be an opportunity to consider how you might take some of the data from last week, which we had, wherein we collected everyone's favorites, and lay it out in a really big HTML table. So I wrote this out in advance because it was a huge amount of data, but it's the same data from the Google form from last week. And you'll see already the hints of a table tag and these TRs. And I added a few other tags for aesthetics. It turns out when you have a more visually interesting header for your table, there's another tag called thead. There's another tag called tbody. These are not all that intellectually interesting. I just read the documentation and realized, oh, to make things prettier, I need a thead, a tbody, and so forth. But what's interesting here is that if I go to my index here and open this file called favorites.html, here is all of the data from last week's Google spreadsheet, which we exported as CSV, and I manually, before class, converted to just HTML. It's indeed a table, but it's really not pretty. Like, the columns are really close together. It's kind of hard to distinguish one row from another, but this is just raw HTML written by me. Now, I could use CSS and some of the tricks we just saw to maybe change font size. There's ways to change color, background color, and a lot of things like that. But honestly, surely other people in the world have presented tabular data in pretty ways, right? I've been to many websites that have prettier tables than mine. Can I maybe use someone else's framework, someone else's CSS, include it in my page, but then stand on their shoulders and just make my stuff look prettier? Well, I dare say I can. Let me go ahead here and semi-secretly open up VS Code again, and let me grab a slightly different version of favorites.html that I also opened in advance, wherein I add this line of code instead. Give me just a moment to foreground this version, and the data is all the same as before, but I've added one of these link tags. And I'm not linking to my own styles.css. I'm using a popular library called Bootstrap. And Bootstrap is just one of many popular libraries out there, free at that, that has a whole bunch of CSS files and soon JavaScript files that you can just use for free in your own projects, personally or professionally, that just make things look and behave better without you having to reinvent wheels. Now, to access their CSS, I had to read their documentation and grab this very long URL here. But it's the same idea. Link href equals quote unquote something. And I read their documentation, and they told me to add this. They told me that if I want my tables to be prettier, I have to add a class attribute to my own table tag and specify, a little weirdly, but this is what Bootstrap told me to do, a class called table. And that will make it a prettier Bootstrap table. And if I want to stripe it, like every other row is gray instead of white, just to make it pop a little more visually, I can also add a second class separated by a space called table striped. That's all I did. I added line 5 and I changed line 9, and that is it. The rest of the hundreds of lines in favorites.html are the same. But if I go back here now and reload the browser, now, thanks to Bootstrap, voila, like it's much prettier. Now I can zoom out, and that changes the font size just locally for me. And even if you don't love their aesthetics, I mean, this is easily better than my own there. And it turns out we can do even better by adding interactivity to this too. But to do that, we're going to need one final language for today. And this one is an actual programming language. And we won't use it all that much in CS50, but we introduce it here as we begin web stuff because there's just so many free libraries and professional libraries that you can use just to make your web applications fancier and more interactive. Mobile applications as well increasingly use HTML, CSS, and JavaScript to power our iPhones and Android devices as well. So a quick tour of some syntax, and then we'll conclude with just some hopefully inspiring examples to give you a taste of what JavaScript can do. So JavaScript supports conditionals, just like C and Python before it. If we rewind to our Scratch days, here, of course, is a conditional. Here is the corresponding JavaScript code as of today. It's pretty much identical to C with the syntax here. If we had an if-else, in Scratch, it looked like this. In JavaScript, it's going to look like this instead. So it's a bit of a regression vis-a-vis Python. Like the parentheses are back, the curly braces are back, the semicolons I mentioned in CSS are also back in JavaScript potentially. But it's familiar is the point here. And it's a different language that's frequently used for the web, whereas you can't use Python in the ways we're about to use JavaScript. It just wasn't designed for that purpose. Meanwhile, if you have an if-else in Scratch, well, in JavaScript, just like in C, it's going to look like this instead. Variables in JavaScript, of course, are a thing too. And in Scratch, we might have initialized a counter variable to 0. In JavaScript, a few different ways to do this. And just for now, the keyword is let. It's sort of a polite way of asking for a variable. Let counter equals 0, semicolon. So you don't mention the type, but you do use a keyword here, in this case called let. If you want to increment counter by 1, few different ways. In JavaScript, you can do this, just like in C. In JavaScript, you can do this, just like in C and in Python. In JavaScript, you can also get this. So ++ is back. So maybe that counterbalances the other syntax as well. That was not the case in Python. Loops are back, of course, in JavaScript, whereas in Scratch, you could repeat 3 times like this. In JavaScript, it's pretty much just like C. The only difference here is that you say let instead of int for an example like this. Meanwhile, if you want to do something forever in Scratch, in JavaScript, just like in C, you say while true in this case. So this is to say, we're sort of comfortable spending relatively little time on JavaScript, at least for today's purposes, because syntactically, it's really the same as we've seen before, with maybe a slight variance here or there. But what's interesting today, arguably, is just what kinds of things you can do with it. So with that said, what kinds of things can we do? It all comes back to this picture. If this is a simple web page on the left, and this is the corresponding tree, or DOM, document object model, on the right, that is the tree the browser automatically creates in memory, or RAM, for you, JavaScript is now a proper programming language that lets us dynamically manipulate, like read data from this, change this. And this is how Google, for instance, implements your inbox. They might have in your inbox, it's like a table. So tr, 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 probably, something like that. Or heck, maybe div, 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 div. Using JavaScript, anytime they realize someone sent you new mail, they can create a new node, a new rectangle in memory. And you, the human, see a new div or a new tr again and again and again. So with JavaScript, you just have the ability to control the user's experience instead of, like I've been doing, constantly hitting reload in the page to see some new content. To see some new content, JavaScript can be running 24/7 so that you can actually see all of these changes live. All right, so let's go about writing some JavaScript code now. Instead of writing it on the server and executing it on the server, we're going to actually use a very common paradigm, whereas JavaScript is actually executed in the browser client side. That is to say, we can actually start writing some JavaScript code inside of our own .html file so that when a user visits that web page with their browser, not only is the HTML and any CSS downloaded to the user's browser, so is that JavaScript code so that it's executed indeed client side on the browser rather than server side, as has been the case with Python in previous weeks. Well, where do we go about writing some JavaScript code? Let's go ahead and revisit hello.html, which previously was a completely static example that literally just said hello title, hello body. Indeed, if I open this up using HTTP server and view it now in a separate tab, all it said was exactly that. Hello title in the tab and hello body in the main part of the viewport, so to speak. Well, let's make this example a little more dynamic so it doesn't just say hello body, but maybe says hello to an actual person. So let's go ahead and do this. Let's go ahead and remove the hard-coded hello body. And let's actually go ahead here and use a form tag. But we're not going to use this form in the usual way, whereby the data gets sent all the way back to the server. We're going to leverage control over this form client side instead. So I'm going to go ahead and create this open form tag, close form tag. Inside of that, let me give myself a text input that's going to have autocomplete equals quote unquote off, just to ensure that what I previously type in my examples doesn't reappear accidentally. We're going to autofocus it so that the cursor is blinking right there in that text box. And this time, I'm going to go ahead and give it, how about a placeholder of quote unquote name, to make clear that I'm prompting the user for their name. And then the type of this text box will be the default, or more explicitly here, text. And then I'm going to have, as we've seen before, a button, the type of which is submit, also our typical default. And then inside of this button is going to be the label. How about something like, how about we'll call this greet? So that's what the button will actually say. Well, let me actually go back into my browser tab. Let me reload this page. And we should now see a relatively simple form whereby I have the cursor blinking on a text input prompting the user for their name, and then a greet button that I can click. But if I click this button now, it's not going to do anything useful because I haven't written any code to tell the browser what to do when I click that button. But it turns out there's all sorts of events in the world of JavaScript that you can listen for, so to speak. In fact, here's just a list of some of them. Anytime something changes in a form field, anytime the user clicks or drags on something, anytime the user presses a key and maybe lifts their finger up, anytime the mouse goes down or over or up on top of something, or anytime a form is submitted, those are events in the same way that we talked about events back in week 0 in Scratch. And in JavaScript, just like in Scratch where you can do something when green flag clicked, in JavaScript you can write code that actually listens for any of these events or more. So with that said, let's go back to VS Code here. And let's make a couple of changes instead. Let's go ahead and add to this form a new attribute. That's not the best way to do it, but it's perhaps the simplest for version 1 here. And let's say on submit, do the following. So on submit is an HTML attribute. And curiously, its value inside of the quotes there can actually be some JavaScript code. And let's go ahead now and let's assume there exists a function in the world called greet. And what I want to do is call that function right then and there. Well, now in JavaScript, how do I go about making that function exist? It doesn't come out of the box just like print might or say might in Python or Scratch, respectively. But I can do this. Let me go up into the head of this page. Inside of a script tag here, both open and close, let me actually write some JavaScript code. And just so it stands out, I'm going to give myself a couple of blank lines, though not strictly necessary. And let me define a new function in JavaScript called greet. And this is the syntax in JavaScript for creating your own function. Similar in Python, instead of saying def in JavaScript, you just say function, then the name of the function, and any arguments within the parentheses thereafter, but I'm not going to pass in any here. Then inside of curly braces, what I'm going to do is use a built-in JavaScript function that comes with any browser called alert. It's not the best or prettiest user interface, but for now, it's going to get the job done. What do I want to say to the user? Well, let's first just say something simple like hello, comma, world, close quote, semicolon, thereby alerting the user with precisely that message. Now, what I'm going to do down here is make one other change. I don't want this form to actually get submitted to the server. Just like we've seen in the past, when you submit a form, it often goes to something like google.com/search. I actually want my JavaScript code to take control over the entire user experience of this form so that I'm just using the form as a user input mechanism, not to actually send via get or post this data to some other server, including my own. So this is going to look a little ugly, but after calling greet, I'm actually going to do this, which I've read the documentation about, and I know that if you actually hard code return false here, that just tells the browser, please don't actually submit the form, only call the greet function. All right, well, let me go back to my browser here. Let me reload this because I need to download the latest version of the JavaScript code. And I'm just going to go ahead, without even typing my name, I'm going to click on the greet button. And you'll see that, albeit a little cryptically at the top, we see an alert that says hello world. There's my ugly URL of my code space there at the moment, but we do indeed see that string. But what I haven't, of course, done is taken any actual name from the user. So how can we go about doing that? Well, ideally, I want to alert the user with hello, comma, David, or hello, comma, Carter, whatever name I type into that box. So how can I go about doing that? Well, let me create a variable called name. And let me set it equal to this function call, document.querySelector. That comes with JavaScript itself. Let me then, in parentheses, pass in an argument that is going to be, the ID, I need a unique identifier for the thing I want to select. So let me actually go back to my HTML code here. And instead of giving this form field a name like Q for query, let me actually use another HTML attribute called ID, where now I can call this anything I want. And for clarity, I'm just going to call this input element uniquely name. Now up here in query selector, just like in CSS, where you can use hashes and dots and other symbology in order to select certain nodes in your DOM, that is rectangles in that memory tree, well, I can go ahead and select hash name, which again is just the syntax for uniquely selecting the element whose ID is, in this case, name. So you have the hash up here. You don't need the hash as the value of the attribute down here on line 20. And now if I want to actually get the value of that text box, I literally just say .value. So document refers to the whole web page itself. Query selector is a function that's built into that object, so to speak. And the value, accessible via .value, just like a C struct or even a Python class, allows me to go inside of that text field and get whatever the value the user has typed in. Now, as I've been able to do in languages like Python fairly readily, I can concatenate this name onto the string hello, comma, space, so as to form a complete phrase. And you'll notice here that I'm actually using single quotes in my JavaScript, double quotes in my HTML. This is perhaps a common convention. In JavaScript, the language does not care if you use double quotes or single quotes, but I dare say single quotes are just more common. And so that's what I've done here. All right, now as always, I'm going to cross my fingers, go back to this page. I'm going to reload because I've changed the JavaScript and I need my browser to download it. And now I'm going to type in my name, for instance, DAVID, click greets with fingers crossed, and voila, now I see hello, comma, David. All right, so it turns out that while functional, this isn't the best design, and commingling your HTML with your JavaScript code, as with this onSubmit attribute, isn't particularly clean. It's better, as with CSS, to keep your HTML over here, your CSS over here, and your JavaScript now over here, so to speak. And better still, perhaps even in some separate files. So how can I go about changing this a little bit? Well, let me go ahead and let's go ahead and delete all of this code for just a moment. And let me go and get rid of this onSubmit handler down here and really just distill my HTML only into the HTML and the attributes therefore. And what I'm instead going to do now is do this. I can use JavaScript to achieve the listening for that submit event or that onSubmit event. I don't need to actually use HTML for that. I can use JavaScript entirely. So it turns out I can access some other member of this document by doing document.querySelector again. But this time, let's select the actual form tag. And it doesn't have an ID because it has no ID in its HTML, but it does have a tag name. So just like in CSS, when you can target elements by way of their name, I'm just going to select the one and only form on this page by using that same query selector function. And now I'm going to use another function that just comes with JavaScript in the context of browsers, whereby once you select an element like that form, I can call add event listener, which is similar in spirit to Scratch's when green flag clicked or any block like that. You can then tell the browser what event you want to listen for. I want to listen for the submit event. So you don't say onSubmit here. Now that we're in pure JavaScript, you just say submit. And now I can do something like this. I can go ahead and say, call the following function. And I'm not even going to bother giving this function a name. And that is allowed to in JavaScript, as we saw briefly in Python. And what I'm going to do now inside of curly braces after that keyword function is the same kind of code as before. I'm going to do let name equals document.querySelector. I'm going to select that same name ID as before and get its value. And then I'm going to do alert and then pass in hello, comma, a single quote. Again, after that, concatenate with that the name, and then semicolon. But I need to do one other thing. It turns out that this function, and if you read the documentation for this technique, actually takes automatically a special argument called by convention event. And this is just a variable, if you will, that refers to whatever event just happened. In this case, it's of course going to be submit. But in other contexts, it might be a click event, a mouse down event, or something else entirely. So this allows me now to do this, which is a little cryptic, but you get used to these conventions. I can use that event, whatever it is, and then prevent whatever the default behavior is by calling a special function called prevent default with a capital D. This is the alternative to that messier return false semicolon that I had inside of my HTML before. So all I've done here now is I've left all of my HTML as pure HTML down here, and I've put all of my JavaScript code as pure JavaScript up here. This sort of separation of concerns similar to what we started doing with CSS just a bit ago in order to keep those two languages separate too. Well, let me go back to my browser here, reload the page, and unfortunately there's a subtle mistake I've made here. Let me go ahead and type in DAVID and click greet. And unfortunately, nothing actually seems to happen. Well, maybe it's just my name, Carter, greet, and nothing seems to happen. That alert does not come up. Well, why is that? Well, let me go back to VS Code here and point out that order of operations in JavaScript matters, similar in spirit to C. Because on line 7, I'm selecting the form and trying to add an event listener for submitting that form, unfortunately, the form had better exist at that moment in time, but it doesn't. Because just like in C, and in some cases Python, where the compiler or the interpreter reads the code top to bottom, notice that the form doesn't actually exist and therefore get loaded into the computer's memory until line 19. So we've got to kind of reorder these somehow. Now, maybe the simplest way to do this would just be to perhaps do something like this. Let me scroll back up to my script tag and perhaps a little more explicitly move it into the order in which I want it to be executed. So I'm going to go below my form and inside of my body, which is actually OK for JavaScript here, and just use that same code. And assuming I didn't make any typos, let's go back to the browser. Click reload again to get the latest. Type in my name again using that purely JavaScript solution. And the only change I made was I moved the code from up here to down here. Clicking greet now. And wow, it's now back. We get the alert with hello, comma, David. So those kinds of things, those kinds of principles matter, at least when we're back in this world. But there's other solutions too. And just so that you've seen it, because it's a common convention in libraries as well, let me undo that change and put that script tag back in the head, or really anywhere else in the page where it might be. And let me propose that there's one other way to solve this problem to postpone that code on lines 7 through 11 getting executed until really the whole DOM, the tree, is ready to go. And the syntax for this might be as follows. I can do document, and I can add to the document an event listener that's going to listen for something a little special. And I always have to look this up myself to remember the spelling and the capitalization. But it turns out that the browser itself, once it's done loading all of your HTML top to bottom, left to right, it will raise an event called DOM content loaded, capitalized exactly as such. And if you want to call some function, and I don't even need an event argument in this case, you can open curly braces just as before and put inside of those curly braces the code that you want to execute only once the DOM's content has been loaded top to bottom. And now let me just finish my thought with a close curly brace, close parenthesis, and semicolon. It gets a little annoying to visually line all of this up, but I think I'm still good. And now, even though this code is at the top of my file, or really above the form tag itself, I think we're OK. So let's go back to the browser here, reload the page, type in DAVID, and click greet, and we still get the same correct behavior. And so this is just a very common paradigm to use these kinds of events to listen and listen and listen for something to happen, and then only do something once that thing has transpired. All right, well, let's take one more step with JavaScript code before we take a look at what's really fun about this language and what you can do with browsers in particular, by just cleaning things up a little bit further. I'm going to go back into the code here, and I'm actually going to remove or cut all of this code out of the hello.html file itself. And I'm going to change my script tag to have nothing in between the open and close tag. But I am going to give it a source attribute. And let's go ahead and call this, for instance, hello.js. So .js would be the convention for the file extension for a JavaScript file. And even though this is a little weird that we have the script tag and a source attribute, then nothing in between the open and close tag, this is indeed the convention when you want to put all of your code in a separate file. And let me go ahead and do that. Let me go ahead and open my terminal window, create a new file called hello.js. And then in that file, I'm just going to paste the very code that I just cut from the previous file. So no changes to the code. All I'm doing is factoring it out. And now I'm doing something just like our CSS factorization before, which confusingly used the link tag. This uses the script tag. This just now allows me to collaborate with someone like Carter or someone else so that they can do the JavaScript code, I can do the HTML, maybe a third person can do the CSS, and indeed, maybe we can build even grander things by designing things in this way. All right, well, let me go back to my browser again, reload the page. I shouldn't see any visual changes, but if I type in my name again, David, and click greet, this still now works. And what my browser has just done underneath the hood is not only download the hello.html file as always, because there's now this script tag that's referencing the source of another file. Just like an image tag might reference the source of an image, the browser is automatically helping me out by loading that into its memory as well. And now how about one final example? And for this one, I'm going to go ahead and not write it live, but open it up as prepared in advance, just to show you what you can do by listening for some of these other events as well, like the key up, the finger going down, the finger going up, and listening for exactly that. So as the user is typing something, you can do something interesting as well. I'm going to go back into my directory listing here, and I click on this source 8 directory, which has all of the examples that I wrote here in advance. And I'm going to scroll down to one called hello5.html, and in hello5 now we've gotten rid of the button and we just have this text box. But notice now what happens if I start typing my name as D, A, V, I, D. I'm not typing enter at all. And in fact, if I start deleting and I change my mind and start typing Carter's name, notice now that the web page, the DOM inside of the computer's memory, is now automatically updating itself. So it's not even listening, it would seem, for a submit event anymore, but maybe for a key up event instead. So let me go back to VS Code here, open my terminal window, and in my source 8 directory, let me open up hello5.html. Inside of the script tag, you'll see some code that's similar in spirit to before, whereby I'm adding an event listener to the document, waiting for the whole DOM's content to be loaded. But then inside of that function, I'm now doing this. I'm creating a variable called input and selecting from the document the one and only input tag that we saw just a moment ago. I'm then adding on line 11 an event listener for key up, which is exactly that gesture, so that I can execute some additional code anytime the human lifts their finger from the keyboard after typing a key. What do I then do? Well, I'm going to go ahead, it seems, and declare another variable called name. And I'm just going to select some p tag on the page. And now we didn't really see a p tag, so I think it's time to look at the HTML. If I scroll down to the bottom of the page where my actual HTML is, you'll see that there's just a form tag and no onSubmit handler anymore as before. There's just an input tag and no button at all. But there is on line 29 here an open and close p tag, just so I have an empty placeholder in which to put something like hello David or hello Carter. So that's why now on line 12, I can define a variable called name, and I can select that p tag so that what do I want to do? Well, if inside of the input there's a value, so this is essentially checking for null or the absence of a string. So if input.value does not equal nothing, that is, there is a value in that text box, well, this syntax here on line 14 is a very clever way of doing the following. Go into that name tag, that is to say the empty paragraph, change the inner HTML of it, the HTML inside of it, to be literally this, hello, comma, and then just so you've seen an additional piece of syntax, this is similar to Python's f strings. The syntax is a little weird in JavaScript. You actually use not single quotes, not double quotes, but backticks, which on a US English keyboard are typically the top left-hand key of your keyboard or thereabouts, and using $ curly braces, just like the curly braces alone in Python, allows us to plug in whatever the value is of that input. However, if there's no value there, it looks like I'm just going to say hello, whoever you are. And in fact, we can see that behavior now as I delete, 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 and nothing's there. Now that if condition is no longer true, and so we see this default value instead. So this is only to say that by harnessing these various events that are constantly happening on most any web page, we can now register code, just like we did way back in Scratch, to actually listen for those events and do something with them. Now, it turns out we can do some interesting things even using third-party code. And just as we used Bootstrap a bit ago to make our table prettier, allow me to propose that we also take a look at this version of favorites as well. Let me go back into my source 8 directory and open up favorites 2, which I made in advance, which looks almost the same, though I've zoomed in here a bit. But you'll notice somewhat subtly over the leftmost column in this table, you'll see now this arrow in gray pointing up and pointing down. Previously, those were not there. All I had was a static HTML table with all of this data sorted in whatever order it was inputted the other day in that form. But now, notice what I can do. If I want to sort in one order, I can click this arrow, or the other order, I can sort in this arrow, so essentially doing it chronologically forward or backward. Now, how is that sorting happening? It's presumably based on all of the timestamps that were registered when we submitted that Google form just a bit ago when it was live. But now, using JavaScript, it turns out that we can use some logic somehow and sort this data by the same. And you don't get that automatically just by using HTML alone. Now, how did I achieve that? Well, it turns out if I go ahead and close these hello files and in VS Code, let's open up favorites2.html, you'll see that all of the HTML is actually the same if I scroll down and down through this file. But I added a little something interesting at top. I copied and pasted the appropriate URLs and HTML tags from Bootstrap's documentation. And you'll see here that I have a file called not only bootstrap.min.css, but also bootstrap.bundle.min.js, as well as a couple of other things as well that allows me ultimately, using third-party libraries, to add some special HTML attributes that those libraries told me to add. And then as soon as those libraries detect the presence of these attributes now on my own raw data, they do their thing and JavaScriptify, not a technical term, the entire table and now make it interactive and not static. So you'll see here that the aesthetics of the table are as before, table and table striped. But I'm adding now another HTML attribute called data toggle, whose value is table. And I know that only from the documentation of these libraries, indicating that that's how I can now enable this table to be interactive, as I can too by adding data sortable equals quote unquote true on specifically the timestamp column. And the only thing unfamiliar here perhaps is I'm using TH for table heading as opposed to TD as I do elsewhere. But that's all that it takes to now focus on the raw data you want to present and let someone else do the heavy lifting of actually implementing the logic. Well, let's end with just a look at what more you can do with JavaScript and just how powerful it is when you combine a language like this with the data and the user interface you want to convey. Let's go ahead and open up within source 8 directory something called background.html. Now, this interface here is quite simple. It just has 3 buttons, R, G, and B. And the background, of course, notice by default is just white. But when I click on the R, the background turns red. When I click on the G, it turns green. And the blue, it turns blue. And again. So how is this working? Well, if you think back again to the available events, perhaps I'm just listening for a click on those buttons and then doing something with maybe the CSS of the page to allow me to see those different colors. So in fact, let's go back to VS Code here, and let's open up background.html. And in here, you'll see some simple HTML at the top, just 3 buttons, but I've given each a unique ID so that I can reference it in code. And then inside of a script tag here below, because I didn't bother with the DOM content loaded event here, notice that I'm doing the following. I'm creating a variable called body that lets me select the body tag. I then have in these 3 lines some code that handles red. What am I doing? Well, I'm selecting from the document whatever HTML tag has a unique ID of red, and then I'm adding an event listener for any click on that button. And anytime someone clicks on that red button, I call this function anonymously. It doesn't even have or need a name. And this syntax here is powerful because now in JavaScript, I can alter the CSS of my page by doing body, which is the tag that I selected 2 lines ago, accessing its style, accessing its background color property, and setting it equal to quote unquote red. And I do the same down below for green. I do the same down below for blue. And the only thing worth noting here is that in CSS, it turns out it's the case that the CSS property for the background color of a page is actually background-color in all lowercase with a hyphen in between. Unfortunately, in the world of JavaScript, a hyphen would be mistaken for subtraction, like background minus color, which would be wrong. So the convention in JavaScript is when you're trying to manipulate CSS, you take whatever the property name is, font size, background color, and you change it into so-called camel case here. You get rid of the hyphen and you capitalize the subsequent words like color in this case here. All right, how about another? Well, it turns out back in the day, back in my day, there was a HTML tag that would actually allow you to do this. Create blinking text on a screen. It's rather unpleasant at this rate, certainly, but how might this work? Well, it turns out in JavaScript, if we take a look at the blink.html file here, we'll see that you can, in your HTML, do something literally as simple as hello world in the body. But then you can call this function here. Turns out just like document, there's another global special variable you can use in JavaScript in browsers called window, which refers to all things related to the window itself. The window comes with a set interval function, which lets you do exactly that. Set an interval in milliseconds, and after every expiration of that interval, some function will be called for you. So in this case, it's saying every 50 milliseconds. But let's actually slow that down now to 500 milliseconds, or 1/2 a second. Call a function called blink. Notice I do not have parentheses after the blink name because I don't want to call blink now. I want to tell JavaScript to call the function called blink every 500 milliseconds. Now, we'll see in a moment what that code looks like, but let's go back to the page and reload. And you'll see now that it's a more pleasant blinking, if that's even the case, every 1/2 second, because I'm now firing that event. That is, I'm calling that function now every 500 milliseconds instead. How am I doing that? Well, in this same script tag, I've invented my own blink function. This has the distinction back in the day of actually being an HTML tag and among the few tags that the world removed and got rid of so that it's no longer used because it's not all that user-friendly. But down here, what am I doing? I'm getting the body of the document itself with this variable, and then I'm checking two CSS properties that we didn't talk about before, but it turns out that you can check and set the visibility of an element in JavaScript by going into that tag, checking its style, and getting its visibility property. And if it happens to equal hidden, the next line of code here, 13, sets it equal to visible instead. Else, if it's not hidden, it must already be visible. And so line 17 flips it the other way and changes it to hidden. Here, left hand, right hand, clearly not talking. No idea why the opposite of visible is not invisible. It's indeed visible and hidden. But this just allows you, every time this function is called, to change the property from one value to another, achieving that blinking effect. You can do even more powerful things that you and I take for granted every day. Let's go into source 8 and go to autocomplete.html, which I wrote in advance. And this is a page that also loads into memory a really big dictionary that you might recall from problem set 5. And if I go ahead and type in something like C, A, T, you'll notice dynamically an unordered bulleted list appearing below the text box that shows you all of the words in that dictionary from pset 5 that start with C and then CA and then T, just like the autocomplete you see every day on your phone in Google or websites like it. How is that working? Well, probably I'm listening for the key press going up. As soon as that key is pressed, I'm probably searching through a big array, really, of all of those words, maybe using linear search, maybe binary search if faster than that, and then looking for any string in that array that starts with C or CA or CAT. And then I'm generating automatically the HTML therefore. But perhaps most familiar nowadays is just how much your phone and your laptop know about you. And let me go into a final example here in source 8 called geolocation.html, which is a term of art that just refers to figuring out your geography, for instance, your GPS coordinates. Now, here we have a third and final global variable that your browser provides you with called navigator. And in navigator, there's a special object called geolocation that comes with a function called getCurrentPosition. So if you call navigator.geolocation.getCurrentPosition and then pass in a function of your own that doesn't need a name but does take an argument, in this case I called it position, as soon as the browser or as soon as the phone has figured out where in the world that user is with that browser at some latitude and longitude, the browser will automatically call that function for you, and you can do anything you want with the position that comes back, the latitude and longitude respectively. So I'm going to use a function that's not often that helpful, but for our purposes today, it's just going to write to the document itself, to my big rectangular region, whatever the latitude is, then a comma, and then the longitude as well. So if we go back with this final flourish into source 8, open up geolocation.html, you'll see that my browser first wants my permission to let this website, my own, know my location. I'm going to go ahead and click allow, crossing my fingers because it might take a moment for the phone or the laptop to figure it out. And it looks like, according to Google, I am right this moment with my Mac at latitude, longitude 42.375, comma, negative 71.11. Let's go ahead and highlight and copy that. Let's go to a website like googlemaps.com, crossing our fingers. If you've never done this, you can search for GPS coordinates too. Let's hit enter, and amazing. We are indeed in Sanders Theater, roughly there, standing on this stage on Halloween. And that then is week 8. We will see you next time. Happy Halloween. Nothing good? Buffering? Okay. Josh? Nice. Helen? Oh! Moni. No, oh, wait. That was amazing, Josh. Sophie? Amazing. That was perfect. Moni?
I think I...
Over to you, Al.
Oh, nice.
Guy? That was amazing. Thank you all.
So good.
This is CS50, and this is already week 9, which is our second to last. Indeed, this is really the last week where you'll learn in this class how to program. But indeed, it's this week that's really meant to be the pedagogical climax of like all of these various languages we've been looking at, all of these various techniques, all of this syntax, so that at the end of CS50 in just a few weeks, you indeed feel that you didn't take a class on C, and you didn't take a class on Python, but you really more generally took a class on programming. Because indeed, we know already about half of you will go on to study computer science further, but half of you will not. And indeed, all of your programming chops here on out theoretically will have a foundation in what we've been doing these past many weeks, but here on out, it's really going to be up to you to learn some newfangled language when it comes out, or to follow some new trend when some language eclipses the ones we've been using as more popular, as more appropriate for problems you want to solve. And so today really is about synthesizing so many of the past few weeks, but doing it in the context of web programming, which for better or for worse is so very much in vogue nowadays, both on our laptops and phones. And indeed, the languages we looked at in recent weeks are used not only to make websites, but also full-fledged applications applications and app stores and the like. So this really will be the culmination of those past several weeks. And indeed, we'll even talk about some familiar concepts like shopping carts when you're on Amazon and these things called cookies when you're visiting websites. All of those topics, too, will come into play, and you'll have an understanding of what all that means from the ground up. So how did we get here? Well, just last week, we focused on HTML and CSS primarily, which are not programming languages. They're just about aesthetics, structuring your data, presenting your data, and so forth. And we served the web pages we wrote using this program, HTTP Server. This is just one such program. There's dozens, hundreds of different web servers that you can use out there. This is just a super simple one we pre-installed in your code space for you in VS Code so that you can just serve up web pages. At the end of last week, too, though, we teased JavaScript, a full-fledged programming language that you can use to manipulate the user's experience for the better, to make things more dynamic and interactive by actually running code in the user's browser on their Mac, their PC, their phone, as opposed to server side, which up until now is where all of our code in C and Python has been written. So you're writing code on a server, you're serving code from a server, but now with HTML, CSS, and JavaScript, it's getting executed in a browser. But today, we're going to give you one final feature of Python or really languages like it that you can also use code on the server to generate automatically, dynamically, the HTML, the JavaScript, the CSS that you actually want the user to receive. You don't have to hard code everything as you have when making your own home page. Well, let's consider what some of the building blocks were last week. So here's a sample URL, and over here / is sort of the default page on any web server. It might be index.html. It might be something else. That's just a convention, but it refers to whatever the default actually is. You can visit, of course, with any browser, like a URL that ends in file.html or something else.html, and that literally means your browser wants this file on this server. Or, of course, we saw that it can be a folder, and inside of that folder is presumably some default file name, like, again, index.html. Or you can be more explicit, like folder/file.html. And these more generally we just called paths. And indeed, a path is just a location on your Mac, your PC, or on a server of some piece of information. But today, we're just going to rename this only to use other common terminology, but they're really just synonyms. Today, we're going to refer to those same things as routes. Because now, today, we're going to ultimately replace HTTP Server, which just serves up static content that you all write, with your own web server. Like, now you will be the ones controlling what it is the server does in response to the user's requests so that you can respond interactively and dynamically. But we're still going to see techniques like this. These were our so-called HTTP parameters. They're everything that comes after a question mark in a URL. And it can be like key equals value. And an example was what? When we played with Google, what was the key and what was the value that I first tried? Any recollection? I was searching for cats, and so the key I figured out was Q, because that's what Larry and Sergey, who created Google years ago, decided the name would be of the HTML text box that you type your query into. And if I type CAT for cat, the value of that would end up in the URL for Google as being cat equals value. And I mentioned that it's often the case that you want to send two different inputs to a server, and this is why I propose that you just keep an eye out for ampersands. And ampersands separate these key value pairs. But again, this is the same darn paradigm as before, and we've seen this so many times, right? Key value pairs in dictionaries in Python. We've seen HTML attributes and their values. We've seen CSS properties and their values. It's all the same thing, associating something with something else, even though every language, every person seems to have their own vernacular for it. It really is just the same idea, this associating of something with something else. We'll continue to see. And here, to be concrete, were the HTTP lines of text that were in those virtual envelopes, if you will. If I were indeed trying to search for something like cats on Google, this, recall, was the message that got sent to the server by my browser in order to tell Google to please search for not dogs, but in this case, cats. Now, what has HTTP Server been doing for us? Well, it's just been serving up HTML files, CSS files, maybe some JS or JavaScript files, but it has been ignoring any HTTP parameters. Like, HTTP Server does not take user input. Why? Well, what's it going to do with it? Because you already wrote the HTML, you already wrote the CSS. Like, there's no decisions to be made until we introduce a proper programming language on the server. And so we're going to move away now from this simple HTTP Server program and introduce you to your own server that's going to handle the parsing, that is, the extraction of these key value pairs, so that you and I don't have to write Python code all of a sudden that, like, analyzes this stuff, figures out what page is requested, requested the key value pairs. All of that we're still going to get for free by just using the right framework. And so today we revisit Python, which we've now used in some form in the past few weeks. And indeed, it's kind of been the glue that allows us to stitch together some of our own logic. We saw it with SQL. We're going to now see it with HTML, CSS, and even JavaScript if we want. And we're also going to see another language today, not a programming language, called Jinja. And this is going to be a common paradigm in the real world whereby different languages, different libraries, different frameworks often like borrow from each other, or they use technologies that someone else wrote just so they don't have to reinvent that wheel. So Flask is just a framework. That is a third-party library. It's pretty popular nowadays. It's relatively simple, which is why we use it in CS50. If you've programmed before CS50, Django is another popular framework or library in the Python space, but it's a little more complicated, so we focus on Flask. And Jinja, we'll see, is not a programming language. It's just going to be some syntax, thankfully familiar, with curly braces that allow us to use placeholders in our actual web pages. So again, you'll wrap your minds all eventually around where the lines are among these various technologies, but these are not the interesting ideas. The interesting ideas are the ones we'll focus on in code. But starting today, instead of running HTTP server to serve up a static website, we'll have you start running literally Flask space run in your terminal window to run your own web server that's implemented in Python using this Flask framework. So Bootstrap was a library for making your CSS and JavaScript prettier and more interactive. Flask is a framework or library for just making your Python code more pleasant to use, since you're borrowing features from someone else. All right, so how can we go about doing this? Well, if you were to write your very own web application, your own Amazon.com, your own Google.com, in Python using Flask, minimally, you need to have a file called app.py by convention, which is where all your Python code goes, and then a folder called templates, which is where all of your templates go. And for now, your templates are just your HTML files. So if we're going to now start building more interesting interactive things like Google.com or Amazon.com, we need to be able to execute code on the server. And so this is the convention. It's not index.html anymore necessarily. It's these two things at the top level. With that said, we'll quickly see that there's some other conventions. And in my examples online and in the problem set 9, you'll see another file called requirements.txt, which is just a text file that allows you to enumerate all of the third-party libraries your application might want to use. It's a convention so that the server can like automatically install things for you without you having to do it manually. And then static is going to be where literally your static content goes. So if you've got images for your web application, if you've got JavaScript files, CSS files, by convention, that goes in static. These are just conventions. Like all of this can be changed, but this is like the way to do things. So we'll introduce you to the defaults. All right, so what does this mean? How, for instance, could I go about implementing my own web application using Python that somehow spits out a message like hello world? All right, well, turns out just this. Now, we'll tease this apart in just a moment, but this is the contents of a sample app.py file that apparently uses some library stuff, like familiar syntax from something, import something else. We've seen that before with CSVs and other libraries. This is somewhat new syntax, but it's kind of copy-paste for now. This is definitely new syntax and kind of weird with the @ sign here, but we'll see this again and again today. And it's just copy-paste initially until you understand what it's doing for you. But at least there's some familiar stuff here. Like index.html is still going to be with us, but it's going to be up to us when and how to show it to the user. So let's make this more real. Let me go over to VS Code here, and let me go ahead and create a, how about we'll do this in hello. Let me do make dir hello to make a new folder called hello, and I'm going to cd into it just to isolate all of these files to the same directory so that we have different apps today in different folders. And now I'm going to do code of, let's do this. Actually, let's do our make dir templates.html. Sorry. Not templates.html. Let me rename that to templates using the mv command. This has nothing to do with web programming. This is me making typos. So if I type ls now, I've got a folder called templates. All right, in there, let's create a file called index.html that is going to be super simple and pretty much copy-paste from last week. Let me hide my terminal window, and let me just very quickly whip up a simple hello world page using my HTML tag, lang will equal English. Then inside of this, I'm going to have a head tag. Inside of this, I'm going to have a title tag, and I'm just going to call this thing hello. I'm going to then have a body. And in this, I'm only going to say something simple like hello, comma, world. And just so this is mobile friendly, recall that we touched on these meta tags. So just in case you, after class, play with your mobile device instead of your laptop, I'll do name equals quote unquote viewport. viewport, and then content equals, and I never remember this. I'm literally reading it off of a cheat sheet. Initial scale equals 1, width equals device width. And this is just this magical incantation that says to the browser, like, size things appropriately for the size of the device. It blows up the font sizes a bit. All right, so that's what I would have done last week. And I would have served this web page by running HTTP server in the same directory. And boom, I would see that HTML. But let's now start to take some control over the user's experience. And for now, it's going to be underwhelming. It's just going to always say hello world. But in a moment, version 2 is going to say hello David or hello Carter a bit more dynamically. And we'll quickly escalate from there to just more interesting applications as well, culminating with things like cookies and shopping carts and the like. So let me go back into my terminal window. And as promised, let me create another file called app.py. And this is where now I need to implement the web server I'm going to run using this Flask framework. And for now, I'm just going to kind of do some copy paste from what we saw on the slide a moment ago. From the Flask library, which we've pre-installed for you, I'm going to import a function called Flask, capital F. It's subtle, but it's important there. And I'm also going to import a few other things, a function called render template and another variable called request. And the only way I know this is from having taught this before, read the documentation, followed a tutorial. Like, you wouldn't know this unless someone told you or you read how to do this. But what this means is that this library called Flask has 3 things in it: a function called Flask, capital F, a function called render template, and a variable built into it called request. And this is going to be all the building blocks I need to implement my own web server. The convention in Flask, when you want to create a web app in Python, is you create a variable by convention called app, and then you assign it the return value of that Flask function, capital F, and pass into it underscore underscore name underscore underscore. Which is weird, but we have seen this before. A few weeks ago, anyone recall when and why we mentioned underscore underscore name underscore underscore? Yeah.
I think was it during Python at main or something?
Yeah, if we wanted to check if the name of the file was itself main, so that we avoided a situation where if you're writing your own library code, you don't want your code to be executed automatically. You want to potentially execute the main function. And that was a solution to that problem here. For today's purposes, this is just the way you do it. Underscore underscore name underscore underscore refers to the current file. And so this is just a little trick that says turn this file into a Flask application. That's all it is. And for now, that line suffices. All right, what do I want to do after that? Well, now I'm in charge of the web server. I need to write the code that decides, based on the browser's request, what file or files I'm going to send from the server to the browser. Last week, HTTP server did all of this for us, just based on the file name. But today, I'm going to take over control over that process. And the way I do that is as follows. I say app.route with, weirdly, an @ sign in front of it. This is known in Python as a decorator. And it's a feature of Python, not of Flask, that we just didn't introduce in weeks past. But it's a handy trick to do what we're about to do. The route I want to define is quote unquote slash. So that is, here is code I want the server to execute whenever a user visits /, the default page of the website. Well, what code do I want them to execute? Well, I want them to execute a function, and I can therefore define in Python a function. I can technically call this thing anything I want, x or y or z. But because they're accessing the default page, otherwise known as the index of the site, I'm going to just more reasonably call this function index. But just a convention, you could call it anything you want, but x, y, or z is probably a bad stylistic choice. It doesn't need to take any arguments in this case. And the only thing this function is going to do is, for now, let's go ahead and have it return hello world, quote unquote, and that's it. All right, now let me go into my terminal window. Let me go ahead and do Flask run in the same directory that has app.py and hit enter. I'm going to see some cryptic output, but including a URL of my code space. And if I open that URL after hovering over it, I'll indeed see hello world, as you might hope. But let me do this. Let me go ahead and right-click on the page and click View Page Source, which, if you haven't done before, shows you all of the HTML for a page, however pretty or messy it is. And that's it. There's no HTML that I've spit out. It's just quote unquote hello world. Well, if I actually want to spit out a full web page, which is not a big deal here because who cares? It's just the text anyway. But if I want to spit out a whole file, let me do this. I want to return essentially the contents of index.html, which have all of the tags I want, the mobile-friendly stuff and all of that. Well, I can't just return index.html, but I can return this. Render template, quote unquote, index.html. And per the documentation for Flask, this render template function will go find that file for me in my templates folder by convention. It will open it up, and then it will spit the whole thing out to the browser for me. So I can keep all my HTML in one place and all my Python code in this one place. So now if I go back to my browser and reload, I don't think I'll really see a difference because it's the same text ultimately. But if I view page source now, notice that, there is all of the HTML that was just sent to the browser. So this is only to say we have the building blocks, the puzzle pieces, if you will, via which to now store all of our HTML in one place and presumably CSS, JavaScript, and so forth, but then serve up whatever we want, even though I'm just blindly spitting out index.html. So before we proceed, any questions on this, which again I claim is like my manual version of what HTTP Server was doing for us automatically last week. But this is how you do it yourself. Any questions? All right, well, let's make it more interesting, which we could not do with HTTP Server and HTML alone. Why don't we go ahead and do this? Let me visit the same URL, and I'm going to zoom in. And your URL will differ from my code space, but it's going to end similarly here. I'm going to do / name equals David, for instance, or Q equals cats, or name equals Carter. Any key value pair I want, I'm going to append after a / and a question mark, thereby providing user input to the server, albeit in a very user-unfriendly way. No one's going to normally do this in their browser. Enter. Nothing changes here. It just says hello world. But wouldn't it be nice if it says hello David? Or equivalently, if I zoom in here again and change David to Carter and hit enter, wouldn't it be nice if it says hello Carter instead? So we need some dynamism there. And here's where now Python is going to be our friend. If I want to access the HTTP parameters that the user has provided via the URL, be it Q equals cats or name equals David, I can use this special variable I already preemptively imported earlier. And I can do this. If there is an HTTP parameter called name in what I'm going to call request.args, then I'm going to go ahead and create a variable called name, and I'm going to set it equal to request.args bracket name. Else, if there is no quote unquote name key in this special variable called request.args, I'm going to just assume that the user's name is world by default. Now, what's going on here? Well, it turns out that Flask provides us with this special variable called request.args. And in there is all of the key value pairs that might have come in via the URL. So if you had to guess what type of data or what data type is request.args, that's its name, and here it is in context. Line 9 might provide a clue. In Python, what data type might request.args be? Yeah? It's not going to be an array or a list, because those are always, in every language we've seen, numerically indexed, but you're close. Someone else? It's a dictionary. So a dictionary is similar syntactically to a list in Python, but instead of numeric indices like 0, 1, 2, you can literally use strings like quote unquote name. Now, that's a bit of a white lie. It is a dictionary, but it's Flask's special fancy version of a dictionary. But the syntax via which you can access it is exactly the same. And actually, this is a typo. I didn't mean to say names there. I meant to say name singular. But otherwise, I think the code is correct. This is going to, on line 8, check if there's a key called name in request.args. And if so, it's going to set it equal to that value. Otherwise, it's going to default to world. I deliberately did not do this. I added this if else and did not do this. Why? What error might happen if I just blindly grab name? Exactly. If there was nothing at the end of the URL that was of the form $name equals someone, then there would be no name key. And this is a couple weeks back, but this would give you one of those annoying key errors when you get a trace back because you screwed up because you used a string that doesn't exist. That's why I'm just proactively trying to avoid that situation, just like I might have a couple of weeks ago. So even though it's more verbose, this is just much more defensive so that I don't accidentally index into a dictionary where there is no key. But we'll see how we can tighten this up to be not 4 lines, but 1. But I think now I can do this. Wouldn't it be nice if now in my index.html file, which recall is in my templates folder, wouldn't it be nice if I could do the equivalent in C of like a %s here, for instance? Or in Python, something like this name. Well, it's close. And this is just because different humans invent different languages, invent different frameworks. The syntax for this in Flask is to actually do, 2 curly braces and then name of the variable inside of it. Why? It's just probably someone figured, what are the odds that a normal person is ever going to use 2 curly braces at once versus just 1? So this is probably decreasing the probability that people actually want to output literal curly braces like this. So it's similar in spirit to Python's f strings. It's similar in spirit to C's %s. It's similar in spirit to SQL's question marks. Same idea, slightly different syntax. And this here is Jinja. So it's not programming code per se. It's just a template. And indeed, that's why this folder is called templates. It is sort of like a blueprint for what I want to be spit out to the user. But I've got these placeholders, like this variable, that I want to plug into that value. Now, this alone is not enough. Watch what happens if I go back to my other browser and I reload the page after changing up here. Let's do name equals David again. Enter. Nothing outputs after the hello comma. So it seems that the name variable doesn't exist yet. And that's why, indeed, if I do view page source, you can see what was sent to the browser. Something's wrong with my placeholder. But I just need to be a little more explicit as to what I want to send where. So it turns out that the render template function takes not just one argument, the name of the template you want to spit out, but it takes, after that, with commas, all of the placeholders you want to plug in. So for instance, if you want the placeholder to be this, literally placeholder inside of those curly braces, you can then specify as the second argument to render template a placeholder named argument equals whatever the name is. So name is the variable in the lines above. Placeholder is the name of my literal placeholder in the curly braces. And so now if I go back to my browser and reload this with still quote unquote with still question mark name equals David in the URL, now I indeed see hello comma David. And if I zoom in here and let me move over here, let me type in Carter and hit enter. Now I see hello Carter instead. Now, this is a little unnecessary to explicitly call the placeholder, especially if you want to have 2 or 3 of them. So you can actually call this anything you want. And I'm going to change it back to name, which is a little more straightforward. The only weird thing here is that now you'll see that you're writing code like this. And this is correct. And this is the norm. It just looks weird. But the thing on the left of the equal sign is the placeholder you're using in the template. The thing on the right can be any value you want, including a variable. So even though I'm naming them exactly the same, which looks stupid, admittedly, like this is what people tend to do, just because it's simpler than introducing another word like placeholder. Any questions now on this? Any questions on these placeholders? No? All right. Well, let's tighten this up a little bit and see if we can't get things to be more dynamic still. Let me propose now that instead of using this condition, which made a very simple idea, like very verbose with 4 different lines, it turns out there's an easier way to do this. You can actually still create a variable called name. And you can set it equal to request.args. But instead of just blindly indexing into that dictionary, it turns out that request.args comes with a function as well called get. You can pass it an argument that tells you what value you want to get. And by default, if there is no key called name in that dictionary, this function will not throw a key error. It's just going to return none, N-O-N-E, the special value in Python. So it avoids a bug in your code, but it tightens up 4 lines into 1. But even nicer, if you read the documentation, the get function can also take an explicit default value. So if you don't want none to be on the screen, like hello comma blank, or I mean, that would be weird too, you can just put in a default value per the documentation of this function, like world. So now we've gone from 4 lines to just 1. So arguably, it's better designed. And if I go back to the browser now, still with Carter in the URL and hit reload, same thing happens. But we'll notice this. Suppose I get rid of the name parameter altogether and hit enter. Now it goes to the default instead, world. So it's just a little better designed than doing it the other way instead. All right, how about we take things up one more notch? And how about we introduce multiple routes and actually introduce perhaps a form to the mix. Because again, no normal person is going to like visit a URL and add a slash and a question mark in their name. Like that's not how browsers work. Well, that's how browsers work. That's not how humans interact with browsers. You and I use a form typically instead. So now things can get a little more interesting when making our own web application, because maybe we could do something like this. Let me go and zoom out again. Let me go back to my code here, and let me move this around and focus now on the index.html file. Instead of just this placeholder, why don't we go ahead and give ourselves a form like we've played with a little bit in the past, be it for Google or something else. And let's do this. Form, and inside of this form, let's have an input. And the name of this input will be quote unquote name. So that too is confusing, but inputs have name attributes, but this is a person's name. So I'm saying name equals name here. So just a messy world of semantics. And let me go ahead and make this a text box by default. And then let me give myself a button whose default type will be submit. And the name of this button will be greet, for instance. So let's see what happens here. But let me change app.py to just be the original simpler. I'm not passing in any placeholders now. And I'm going to even get rid of this. I'm just going to rewind to the first version of this for simplicity. Let's now change the URL to get rid of Carter and myself. So we just go to slash and hit enter. And now we have a super simple form again. All right, this is not super user-friendly, but there's some nice enhancements we can make. For instance, like we can, for instance, turn off autocomplete, especially if I want to type David and Carter manually and I don't want it finishing my thought during class. We can do autofocus, which puts the cursor there blinking by default, which is nice because then the human doesn't have to deal with that. And then we can even have a placeholder attribute. Placeholder equals name, so that it's like built-in instructions for this thing. And so now if I go back to the other tab, nothing's changed yet because I have to download the HTML again, reload. OK, now it's a little more user-friendly. It says name in light gray. The cursor is blinking. And I'm sort of ready to go. But this form hasn't been wired up to go anywhere yet. And so let's do this. Let's, for instance, say that the action of this form is not going to be something like google.com, which we did last time with for cats. I am now going to be both the front end and the back end of this website. The front end is what the human sees, the web page, the graphics, the forms. The back end is the stuff the human typically doesn't see, the Python code, the SQL code, the server itself. But now I'm in control of both sides of the experience, the HTML and also the routes. So let's just propose that we invent our own route. And instead of calling it /search like Google does, let's call it /greet. And let me specify that the method this form will use, which is technically the default, will be get. And confusingly, it is lowercase get, even though in the envelope we keep talking about virtually, it's actually capitals. Again, left hand wasn't talking to right hand when these things were decided. All right, so all I've done is create a web form that's going to submit whatever the text box value is to a route called /greet. By default, because there's no HTTP or HTTPS or no domain name, /greet is going to be assumed to be not at google.com, but whatever my own server's URL is. So whatever my code space's URL is, that's going to be the implicit prefix. This /greet is just the route. So now let's go back to VS Code's app.py file. How do I now stitch this together? Well, I think we're good to go with index.html. If index.html's purpose in life is just to spit out this form, we're done with one of my routes. But if I want to have a second route, greet, that actually spits out some greeting to the user, well, let's prepare that template too. Let me go ahead and highlight all of this HTML. Let me go back into my terminal window and into my hello directory and then into my templates directory. And let me create another template called greet.html, whose purpose in life will not be to show a form, but to greet the user with hello so-and-so. So in this file, I'm going to paste all that same HTML, but I'm going to get rid of the form and essentially revert to our previous version, hello, comma, and then using the Jinja syntax, name. So one template, index.html, is for the form. The second template now is for the greeting of hello, comma, so-and-so. But otherwise, these files, notice, are almost the same, except one has the form, one has just the hello. So now let's finish this up in app.py. Let me go down here after a couple of blank lines stylistically. Let me do app.route, quote unquote, /greet. But I could call this route anything I want. I'm just using a reasonable verb. Then let's define another function. I could call the function anything I want, x, y, or z. I'm going to call it more reasonably greet. no arguments. And then now is the code where I want to render the template. So I do return render template greet.html. But I need to do one more thing. What else do I want to do if I want greet.html to have access to the human's name? Just to recap. I think we solved this already, but I deleted it. But what do I have to add back? Yeah. Yeah, so I got to pass in the placeholder somehow. So I can do this a couple of different ways. I'm going to keep it a little more elegant this time. I'm just going to put my name argument there, and I'm going to set it equal to request.args.get quote unquote name comma world. Before I used a separate variable, but I only used it in one place, so that's not strictly necessary. So this is fine too. But if this gets a little overwhelming, notice that I can alternatively do this. I can create an actual variable called name, and then I can pass in an argument called name with a value that is that variable. But again, what's really the point here? It was kind of prettier all on one line. So these are the exact same things. I'm just trying to tighten things up further here. All right, so what just happened? If I go back to my form, this is still index.html. If I reload it, nothing has changed. If I type in my name to this form, notice again, the URL I'm currently at, this is Chrome hiding things. It's technically / by default, even though many browsers are just hiding unnecessary characters these days. But watch what happens now if I scroll over here and I click greet on this new form. Notice my URL, my route changed to /greet, question mark, name equals David, and the body of the page at top left says hello, comma, David. So this is exactly how google.com works, and it's how we implemented search.html last time. But instead of submitting the form to Google via the form, I'm submitting it to myself, my very own route. So I'm implementing my own backend for this same front end. All right, any questions just yet? Much less interesting than Google, certainly, but we kind of have all of the wiring now. Any questions? No? All right, so what can we do to further tighten this up and adhere to some conventions? Well, let me propose that in this version, we solve one problem. And even if you've never done this sort of thing before, I dare say we have enough weeks of CS50 where if I show you index.html again and greet.html again, odds are, to someone's mind, there's an opportunity for improvement. Why is this web app, super simple though it is, arguably poorly designed at the moment? And the answer lies somewhere in these two templates, index.html and greet.html. Yeah, they're almost the exact same except for the contents of the body. And, you know, it wasn't a big deal. There's only 2 pages. So what? I copy-pasted this once. But imagine now a normal website or even your home pages, which had 3, 4, or more pages. I mean, at this point, you're just copying and pasting everything, honestly, as you probably did necessarily for your home page. Why? Because when you have HTML only, maybe CSS, and even JavaScript, that's all you can do is copy-paste, and just make sure that you have the same structure. Maybe you have the same CSS file, the same JavaScript file, the same third-party libraries. But it makes it very, very annoying, as you might have realized already, to just make a change that affects everything. So wouldn't it be nice to like factor out all of this and all of this and just let the body change? So here, too, is something that Flask and really other equivalent frameworks let us do. It allows us to create what we're going to call conventionally a layout instead. So I'm going to go ahead and do this. I'm going to copy one last time all of the same HTML. I'm going to go into my terminal window, and I'm going to create, by convention, a file called layout.html. This is truly going to be a blueprint of sorts. And in layout.html, I'm going to paste all of that same code, but I'm going to use now some Jinja syntax to indicate that I don't want to plug in just a variable like name here. I want to actually plug the contents of a whole other file. So instead of just using curly braces, 2 of them left and right, I have to use slightly different syntax to say I want a whole block of HTML here from some other file. And the way to do this, even though the syntax is a little non-obvious, is you use open curly brace, %, block. Then you can call the next word anything you want. It just has to be a special type of placeholder for an actual file, not for just a variable. I'm going to call it body only because I'm in the body, so I want a placeholder to be the entire body. And then outside of this, you then say in one word, no space, end block. So it looks kind of stupid, honestly. And why do we have yet more ugly syntax? Again, just different software developers in the world are all choosing their own syntax for their own libraries. So they all kind of look different, but are all kind of similar in spirit. And you just get used to seeing the different syntax. This now is not nearly as pretty as the pair of curly braces for variables. But this is how I can say plug the contents of an entire file here. And now what does this let me do? I can now go back into my index.html file, which at the moment still looks like this, but almost all of this is copy-paste. The only lines that are interesting and different are these 4 lines here in the body. So what I can actually do now is I'm going to highlight that and cut it. And then I'm going to highlight everything else and just delete the entire file. And I'm going to use some of that same syntax and say curly brace %, extends, quote unquote, layout.html. And then I close my thought with a % and close curly brace. So this syntax, as you might just be inferring, is now saying, please extend whatever layout.html looks like. That's the original blueprint, the mold out of which I want to make this web page. And now here, the syntax is a little weird too, but similar at least from before. I can now say the body block that I want you to plug into that layout is going to be everything between these 2 tags, which we already saw earlier. But in layout.html, they're sort of giving a placeholder. In index.html, this is what I'm going to plug in to those other placeholders as well. So I'm just going to give myself some extra white space. I'm going to paste the HTML that was there. If I want to make clear what's going on, I can indent it, although this has no functional impact. But it just makes clear that just like in HTML, you can open a Jinja tag and close it. But in Jinja here, we have this here, hey Python, here comes the body of this page. Hey Python, that's it for the body of this page. And all of this stuff should be plugged into this main parent layout, if you will. So super ugly, admittedly, but now at least things get way less redundant because I'm going to do the exact same thing over here. In greet.html, it looks like this, but now I'm going to do this. Extends layout.html also, just as before. The body that I want to plug in is going to be everything inside of these tags here. And this body is just going to be hello, comma, name in curly braces like that. So again, ugly. Syntax got really ugly fast. But it's really just following these patterns now. And we have 2 types of placeholders, 2 curly braces for variables. And now this kind of syntax with the % and the single curly braces for like contents of actual files. And so now, in this world, or in the world of a home page, if you were using Flask and Python to make your personal home page with all of those various pages, you would probably design one main layout with all of your pretty logos and colors and fonts and like what you want the site to look like. And then each of your smaller pages would now be distilled into just these smaller fragments. And whether you're using Python or Java or JavaScript or other languages too, all different programming languages have popular frameworks that do things like this. The idea is the same across all of them. All right, let's see if it works. Let's go back into the browser. Let me go back to my /route. There's that same form. Let me type in David and click greet. And indeed, I see hello, comma, David. I see that greet was automatically added to the URL by the browser when I submitted the form, followed by the key value pairs. And if I view the page source as I did earlier, you'll see that you have the entirety of that layout with hello, David plugged in. Meanwhile, if I go back to the form and view this page source, you'll see the exact same layout, but with the form tag plugged in. And here's where you can be a little less nitpicky with styling. OK, yes, this isn't technically indented inside of the body, but it was relative to the original file. So at this point in the game, you don't need to worry about your outputted HTML looking super pretty. You want your source code that the humans see to be pretty, not the browser. This is not a stylistic concern. Whew. OK, questions on these capabilities then of Flask? Or problems that we've just solved and why? Yeah? OK, so if the files in question are in different folders, for instance, if I go back into my index page, which has the form, the routes here are entirely dependent on what is in app.py. There's no notion of a folder when it comes to implementing a web application anymore. They are more generically routes. However, and we've not done this yet, you can put your static content, your images, your video files, your CSS files in a folder called static, and there can be subfolders therein, and that would affect what you use as your source attributes for images, or your source tags for video, or any of those kinds of assets. And we'll see that eventually in the problem set next. Other questions on what we've just done here? Yeah? Good question. How did I ensure that the web app starts on the form and then goes to the hello page? So whatever you decide your default index route is, like the implicit slash, that is what is going to be pulled up when a user visits the domain name where your website is hosted. So if I go back over here to app.py, because my slash route is designed to return index.html, that's exactly why that response came back. Good question. All right, so beyond this, let's consider now issues of privacy. And we'll touch on this, too, as we get to issues like shopping carts and cookies. If I zoom in on the URL here, even though the URL itself is a little long and ugly and cryptic, but when I type in my name and hit greet, of course, we keep seeing name equals David in the URL. In what sense might this be bad design? Or in what kinds of web apps might you not want the name to show up in the URL like that? Because this is what Google does, and this is what my app does. Yeah. Yeah, so if I'm logging in with a username and password, I could imagine that they show up in the URL after the question mark, where username equals Malin and password equals 12345. But then all my, like nosy siblings need to do is go through my browser history, and boom, like it's right there for them to copy paste. So that doesn't seem particularly secure. Or if someone's walking past you in a cafe, they can just look at your URL if it's revealed by the browser, and they see it too. So get is not necessarily the best verb to use, even though it's the default when submitting forms. Typically, when you've got anything remotely sensitive or anything large, so be it a password or credit card number or like an image or a video that you're uploading to Instagram or to YouTube or any such site like that, you don't want the data going into the URL. And thankfully, there's actually an easy way to fix this. I can go into my form, which is currently in index.html, and I can just change the method from get to post in lowercase here, but the verb in the virtual envelope we discussed last week would itself be capital P-O-S-T. Now, unfortunately, watch what happens here. Let me go over to my original form by going back to the slash route, and I'm reloading the page to make sure I get the latest, freshest HTML. And just as just to confirm here, yep, if I view source, method is now post. So let me go ahead and type in David now and click greet. And before we saw hello David. But now I get method not allowed. And this is somewhat subtle, but in the title of the tab, notice that it's a 405 error, which is not familiar probably. Almost all of us have seen 404, file not found. Turns out 405, a little more arcane, is the method. The HTTP verb is not allowed. Why? Because by default, my app.py only currently supports get by default. How do I support post? Well, I just need a little bit more syntax. So let me go back into VS Code here. Let me go into app.py now. And after changing the form, I just need to inform Flask that, you know what? The method I want this greet route to use should not be the default, which is only get. I want it to use these methods. And it takes a second argument called methods, the value of which is a list, the default of which is quote unquote get. So that's the default. This has not made any changes. But if I want to support post instead, I can explicitly pass a list with one string in it, P-O-S-T, instead. And now what does this mean? We didn't talk about this in any detail last week, but inside of this virtual envelope typically is that line like get slash search q equals cat after the question mark. If you want to hide that kind of information for privacy's sake or because you want to upload like an image, which just doesn't make sense to put in the URL, essentially the part of the story would be, well, the computer looks deeper inside of that virtual envelope, and anything submitted via post goes below the HTTP headers, like deeper in that envelope. So they're still there. They're just not obviously visible for prying eyes in the user's own browser. So just by making that change in the HTML, telling the browser to submit the data via post, and changing app.py to tell the route to expect the data via post, I can now go back to my other tab. Let me go back to the original page. Let me reload just so I've got the latest HTML. And indeed, view page source, it's still, yep, it's still post. But now when I type in DAVID and click greet, now it works. But, notice the privacy implication. I'm at the /greet route, but where's my name? It's not actually there. It still went to the server, but it's not in your autocomplete or your history now for privacy's sake. Questions now on post? Yeah, oh, no, just scratching. All right. Can you, the programmer, see this? Well, let me show you a couple of other features of Chrome and Safari and other browsers as well. I keep going to view page source, which just shows you like a read-only version of your HTML. But recall that last time I actually right-clicked and went to inspect or viewed developer tools. And this brings up a much fancier version of the developer tools. And under elements here, you see everything. And it's nice and pretty printed. It's hierarchical. It collapses things into these clickable triangles. But it's the exact same thing. It's just more interactive. But notice what I can do today is this. If I go to the network tab here, and let me zoom out a little bit. Let me go ahead and reload the form here and type in DAVID again and click greet. Notice now in the network tab of Chrome's developer tools, I see a few things as we saw before. One, I see that the request method is post. Two, I see that the server automatically, without me writing any code for this, returns 200 when it's successful. But I can scroll down, 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 down. And you'll see that eventually, after all these cookies, more on those later, if I click on payload, the second tab next to headers, you can see as the developer what was actually sent to the server. So indeed, this is going to be super useful like when doing problem set 9, maybe your final projects. If you want to see what's going from browser to server, you have complete control over all of that information. Even if you're using HTTPS, because your browser and you, the developer, can certainly see all of this. So again, these developer tools, even though there's a lot of tabs and buttons you probably won't need anytime soon, some of them, like Elements and Network and with JavaScript Console, are going to be super useful to start to get familiar with. All right, any questions now on this implication of post? Anything at all? No? OK, how about one final hello example that ties a few of these things together? How about now we try to tighten things up further, only in anticipation of something like problem set 9 or really more complicated web apps where you might have not 2, but 20 or maybe even more different routes. It might be ideal to just minimize how many total routes we have so we don't get a little too overwhelmed. And I dare say that these two routes are so short, maybe I can combine them into one. And maybe I can keep the user at what seems to be the same URL, but just to kind of tidy things up. So let me propose that we do this instead. Let me get rid of my greet route. And let me go into my form in index.html. And let me go ahead and just have the action of this form still be /. So I want the form to be visible at /, the index of the site. But I also want the form to submit to itself, if only because I don't want to introduce another route like /greet, which eventually, indeed, will be compelling so you don't have one route for everything you want your website to do. So technically, this is the default too. And if I omit action, the exact same thing would happen as well. But let me rewind. And let me now go into app.py to see how we can make this happen. Well, if I want my one and now only route to support both methods, I can say methods equals, and then in a list with both get and post in any order, but I'll keep them alphabetical like this. This now tells Python, hey, this route should handle both get and post requests at the same place. Let's now go into this function. I kind of want to say the equivalent of this. If get, then I want to return the form. Else, if post, I want to then return render template of greet.html with the user's name. But this is not yet complete code, but I think I can do this. I'm going to go ahead and say the following. I'm going to go ahead and say if request.method equals get, then indeed return index.html. If request.method equals post, then go ahead and return greet. .html. This isn't quite enough, though, because I still want to pass in that placeholder. So let me again add back name equals request.args.get, quote unquote name, and then a default value of world. What does this now do for me? Well, let me go back to my other tab here. Let me close the developer tools. Let me go back to the form here. Let me reload to make sure I have the latest. Let me view page source just to make sure I have the latest. And yep, I have the latest because it still says post, but it now says slash. And let's see what happens now. If I type in my name, David, previously this submitted via post, so I didn't see any name or value thereof in the URL, but I did end up at /greet. But if the action is now slash and I click greet, notice that it still kind of works. I see hello, comma, world, although that didn't quite work, so we'll come back to that issue in a moment. But notice the URL ends in just slash. And again, Chrome is hiding the slash because that's all that's there, but it does not end in name equals David in this case, or name equals world. Now notice this too. If I reload, I'm going to get this warning. Do you want to confirm form resubmission? The page you're looking for used information that you entered. Returning to that page might cause any action you took to be repeated. Do you want to continue? You might have seen this on websites you've actually visited where you hit reload and you're prompted, wait a minute, do you want to do that? Odds are you've been prompted to reload explicitly because why? Whatever you just did was post instead of get. And by convention, besides post being used for privacy, to like hide your username, your password, your credit card number, or the like, besides being used to upload bigger files like images or videos, post is also used by convention to make changes to the server, to add something to your shopping cart, to add something to the database. Whereas get, as the name suggests, is all about getting information, not posting or sending information instead. So this is Chrome being a little careful because, you know, if you just checked out on Amazon and then you hit reload, you don't want to accidentally like buy the same book again, so to speak, even though Amazon and fancy websites have other defenses for this too, to avoid this issue. Now, there is a bug though here. It says hello, comma, world instead of hello, comma, David. And it actually would have said the same a moment ago, and I just didn't retest the code and reveal as much to you. Or if I did, I didn't even notice it said hello, world instead of hello, David. It turns out that request.args is only used for get. When using get, request.args is a dictionary that contains all of your key value pairs. But somewhat confusingly, when using post with Flask, you have to go into request.form. I have no idea why these are not sort of more obvious opposites like request.get or request.form. And sorry, request.get and request.post would be sort of sensible names. In this case, though, we have request.args for get and request.form for post. All right, that's an easy fix, though. If I go back to VS Code here, let's change request.args to request.form. Let's go back to my other tab. Let me just reload. And you know what? I'm going to say OK, continue to resubmit the same form, because the form was OK. It was my Python code that was buggy. Hitting Enter, now it's accessing David OK. But watch this again. If I hit reload, Command R or Control R, I get the same warning. Are you sure you want to submit the form? Yes. If I do it manually with the reload icon, I get the same warning as before. But if I want to manually induce a GET request, well, that's fine. Don't hit reload and send the same request. Instead, go up to your URL and just put the cursor up there and hit Enter. And now notice, same URL is a GET by default. So anytime you and I have typed URLs into browsers, GET is always the default. Only when you click on a button, typically, that the programmer has configured to use post, are you actually adding things to your shopping cart or the like. All right, so we are back, and if I go way back in time myself, like this is actually like the first web application I made back in 1997, I believe. So at the time, this would have been, what, my sophomore or so year. I had taken CS50. I took a follow-on class called CS51, which is a different type of programming. And then I pretty much taught myself a language called Perl, which is somewhat less popular nowadays. But it's another language like Python, like Java, like JavaScript, like others that can be used to make web-based applications. And the web was very young at the time. And the process via which students, my classmates, could register for the first year intramural sports program, aka Frosh IMs, was to grab a piece of paper and like write your name and email address on it and walk it across the yard to Wigglesworth, I believe, where the proctor lived, and you'd slide the piece of paper under the door. And like that was how we submitted forms in my day. So this was an opportunity, even back in 1997-ish, to like move things online. And the website went on to live on until I think like 2007. I found this online, and then it's become something else since. But this was a website via which people could register for sports, and people could log in the scores for various games and whatnot. And so underneath the hood, I didn't even know anything about databases at the time. It was just like CSV files that I was storing the data in, but there were HTML forms. And there was, with Perl, the language at the time, the way to do the exact kind of stuff that we've just been doing already with Flask. And so what I thought we'd do is implement a slightly less ugly version of this. Repeating graphical backgrounds were in vogue in like 1997, as you can see here. But these were the aesthetics of the day, including the so-called blink tag. So let's at least focus on the functionality of this website and not so much the aesthetics, and see if we can't implement some of the plumbing for actually solving like a real-world representative problem, be it for freshman intramural sports or something else like it, where you're getting data from users and processing it somehow. So let me go over here to VS Code. Let me create a new directory called frosh ims, just so we can keep all of this code in its own directory. Let me cd into frosh ims. Let me proactively make another directory called templates, in which our templates, our .html files, do need to live. And eventually, I'm going to go ahead and create two files, minimally, app.py and index.html. So let's do the first of those. App.py will live in my frosh ims directory. And I'm just going to recreate something very simple like we have previously. So from Flask in lowercase, import Flask capitalized, render template, and also request. So same first line as before. Let me then give myself a variable called app, set it equal to calling the Flask function, capital F, with underscore, underscore name, underscore, underscore. And then let me give myself a route for slash, as before, with an index function, though again, I could call that anything I want. And just for now, let's return render template of quote unquote index.html as though that exists. So this is not really a web application as much as it is, at the moment, just a recreation of HTTP server for one file. Let's now, in another tab, create a templates file called index.html. And I'm just going to save myself a few keystrokes. Let me copy paste from earlier almost all of the layout from before. I've changed the title in advance to frosh ims instead of hello. But this is essentially the same template. And for now, though, because I'm in an index.html, I'm not going to use extends or any of that fancy block stuff yet. I'm just going to go ahead and create a relatively simple form via which, back in the day, my classmates could have registered for intramural sports. So let's go ahead here. And I'll propose that we do this. In this page, we'll have a form, the action of which will be a route called /register, though I could call that anything I want. It'll be somewhat private, so I'm going to use post instead of get, just so that people don't accidentally maybe register twice by hitting reload without warning. Inside of this form, let's go ahead and give them an input. Where autocomplete will be off, as always, for demonstration's sake. Autofocus, so the cursor goes there initially. The name of this field will be literally name, because I want my classmate's name if they want to register for some sport. The placeholder will, again, be quote unquote name, just so they see some gray instructions. And the type of this field will indeed be text as before. And then I need to give them the ability to register for a few sports. Why don't we keep it simple? Like back in the day, basketball, soccer, and ultimate frisbee were three of the sports that we supported. And so let me do this. And you might not have seen this before, unless you dabbled further with forms on your own. But I can create a select menu, otherwise known as a drop-down menu, in HTML, inside of which are a whole bunch of options. And each option typically follows this paradigm: the value of the option, and then the actual text that the human sees. So the value of these options will be, how about we do basketball as 1? And I want the human to see literally the same thing. Though just like with a link in HTML, they could be different, but I'm going to keep them the same. Another option will be, let's say, soccer. And whoops, let me fix my quotes. And this human will see the exact same thing, though it could say something else. And then lastly, the value will be, quote unquote, ultimate frisbee. And the humans will see the same thing there, ultimate frisbee. All right, so this is going to create, as we'll soon see, just a drop-down menu with 3 separate options. If I want the students to be able to submit this now, let me give them a button, the type of which is submit. And this button will be like the word register on it. So I think we're pretty much good to go. Like this is all just HTML, no Python, no Flask per se, except for the rendering of this same template. So let me go into my terminal window. Let me do Flask run inside of this directory, because I need to serve this app instead. I'm going to see some ugly output, including my own URL. And if I hover over that and then open that URL, I should now see a more interesting form. It's got not only a field for their name, but also this drop-down menu with all 3 sports. Now, this isn't maybe the best user experience thus far, because I feel like I'm biasing people to registering for basketball, maybe, because it's checked by default. I mean, a lot of forms nowadays have like a blank placeholder for the form. So this is just an aesthetic thing, but I can do this. Let me go back to this same form. And let me give myself just a blank option at the top that, in fact, I'm going to disable. So you technically can't select it proactively, but I am going to select it by default. And so we probably haven't seen those HTML attributes before. But if I want to create the equivalent of like a title for this dropdown, I'm going to literally create a disabled option that's automatically selected called sport, so that you can't select it per se, but it is there at the top. So if I go back now to my other tab, reload, it's just marginally prettier than before, and I'm not biasing people toward accidentally registering for basketball alone. And if I click on this, you'll see that sport is grayed out and therefore not manually selectable, but I can select any of these other 3 still. All right, well, unfortunately, if I type in David and I try registering, for instance, for soccer and click register, I do end up at /register. And there's no question mark or name or sport, so it's probably indeed post instead of get. Those are hints, but not found. Notice the tab here very succinctly says 404 not found. Well, why is that? Just to be clear, why did /register give me a 404? What's the logic here? Perhaps just state the obvious, or... It doesn't exist, right? We haven't done that step yet. All right, so something as simple as that. And so I actually sort of belabor that point, because as you're learning like a lot of these conventions and some of this new syntax, like honestly, you're just going to make stupid mistakes. Something's not going to work. But again, go back to first principles. Well, why is it not found? All right, /register should be a template maybe called register.html. Oh, I forgot my app.route. So that should be the kind of thinking as you try to diagnose these problems moving forward. All right, so let me go into app.py. And let me give myself a second route here. So app.route, quote unquote, /route. Then let me define a function called anything I want, but I'm going to call it, oh, sorry, not /route, /register. Let me call the function, just to be consistent, register. So, but I could call that anything I want. And just for now, let's not do anything too interesting. Let's just return the rendering of a template called success.html. Let's just pretend for now that registration is successful no matter who you are or what you do. Now, I need that template, and I only have index.html at this point. So let me actually now do my best practices. Let me copy all of that. Let me, in a separate terminal window, let me do code. Let me go into my frosh.ims directory. And let me create a new template called layout.html, just like before. Let me paste all that same code. Let me delete the form and just put in that big placeholder. So block body and then end block is all I did earlier. This is just kind of boilerplate now convention. Everything else I'm going to leave the same. But if I wanted to make it prettier, I could add my CSS up top. If I wanted to add like this crazy repeating background, I could probably do that up top too. So I could make every page look as ugly as it did back in my day. But we'll focus just today on the text. All right, so now that I have layout.html, let me clean up index.html. I don't need all this redundancy. I don't need all of these tags at the top. Instead, recall, I think I just need extends, quote unquote, layout.html with the appropriate %signs and curly braces. I then have the appropriate block body, though I could call body anything I want, but I'm going to stick with my convention earlier. And I'm going to delete the tags down here that I no longer need. Why? Because if I go into layout.html, I already have all my open tags, all my closed tags. The only stuff I want in index.html is going to be what belongs in the body. So end block down here. And just to be pedantic, let me go ahead and highlight all that, hit Shift Tab, and that will like unindent it just to line things up, just to be tidy. All right, so better, even though it looks a little cryptic now, but now I've laid the foundation for making a third page, a fourth page that don't have all of that same copy paste. All right, so now let's go back into app.py. Success.html is where I left off. So OK, let me open my terminal window. Let me code up a template called success.html, whose purpose in life is literally just going to be like to say, you are registered, just so that we see some informative message on the screen. So this part I do still need, extends layout.html. So there's a little bit of copy paste still, which is a little ugly, but so be it. Block body for this template. And I'm just going to say, you are registered, exclamation point. All right, and then end block. So super simple. It's just an informative message claiming that the student is registered. All right, let's go back to the original form, which is this. Let me reload to make sure my HTML has reloaded. Type in David. I'm going to register again for soccer and click register. And oh, interesting, method not allowed. So I'm not getting a 404 anymore. I'm getting 405 at /register. What's the deduction here? How did I screw up this time? 405 is progress, yeah? So it's not, the placeholder I think is OK. This is now about the underlying HTTP stuff. The method was not allowed. Say again? So get versus post thing, too. So by default, all of these routes in Flask just by default assume get, because it's safe. It doesn't allow you to send information to the server in quite the same way. But if I do want to support post, recall that we changed this to be methods equals, and then a list with quote unquote post in it. So I just need to enable support for that method. That is that HTTP verb. All right, let's go back to the form, reload just to make sure I haven't screwed up. Type in my name, David, select soccer from the dropdown, click register, and now I'm not only at /register in the URL, it claims that I am indeed registered. Now, of course, I've done nothing interesting. There's no database. There's no CSV file. We'll get to that in a bit. But at least I now have the plumbing in place to do something dynamic based on that sport. All right, well, how can I now improve upon this? How about we go ahead and store the actual registrants in a dictionary in the computer's memory. So instead of just claiming that they're registered, let's actually make a notation. And the simplest way, as we did weeks ago in Python, is just store things in like a variable in memory, like a list or a dictionary, a set, anything like that. All right, well, let me go back into VS Code and in app.py. And I think what I'm going to have to do here is change my register route to actually do some useful information. But before I register the user, let's consider where I want to actually put them. And so let me propose that. How about we do this? At the top of my file, let me go ahead and declare a global variable called registrants. And set that equal to an empty dictionary. So we've done this before when we were playing around previously with using dictionaries to store key value pairs. And I'm going to propose that we store the registrants as a dictionary. Why? Because I'm going to keep it simple. Like the name is going to be the student's name. Or sorry, the key is going to be the student's name, and the value is going to be whatever sport they registered for. So David in soccer and Carter in basketball. And so it kind of makes sense for like a two-column dictionary, so to speak, as we often depict it on screen. So how can I use this dictionary? Well, let me go ahead and do this. Down here under /register, let me go ahead and initially do this. How about we get the user's name from request.form.get and set it equal to whatever the value of name is. And I'm not going to give a default value now because I don't want to call the student world or something strange like that. I'm just going to assume for now that it's there. Let's then create another variable called sport and do request.form.get quote unquote sport to get the student's sport. And then let's go ahead and do this. In the registrants dictionary, let's index into it using the student's name, and let's set it equal to whatever the sport is. So I've got these variables just to keep my code tidy, and I'm now putting a key value pair in that, into that dictionary. All right. Well, what do I want to now do? And I'll go ahead and say success.html. Sure, let's go ahead and do that. But now I think success.html means that. So let me go back to the form, reload. Let me type in David and soccer, register. OK. Let me go back and say Carter and basketball, registered. OK. Now let's see what I want to do next. How about I go into, let me give myself another route, and let's play around here. So app.route, let's give myself another third route called registrants, whose purpose in life is just to show me who all of those registrants are, just like you would expect from a website like this. And then let me define a function called registrants or anything else. And then let me return the rendering of a template called registrants.html. and let me pass in, this is kind of neat. I can do registrants equals registrants, which again looks weird, but what am I doing? I'm presuming to pass in a placeholder called registrants, the value of which is this dictionary that I've been collecting all of the registrations in. So similar to the name placeholder before, but it's a little more powerful because now it's a whole dictionary, not just a single string. So I think now, let me be creative here. Let me go into my templates under my templates folder. And let's do this. Let's go into my terminal window. Let's create another template called registrants.html that's actually going to do this displaying of all of the registrants for us. So extends layout.html, just so I can borrow all of the same HTML as before. And let's define block body, just like before. And inside of this, end block, I want to put, I don't know, like a bulleted list or an ordered list of all of the registrants. So how can I do this? Well, let's do an unordered list, UL. And here's where Jinja and Flask more generally get kind of interesting. Like, I want there to be something like this, an LI, and then like the student's name, and then an maybe LI, yeah, like that, and then maybe like sport, something like this. But I didn't pass in a name. I didn't pass in a sport. I passed in the entire dictionary of registrants. Now in Python, if we were just doing something in the black and white terminal window and doing a command line program, I'd probably have some kind of for loop in Python. Jinja does allow you to do this. So a templating language tends to come with very lightweight mechanisms for doing placeholders, doing simple loops, doing simple conditions. So Python-like syntax, and it's almost identical. So watch what I can do. Inside of this unordered list, let me not start to manually output a single li. Let me use this syntax. The same Jinja syntax that I used for block. So curly brace, %, and I'm going to say this, for name in registrants. So this is just like Python syntax for iterating over a dictionary. And now this is going to look stupid, but the opposite of that is end for. So in HTML, you use the slash. In Jinja, you literally use the word end, no space, and then the name of the keyword. So end for is how you close this. But this is where templating gets really cool. You can now do li, and in here, I can do something like that student's name. And that's it. I'm going to leave it like that. And what I'm doing here is using really a template as templates are intended. I've got like the basic building blocks of what I want this output to look like. But thanks to this little for loop here, thanks to Jinja syntax, the curly brace and the %, I'm going to iterate over every dictionary, printing out name, 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 name. And so if I've got 2 kids registered now, I'm going to see 2 LIs, David and Carter, respectively. So let's see. Let me go back to my Frosh IMs tab here. And I don't have a link yet, so I got to do this manually, like a developer would. Let me go to /registrants, and I'll zoom out and hit Enter. And you'll see what you'll probably see, too, when making mistakes for the first time in this world. So where is the error message? Unfortunately, internal server error is not all that useful, but we do tell you see terminal window. So if I go to the terminal window, I haven't been paying attention to this for quite some time. And in fact, I have 2 terminal windows open so that I can still use commands at the prompt. But if I go back to my first terminal window, aka bash there, you'll see in your terminal window when developing web applications, like all of the mistakes you made in the terminal itself. This is one of those Python tracebacks that's related to me screwing up here. Now, let me go ahead here and let's see, type error. Function is not iterable. And block for name function is not iterable. All right, so what mistake did I make? Well, this is what happens when I don't follow my notes and make changes on the fly. So I have this variable on line 5 called registrants in all lowercase. But what did I then do on the fly here in line 22? I defined a function called registrant. So like newbie mistake, like I shouldn't have done this. I can't have a variable and a function of the same name because the symbols are literally identical. So just to make clear that this variable up here is actually global, we'll use our convention like we did in C often. When we had a global variable, we'll capitalize it all just to make it stand out like a constant value up there. And so down here, what I'm going to do is pass in registrants in all caps. So that was stupid. Didn't mean to confuse there. But the reason for that error, to be clear, is that you can't have a function that's the same name as a variable. I could just change the variable name altogether. I'm going to go ahead and just capitalize it to make it really stand out that this is, in fact, a global variable up top. All right, now I'm going to go back to my browser. Let's do David and soccer. All right, but there's going to be some other mistakes here. So on line 17, let me go ahead and change this variable to be capitalized there, because indeed I want to put the key and the value in this newly named variable as all capitals registrants. Let me now go back to VS Code here. Let me go back to the form, and let me start adding some data fresh. Let me register David for soccer. Clicking register now, and we should see you are registered. But hopefully now it's indeed in the computer's memory. Let me go back and register now Carter for basketball, clicking register again, and hopefully it's now registered. If I now change my route manually to b/registrants, which is this newly added route that I made, and hit enter, now I see, thank God, now I see the unordered list containing everything in the computer's memory. So when I say you are registered, I kind of mean it now, because the server is still running, and in the computer's memory is, in this registrant global variable, a dictionary of key value pairs. Of course, we're only seeing the keys at the moment, so it might be nice to actually see the values in as well. So let me go back to VS Code. And let me go into registrants.html, and I'll just do something a little messy. I'll just say, how about, well, just to make it a sentence, is registered for, and now another placeholder, I'm going to say registrants bracket name. So just like in Python, if registrants is itself a dictionary, registrants bracket, and then the key you want to index into is perfectly valid syntax as well. So now let me go back to /registrants. Let me click reload again. So why isn't it working, everyone? What's the bug that I introduced earlier? If David is registered for none and Carter is registered for none, but David and Carter are in the dictionary, like, that's a good thing. So some of the data is in there. So why are there no sports associated? Well, the first thing I literally just did in front of you all was I went to app.py and I stared at line 17 thinking, like, how did I screw this up? I'm putting sport as the value of the key, which is the student's name. All right, line 17 looked fine to me a few seconds ago, so I looked then with my eyes at line 16. And this too looked OK. My first thought was, oh, did I use request.args instead of request.form instead? Because that would have assumed get instead of post. But no, like, that looks OK too. So then my final instinct was, oh my God, did I screw up the HTML form? And so that's why I went back over to my tab here. I went to the original form here. I then view page source. And this might not be as obvious to you if you've never seen the select menu before. What is apparently missing here that might explain my mistake? Yeah. Yeah, I didn't name this form field quote unquote sport. Now, to be fair, you haven't seen me do this as a select menu before, and it's different from this input. When you have an input tag, you literally say name equals whatever on the input tag. It turns out, I don't know why I skipped this earlier. I probably meant to come back to it. The select tag also can take a name parameter. So if I go back to the name parameter here and go back and add the name parameter, let me go into that template, which is index.html. Let me add name equals quote unquote sport in all lowercase, which is different from the visual aesthetic of this temporary disabled option that's just there to make things prettier for the human. Now, let me go ahead here, and first, I'm going to go into my terminal window. And I'm actually going to hit Control-C to stop the server altogether, because I want to throw away the contents of memory and therefore get rid of that dictionary that had David and Carter and those none values. So this is sort of me clearing the computer's memory. I'm going to rerun Flask run. I get that same URL as before, so I'm going to hover over that and open the new tab. And just to be sure, I'm going to do view page source. And here I see now, OK, now the form has both a name and a sport in it. All right, now I'm really going to cross my fingers, because I intend for this now to work. David will register again for soccer, register. Claims we are registered. I'm going to go back and do it again for Carter and basketball, register. We still don't have a link, so I'm going to manually go up to the URL and change /register to registrants as before, zooming out and hit enter. And thank God, now I'm actually registered properly for this. So, thank you. So what is it, like 20 years later, I'm still struggling to implement this site? OK, so here now we have, for the first time in Python and web stuff, like now we have a proper web application. And it's not just echoing back, hello, David, hello, Carter. This could now work for any of you. And it's currently served privately. But if I made this URL public, I could put this on the web now and let anyone in the world register. But there's kind of some issues here. There's some security flaws potentially. And so for instance, let me go back to the web form here. And let me open up the Inspect tab, the developer tools, and just remind you that anyone on the internet, not only you, the developer, but an adversary, can see all of your HTML, see all of your CSS, see all of your JavaScript. But more importantly, because this is all client-side in the browser, there is literally nothing technically stopping them from changing the HTML, or at least their copy of it. And I did that last week with Yale. I changed their website. But no, I changed my copy of their website. But when forms get involved, you could maybe be actually malicious now. Because even though this drop-down menu only has basketball, soccer, and ultimate frisbee, suppose I really want to register for, how about, let's say, name your favorite sport. Volleyball. We really want to register for volleyball, but like this website won't let me. Well, there's nothing stopping me from going under the Elements tab in my browser, going into this select menu here. And you know what? Ultimate Frisbee. Let's change this to volleyball. And let's change this to volleyball. Enter. I'm going to close the inspector now. And as requested, now we support volleyball in the form. Now, it's not changed on the server, to be fair, but think about how HTTP works. When I fill out this with, say, let's see, Bernie's name, Bernie really wants to register for volleyball as well. At the moment, my code is just going to trust that what's in request.form is what was in the original form itself, no matter whether the human adversarially actually changed it. So if I actually submit this form and click register for Bernie and volleyball, even though that's not one of the supported available sports, if I now go to registrants, my website nonetheless has trusted that Bernie and perhaps you are registered for volleyball. So what's the implication of this? This has surely happened in the past when like really poorly implemented websites allow you to specify the price of an item, for instance, in your shopping cart. And they just trust that when you click submit or add to cart, it adds the price to the back-end server. If you're not validating the price and making sure, as with a database, that, wait a minute, that price is valid, or wait a minute, those sports are valid, like who knows what people are going to do to your site. And it's that simple to actually hack a website accordingly. Now, we can very easily fix this with some week 6 style Python. We really just need to do a bit of logic here. And so let me propose this. Let me go into app.py here. And at the very top, let me also create, how about a global variable called sports in all caps. And I'm going to set that equal to, in square brackets, the list of sports I actually want to support. So I'm going to put in basketball here. I'm going to put in soccer here. And I'm sorry, no volleyball officially. I'm going to put in ultimate frisbee here. So I've got this global list of supported sports. Now, think about how I made this form a while ago. I just hard-coded these sports here. Well, I don't have to do that. I can sort of draw upon my own official list of sports instead. So let me scroll down to my index.html rendering template here. Let me say that the sports I want to support are these. So just using the same placeholder trick as before, but I'm now telling the template what sports we currently support. Now, if I go back into index.html, I don't have to manually do any of this. Let me get rid of all 3 of those options, which I manually inputted earlier. Let me use my new trick with Jinja syntax and say for sport in sports. Then let me proactively say end for, just to finish that thought. And then in here, let me do option value equals, in curly braces, sport. And then so that the human also sees the same words, I'm going to say sport out here. So I've completely changed what was hard-coded, manually typed, to something now that's completely dynamic. So now it's not going to stop someone adversarially like me from changing the HTML. But watch this. The behavior on the form, if we go back, is still now the same drop-down as before. So aesthetically, it looks the same. But you know what? Why don't we be clever now? And let's go into app.py and the /register route. And why don't we say this? If, how about sport, not in sports, then let's return render template failure.html. Now, this template doesn't exist yet, so let me just quickly make this real fast. I'm going to copy that code from before. Let me create a code file in failure.html. I'm just going to paste this here so I have a super simple error message. And I'm going to say you are not registered. That's what we mean by failure. And now in app.py, consider what logic I've added. Sports, in all caps on line 22, is that same global list as before. By asking Pythonically, if sport, not in sports, well, then you hacked me. Like you tried to inject volleyball or some other sport into request.form. So I'm just going to say, no, failure, not letting you register. And I can do this a little more verbosely too. Why don't I also say this? If not name. So if the name is blank, let's similarly return a render template of failure.html. In other words, if you didn't give me a name, you left it blank, that's not useful for me running the sports program. Let's also consider that to be a failure. So if I go back to this tab now, I'm going to reload just to make sure I have the latest client side. Let me be lazy and just click register. Enter. You are not registered because I didn't give it an actual name. All right, well, let's go back. How about I now type David, but I'm not going to choose a sport. I just want to register myself. Nope, that did not work now. Let me go ahead here and choose soccer. This, I think, does work. Let me go back now and try this hacker trick whereby I go into the drop-down menu. I go into the select menu. I change, as before, Ultimate Frisbee to volleyball. And I'll change this one here to volleyball. Let me close the tab now. This looks like it's available now. But when I click register this time, it says you are not registered. And this is much better than relying on other techniques you might see or have seen online with regard to HTML, because there's also this trick. Let me go back to the screen here. Let me go back to index.html. And you might have seen online, or you might eventually see online, that there's other attributes you can use, like required. You can literally tell the browser, this field is required. You cannot leave it blank. If I go back to the browser now, reload, and I, again, presume to be lazy, and I don't type in any name and click register, OK, so that's kind of nice. Like now the browser is being a little more helpful for me, saying, no, this is required. You have to fill this out. But again, if you know what you're doing, OK, well, I disagree with your requiring a name of me. Let me go in here. Let me go over to this tag. Let me delete the required attribute. And now I slip through. But I didn't slip through on the server. And so there's a difference here, and an important distinction. And so many people in the real world still screw this up. There's client-side validation, like actually checking that the data is as you expect on the client side, the browser, and there's server-side validation. And even though client-side validation, like adding that required attribute, makes things more user-friendly, right? Like that was a pretty little pop-up. It tells me that it's required. It just looks better than the previous version. It is not trustable. You cannot trust any input that ever comes from the user, because clearly with like an hour or so of CS50, like they can learn how to turn all of these defenses off. So even if you like the user interface better client side, you have to do server side validation always. Users are not to be trusted. And as soon as any app or website you make becomes popular, unfortunately, then you have to deal with all of the adversarial possibilities as well. Oh, good question. Could the adversary potentially access things sensitive like app.py? Theoretically, no. Like if Flask itself is buggy, then sure, maybe. If you're running some other software on your server, on your laptop, then sure, it's possible. However, if your server's properly configured, theoretically, they should not be able to get access to that. With that said, we'll soon see, or you might with your final project, if you do something web-based, you're never going to want to write like usernames and passwords in your actual code. You can put them in what are called environment variables. So sort of in the computer's memory, but not in your code, just in case you or someone screws up. There are still ways to defend against those kinds of possibilities, however slim. Yeah? A good question, and this comes back to first principles, just like in C and in Python. As soon as you return from a function, that's it. Nothing below that line of code executes. And so to summarize the question, even though I'm returning this failure.html template, how am I making sure we still don't accidentally put volleyball in that global dictionary? It's because, for instance, if you don't give me a name on line 22 at the moment, I'm returning the failure template, and that's it. Lines 23, 24, 25, 26, 27 never execute. In particular, 26 never executes, and that's where I would have been saving the name. Similarly, if we get an invalid sport that is either blank or not in the original authoritative list, we return failure.html as a template in line 25. We never get to line 26. So it just boils down to return and what that means in Python 2. Good question. Other questions as well? No? All right, how about we make one more enhancement here or so, because the problem with storing everything in this global dictionary might be what? We've got it all working, finally, but why is probably a global dictionary not the place to store frosh.im's registration data? What's the implication of this? OK, might slow the whole process down, but RAM is actually good. Memory is actually generally a good thing. So not going to be a deal breaker here. Why might I not want to store that data, though, in that variable? You can perhaps infer how I fixed something earlier. Yeah, and back. Yeah, the memory gets deleted, garbage collected, if you will, as soon as Flask stops running. So if you so much as hit Control-C, like you've just lost all of your freshmen who registered for the sport, probably not a good thing. I did this deliberately a moment ago, and I hit Control-C because I did want to clear the dictionary, but trusting that your server will never crash and your code will always work and the power will never go out, like that's not the right way to build any kind of web application with persistent data. So what we probably want to do is reintroduce CSVs, and we've played with those in C and in Python. Could totally use CSVs, but we also now have SQL at our disposal. And let me propose that we do this in SQL instead. And for this, let me go ahead and open up a version of the program that I wrote in advance. So let me go ahead and close these templates, which will look very similar but a little different from the ones I wrote in advance. And let me go ahead and open up let me go into source 9. Let me go into frosh.im's, how about version 4, technically, in the versions online. And let me go ahead and open up app.py as follows. So here is an already made version that does just a little something different. At the very top, I'm importing CS50 SQL library, which you might recall we used a couple of weeks past, just to write Python that talks to a SQL database. And this feels like an opportune moment to bring that idea back. Down here on line 8, I'm creating a DB variable that opens up a file called frosh.ims.db using syntax that we've seen before. I did create this frosh.ims DB file in advance of class just so that we have a couple of columns in which to store names and sports and such. Here's that same global array, a global list called sports. And let's just see what's going on down below. If I scroll down to index, this is the same as before, as we wrote together on the fly. Let's skip deregister for a moment and go now into register. So this one's a little different, but let's see what I've done. I've got some comments in here because I wrote it in advance. And I think this logic is pretty much the same, though I tightened it up. And I'm asking two questions at once using on line 38 the or keyword here, just to say if there's not a name or the sport is not in sports, that is what we'll call now a failure. But what's fun now is that on line 42, I'm using the CS50 SQL library to execute some actual SQL. And I'm going to insert into a table called registrants 2 columns, name and sport. What names and sport? Well, these 2 values with placeholders, plugging in name and sport. Notice I'm using the question marks. Absolutely necessary so we don't get one of those SQL injection attacks, because that too could be possible if someone typed in some dangerous words or keywords like delete or single quotes or semicolons in the form. Here, I'm letting the library sanitize the data. And then this is a trick we haven't yet seen, and it's really going to start tying things together. I can also use a redirect function in Flask that has the effect of doing the if you will, safetyschool.org trick again, whereby after the user registers, if I want to automatically show them now everyone who is registered at /registrants, I don't have to manually expect that they'll change the URL like I've been doing for the past few minutes. I can just redirect them anywhere I want on my app, or heck, I could redirect them to any URL on the internet using this function call. And it's just a nice way to send them to a different route if you want them to see, in this case, those registrants. So let me do this. In the same directory, let me increase my terminal window size. Let me do SQLite 3 of frosh.ims.db, and let me type .schema. And you can indeed see it wraps onto 2 lines here, that each registrant has an ID, which will be automatically assigned 1, 2, 3 on up, a name, which is not null text, and a sport, which is also the same. And the primary key is just going to be this unique identifier. So that I made in advance. But if I do select star from registrants, semicolon, there's no one currently registered for any sports. But let's try now running this. Let me go ahead and close my old version, which we wrote together. And I'll close that tab. Let me do Flask run in this version 4 here. All right, I'm going to see some similar output. I'm going to open the URL now. And you'll see that I made a couple of changes before. Instead of using a select menu, I used what are called radio buttons now, which is a reference to old school radio buttons that were mutually exclusive in cars back in the day. And we'll see how to do this, but it's just an alternative to a select menu. And I'm going to go ahead and type in my name again here. So I'll do David. I'll do soccer by selecting this radio button. And I'm going to click register now. And notice what happened. It's a little ugly, the formatting, but so again was this 20 years ago. Here I have now at the /registrants route, instead of an unordered list, I'm just using a simple HTML table. So I'll show you what this looks like in just a moment too. And I'll show you this deregister button, which is sort of unnecessarily large. I also have functionality we'll soon see for how you can unregister someone from a sport as well. So take your name out of contention. Well, let me go back to my terminal window here. And I'm going to click the plus to give myself a second terminal so I can go back into source 9, frosh.ims 4. I'm going to do SQLite of frosh.ims.db. I'm going to do select star from registrants now. And now you'll see that, indeed, there's David registered for soccer. And in fact, if I quit the Flask program with Control-C and rerun it again, no big deal, because that next version of Flask will just use the database as well. So I'm persisting, keeping the data in SQLite, whereas I'm actually grabbing it using my Python code in Flask. All right, let's put one more person in here so we can delete one of us too. Carter for basketball. Register, and now we see both of us here. All right, so let's see how we did this. Let's go back over to VS Code. Let me shrink down my terminal window. Let me go into the let's go into the templates directory, and let's look at, for instance, index.html. So previously, we were using a select menu. Turns out radio buttons use the input tag, but instead of having an input of type equals text, like for the human's name, you have type equals radio. And so long as each of your radio buttons has the same name, the same name, the same name, that's what makes them mutually exclusive. So checking one radio button turns off the others because they have the same name. The value I want to assign to each of these radio buttons is just the sport placeholder. This is what the human sees on the screen. So it's almost the same as the select menu. It just looks aesthetically different. But there's my same button. So that's all the difference I made there. And I added a heading tag, h1, just to say register to make clear what it is. But let's take a look at another file. This one now being, how about the /registrants route? So if I open up registrants.html, here now, it's way more verbose than my unordered list, but this is just kind of boring HTML. Here's my table tag, table head, table row, table heading. This makes things bold as the first row of the table. Name, sport are my 2 columns. I've got a third empty column just so I can fit that button, as we'll soon see again. T-body for table body. Here's the same for loop trick again, so that I can output for every registrant a whole table row. And there's this weird form in there, but we'll come back to that. But there's the registrant's name. There's the registrant's sport. But notice the slightly different syntax here. Recall that CS50's execute function, when it returns to you a list of dictionaries, you can then get at the individual columns by way of those keys. So let's go to the /registrants route. Let me go back to app.py, scroll down here, and it's actually super simple. Here, I have a /registrants route that first executes select star from registrants. So just old SQL stuff. Give me everyone from the registrants table. Let me then render the template called registrants.html and just pass in this list of dictionaries. And we haven't quite done this yet, but if you go back to registrants.html, how do you iterate over each dictionary in that list? Well, the syntax is just for registrant in registrants. That makes this a dictionary, one at a time in the list, just like in Python. So registrant.name and registrant.sport is just another syntax for using the square bracket notation. It's just a little cleaner and slightly more succinct than having quotes and square brackets everywhere. And then the rest of this is just HTML. So what happens now if I want to, like Carter's been cut from the basketball team, if you will. So how do we do that? Well, we want to click this button, deregister, next to Carter's name. But how does this work? And think about now any website you visited that has something like a shopping cart where you can remove things from your cart or update quantities or add more quantities to your shopping cart on Amazon or anything else. Well, let's actually look at the HTML that my app has spit out. Let's actually look at this here, and we'll see the following. We'll see that we have here in the HTML that reached the user, not only is David in the first column, soccer in the second, notice that my registrants.html form is also spitting out a tiny little web form of its own. It's ugly, but I only care about its functionality for now. And notice what I'm doing here. Every registrant in this database gets their very own deregister button. And that form has a button that says deregister. But notice what else each of those forms have. There's no text box. There's no drop-down menu. There's no radio buttons. Rather, you have a hidden input field here. So there is a way with HTML to have a form that will submit information, but you don't have to give the user the ability to change that information. You can just go ahead and tuck it inside of the form invisibly, if you will, hidden in fashion. And so what's going to happen is if I click the deregister button next to Carter, his primary key is 2. Mine is instead 1. So what's going to happen if I click his deregister button, it submits a form with a ID parameter whose value is 2, and it submits it to the deregister route. So what does that mean? Well, if I go to VS Code and I go to app.py, let's look at the deregister route that I skipped over. So if you access the deregister route via post, this code gets called. I grab from request.form the ID that was submitted in hidden fashion. If there's indeed an ID, that is, it's not blank, it's not 0, it's an actual number like 1, 2, 3, or more, I execute delete from registrants where ID equals that value with a question mark placeholder. And then I redirect the user back to registrants. Now, if I go back to this form here, I click deregister, we'll see that in action. Gone is now Carter. And in fact, if I go back to my terminal window here, I open up SQLite 3 of frosh.iams.db and rerun select star from registrants, Carter is now gone. So again, using very simple HTML forms, you can get buttons and links and other such UI mechanisms to like do things on the server that you want. But there is a danger here. This now is really meant, this example is like an administrative website like it was some 20 years ago, just for us internal staff to be doing things. Technically, this is dangerous, what I've just done too. Even though Carter's ID is 2 in hidden, and mine is 1 in hidden, what could this allow an adversary to do if they had admin access to the same site? Any thoughts? Yeah. Oh. Yeah. Yeah, they could change the value of that hidden attribute by opening up Chrome's like developer tools, change the number in the HTML. They could delete anyone, deregister anyone they want from the database. Now, in this case, I claim this is fine because this is only meant for us staff who were running sports back in the day, but it's indeed a risk. So wouldn't it be nice if we could actually ensure that only those users who are authorized are allowed to execute certain actions? I think for this capability, we're actually going to need to introduce something a bit more. And so here, of course, is an opportunity to talk briefly about really what you and I do all day long, every day. We log into one or more websites or apps, or at least until you're logged out automatically and you have to do it again. So here, for instance, is a screenshot of Gmail. When you type in your username, you type in your password, maybe your two-factor code that gets texted or sent to your phone, then you're logged in. And thankfully, you're not prompted to log in again typically for a number of hours or days or weeks, depending on the website. Like Gmail keeps you logged in for ages. Your bank probably logs you out within an hour or so for safety's sake. So that is completely configurable on the server. But how does Gmail know, how does Google know that even as you're checking different mails again and again and again, how do they know that you're still the same person who logged in? Well, it turns out that using these same building blocks as today, HTTP and HTML and more, you can actually implement the notion of a login feature by doing the equivalent of something with something called cookies. Essentially what happens when you first log into a website for the very first time successfully with your username and password, a cookie, so to speak, is planted on your computer. And metaphorically, this is kind of like taking a hand stamp, and your hand is now stamped, in this case a smiley face, so that every other time you click on a link on that same website, google.com, gmail.com, whatever, unbeknownst to you, your browser is constantly presenting that hand stamp, just like going into a club or an amusement park or something like that, where they don't want to check your ID again, they don't want to check your ticket again, they just want to quickly see the same hand stamp. And so that is one of the things that a browser is always doing for you once you're logged in. Any cookies that have been planted, so to speak, in your Mac or PC or phone are constantly represented to the site every time you click a link or make another request to that website. And mechanically how this works, not just metaphorically in ink, essentially this is what happens. Here is an example of an HTTP request to something like Gmail. And suppose, for instance, that you've logged in. Typically, as of last week, we said that coming back from the server would be another virtual envelope containing like a 200 OK message, and then like the actual web page or the picture of a cat or whatever it may be. But Google can also, if they've verified that you have some username and password correctly inputted, they can do the equivalent of stamping your hand. And the way they do this is they send an additional line of text in that virtual envelope from the server to your browser, literally using another HTTP header, not content type, which just mundanely tells you what kind of content has come back. They literally send an HTTP header called set-cookie. And then they set a key value pair on your Mac or PC. This is the technical equivalent of the smiley face hand stamp. And what your computer is designed to do, because your computer and in turn browser are supposed to implement HTTP, anytime you click another link on Gmail or click on another mail or the like, your browser, unbeknownst to you, presents that hand stamp. And how it does it technically is in the envelope it sends to Google from your browser, it doesn't send set cookie, it just sends cookie, colon, and the exact same thing. And so long as Google is smart and they have a database or something of all of the session values. Session is the technical term for this maintenance of information across HTTP. So long as Google has a big database that knows that my cookie value is 1, 2, 3 and your cookie value is 4, 5, 6, they can infer from this virtual hand stamp whose emails they should be showing, mine or yours or the like. So this is just scratching the surface, but if I really wanted to enable only Carter to deregister himself, I just have to make sure that I log him in somehow, username, password, and all of that. I stamp his hand, or really put a cookie on his computer, and only if his cookie lines up with the user ID he's trying to deregister should he be allowed to, in fact, do so. So all of this is quite possible, and indeed the technical term for this is session. And what we thought we'd do in our remaining time today is show you some examples of exactly how some of the most familiar web functionality is implemented today, some of which you'll use in your own problem set 9, which itself will be a web app, or perhaps even your final project. So let me go ahead and do this. Let me close my previous tabs and all things Frosh IMs, and let's move on to implementing some notion of login. So in just a moment, I'll switch over here to VS Code. And what I'm going to do is, indeed, in my source9 directory, I'm going to go into a login directory. And if I type ls here, you'll see app.py, requirements.txt, which just refers to libraries I want to automatically install, and a templates folder as well. I'm going to go ahead and stop the previous server and close that terminal window. And I'm going to open up this version of app.py. So there's a few new lines here, and we'll give you these lines for problem set 9. But I've got some of the familiar stuff up here, including this new redirect function we just used. And I have a session variable that comes with Flask 2. So what's nice, again, about Flask is that it deals with all of this cookie stuff for you. It sets the cookie, it checks the cookie, and what Flask does for you is it gives you the abstraction of a variable called session, so that anything you put in the session variable, which itself is a dictionary, will be there again and again and again whenever that same user comes back. A session is how you implement, essentially, like the proverbial shopping cart. If I'm logged into Amazon, you're logged into Amazon, Amazon knows which of us is which by way of that cookie. And Amazon, if they're using Flask, provides the programmer with a dictionary called session. And Flask makes sure that when Carter's visiting the site, the code uses his session object. When I'm visiting the site, it uses my session object. But it's all implemented with those same cookies. This is the same as before. These lines are new, and you'll see these in problem set 9. This is how we enable sessions in a web application. And I'll just wave my hands at the detail. There's different ways to implement sessions, whether you use cookies on the server, cookies on the browser, or other things. These just ensure that we're storing the session information, the shopping cart, on the server itself. Now down here, let's go ahead and do this. Let's go ahead and run Flask run so I can see what this app does. If I do this and visit the URL that gets outputted, you'll see a very simple web page here. And if I type in, for instance, my name, I'm not going to bother with a password and click log in, you'll see that you are logged in as David. And now I can log out. So I'm going to go ahead and click log out. And now it seems to know that I'm not logged in again. I can log in as Carter because I didn't bother implementing passwords for simplicity. But now the site knows I'm logged in as Carter. Better yet, if I reload, or click this button again and again, notice it still knows that I'm Carter until such time as I log out. All right, well, how is this working? Well, let's go back to VS Code here. And let me scroll down to first this route. This is a very common paradigm here whereby I'm checking for the index route. If there is not a name in the session, redirect the user to /login. Now, what does that mean? Well, let me go back to VS Code here. Let me go to the /route. So again, your URL will be different, but I'm just going to go to / and hit enter. Notice that I got automatically redirected to login. And so many websites do this. If you go to a website and you're not logged in, you're very often redirected to /login or /account or something like that where you're prompted. The code for doing that is right here. If there's no name in the session, if there's no name in the shopping cart, if you will, go ahead and return the user to login, that route. Otherwise, implicitly, if they are logged in, show them index.html. So let's go down that rabbit hole. Let me open up in VS Code a second terminal window. Let me go into source 9 and go into this same login demonstration. And let me open up the template called index.html. And here's all this is. There's some layout, but who cares at this point? It's just the boilerplate generic HTML. Here's the body block. I have this, and this too is Jinja because of the curly brace and the %sign. If there's a name in the session, this is just Python syntax, then say this sentence. You are logged in as whatever name is in the session, in the shopping cart, if you will. And then I just have this HTML link for logging the user out. Else, if there is no name in the session, logically, just say you are not logged in and give them a manual link for logging in instead. So that's all this particular template does. But how does the /login work? Well, let's go into this other template, code of login.html, to which I'm redirected. Super simple. This is just copy paste from HTML before. I've got a login form that's going to have an action of /login, submits for privacy's sake via post. And then the rest of this is just a simple form. And I'm using an input type equals submit instead of button equals type equals submit, but same idea here too. And if I go back to app.py, well, let's see how login works. All right? It's a lot all at once, but they're relatively simple reapplications of the same idea. So if the user visits /login via get or post, call this function login. If the user has submitted via post, and we saw this technique before, go ahead and do this on line 23. Store in this special session variable that comes with Flask a name key and store in it the user's own name. So quote unquote name will have a value of David or Carter or the like. And as soon as you do that, redirect the user back to / just so they see the home page again. And this is how Amazon and all these other websites work too. Otherwise, if they visit this page implicitly via get, and even though I didn't say equals get anywhere, that's sort of the implication. Because if you can only get here via get or post, and we already handled post, logically all that remains is get, well then just show them the login screen instead. But there's half a dozen ways we could express that same logic. And then for logout, this is kind of straightforward. If the user clicks that logout link and ends up at /logout, this route, well, just change the value of that key in the session to be none. Effectively, no, Carter's gone. David's gone. There's no one logged in. So that is all that's required to actually implement the notion of logging in and logging out of a website, plus the password thing, which should probably involve a database, but one thing at a time. And really, session is sort of like the code version of a shopping cart, whereby if I visit this same code, I get my own session object. If Carter visits the website, he gets his own session object. And the way Flask keeps us straight is they put one cookie on my computer, a different cookie on his computer, and uses those to line up with, making sure the right session gets shown to the right actual user. Questions on this notion of sessions? No? All right, how about a couple final examples just to tie this all together? Let me go back into VS Code here. Let me quit my previous version of Flask. Let's go into source 9 and go into store, which is a separate app altogether. And let's start by just running Flask to see what it does. Let's hover over the URL and open it in another tab. And this is pretty ugly too. Let me zoom in. But it's a very simple bookstore, like an early Amazon.com for each of these 7 books here, each of which seems to be like, maybe this is H1, this is H2, 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 and then there's a button underneath each. Well, now let's use this as an opportunity to kind of infer, like for any website, how this thing works. Let me go ahead and do view page source. And you can do this for any website on the internet. Let's try to figure out how this bookstore adds things to a cart. Well, here's the H1 tag, uninteresting, H2, H2, H2. So the juicy part is in these forms. Each of these forms has an action of /cart. So that's the route that's going to be interesting in a moment. And it uses post for privacy's sake. Each of these forms, like the deregister feature for Carter, has an ID attribute, an ID parameter that's hidden visually that has a value of 1 or 2 or 3. So like the unique like barcodes for the books, if you will, but super small numbers in our case. And then each of these other forms each of these other books has an identical form except for the value of this here. Now in this case, this isn't such a big deal that a user could technically hack the HTML of this bookstore, Amazon.com, and change the IDs. Because, whoa, what's the worst they're going to do? Like buy more books by adding more IDs to their shopping cart? Like that's not a problem. There's no prices here. It's just the unique IDs of books. So whereas the deregister was maybe worrisome because you're changing the server, I think it's OK because the user can only, at worst, buy more books than they might via the buttons alone. So how does this now work? Well, let's go into VS Code again here. Let me give myself another terminal window. And in source9/store, let me open up app.py, which is where all the logic is. So I'll flip through most of this quickly because we've seen this before. These imports are pretty much the same as before. This line is the same. This line is almost the same, but the database now is called store.db instead of frosh.ims.db. This is the boilerplate code for just enabling sessions, this notion of a shopping cart. And so let's see how the index works. How is it I'm seeing all 7 books at once? Well, in this index function, I'm using on line 19 select star from books to get all the books from the database. And then I'm rendering a template called books.html, passing in as a placeholder all of those books. All right, let's go down that rabbit hole for a second. Let me open up books.html in my templates directory. And here again, even though it's new today, it's probably increasingly familiar syntactically. Here's the H1. Here is my loop. Here's the H2, which is going to output the current book's title in that loop. Here's the form. Here's the ID of that book that's going to be outputted in the form. So I didn't manually type out 7 long forms. I just did 1 in this template so that it gets generated automatically, literally what a website like Amazon would do to show you 10 books at a time or 10 search results or more at a time. All right, well, let's go to /cart, which was the juicy one. And this one's longer, but let's see if we can reason through it. If the user submits via get or post to /cart, well, we first do this. And this is just necessary in some boilerplate rewrote. We're going to use the session object to store a variable called cart that in this case is going to be a list. So session, again, is just a dictionary. You can put anything in it you want. Previously, we put students' names and sports. Now, what I want to do is actually, previously we put the student's name, the user's name in it. Now I'm going to actually store a cart key whose value is a list. Why? Because I want to aggregate more and more books in this list. All right, so that just makes sure that I have at least an empty shopping cart the very first time the user does this. If they visit this form via post, Let's go ahead and get the ID of the book that they posted. If it is not empty, if there is a number like 1 or 2 or 3, let's go ahead and go into the shopping cart, which is a list per this line, and just append that ID. So this list of books in your shopping cart is going to contain like 1, 2, 4, 6, whatever books you're actually buying. And then the user gets redirected to cart. What if, though, the user got here via get and not post? Well, this one's relatively straightforward. If you just visit /cart, we select star from books, where ID is in. OK, so this is interesting. This list. And this is syntax you might not have seen before. But if you read the documentation for CS50's library, if you select something and use a question mark placeholder, and the placeholder itself is a list, we output a comma separated list of values, just like you would use maybe in problem set 7 for doing SQL queries on your own. So this just means show me only those books in my shopping cart, not Carter's, not someone else's, not in the whole database. Only show me the books in my shopping cart, and then render it as such. So we only saw what the catalog here looks like at /books. Let's go ahead and let's go ahead and add maybe the first book to my cart. And now I see at /cart only that first book whose ID is 1. Let me now go back to the bookstore here, scroll down to maybe the 7th book, and add that to my cart. And now I see this here too. Meanwhile, all of this information is stored in my session. And so when I reload this cart again and again, the reason I'm only seeing my 2 is because we're checking only the list in my session. And Flasks make sure, again, that my session is different from your session, is different from Carter's session as well. But you write the code once, and it works for thousands, millions of people in parallel. Any questions on this? Yes, in the back. Sorry, say a little louder. So to recap, so users will never have the same session values. Theoretically, the cookie that gets planted does not look like a smiley face for everyone. Each of us gets a big random number that's assigned to us. So it would be like each of us gets a completely unique hand stamp that no one else can see. The reason no one else can see it is because if the website's using HTTPS, every time this hand stamp is shown, every time this cookie is sent back and forth, it's all encrypted as well. So each of us can, even if we have the same contents by coincidence, because we like the same books, they will be separate cookies, separate memory, separate sessions. Behind you, yeah. Really good question. When does the session end? Totally configurable. Typically, it ends when you close the tab or when you quit the browser. Or you can also configure cookies to themselves be persistent for a day, for a week, for a longer. So for instance, when you log into say Gmail, they plant a cookie on your computer probably for a week, a month, a year, something like that, because it would be annoying and probably drive you to like Outlook or something else if you kept having to log into your account, whereas your bank account might actually wait for you to just close the tab, and then for your own financial safety, they just automatically delete the session far sooner, but totally configurable. By default, as I'm using it, it will typically be thrown away when the browser itself quits. And here, too, is another reason to develop websites using incognito mode, because if you want to just throw away all of your cookies, you close the incognito window mode, open a new one, and now you're starting from scratch. You don't have to manually delete all your cookies, which could log you out of websites you actually care about. Yeah? A good question. When using sessions, if someone maliciously changes the value of subforms, could it affect other people? Theoretically, no, because the worst you can do is like add books to your own shopping cart that you don't want there. So at that point, even though it's on the server, it doesn't affect you or Carter or anyone else, unless there is something more globally happening, like registering or deregistering for a sport, or removing books from the Amazon database. That would be problematic. But in this case, we're removing things only from my own session that the website is giving me. All right, the last topic for today is this thing here, which is sort of everywhere nowadays, these things called APIs, or Application Programming Interfaces. And this is a very generic term, in fact, because any function you've used in C, in Scratch, in Python, in SQL are all APIs. Like there is a standard way of interfacing with those functions. They all have names. They sometimes have return values. They sometimes have arguments. And an API is just how you use a function. Or, more generally, an API just specifies how you interact with some service. And so nowadays, there's a lot of web-based services that you can use to get back data, like the weather, or the current time, or the database of Amazon books, for instance. All might have APIs, often web-based, that allow you, using URLs or some other technology, to just get data from someone else, as though it's a function you're calling remotely. But HTTP is very often the mechanism that's used to actually get data from servers. And the way the data can come back can be as follows. Let me end with one final example using some of our familiar shows from weeks past. Let me go ahead and close the old Flask version, go back into source 9, and go into how about an example called shows. And the first version of this 0, I'm just going to go ahead and run with Flask run. I'll hover over my URL and open it here. And you'll see now that I have a very simple form, as we keep doing today. I'm going to type in like OFFICE office into this search box and click search. And you'll see now that I ended up at a URL ending in /search !Q equals office. So this is like my own baby version of google.com, but I implemented it myself. And for any title of a TV show from a couple of weeks past that matches OFFICE, I spit it out into an unordered list. How is this working? You can maybe imagine, even if you might not be able to program this off the top of your head certainly so soon. Let me go into source 9. Let me go into show 0. Let me open up app.py. And in this file, you'll see that I'm grabbing a file called shows.db, which is like a simpler version of the one from a couple of weeks past. Here is why I see the web form. My first route, my index, is super simple. It just spits out that form. And my search route, like you can think of this as google.com, is only like 4 lines of code. So if the user sends data to /search, this function called search is called. I declare a variable called shows. I execute a SQL command that is select star from shows where title like ? And the syntax here is a little crazy, but I want to prefix to the user's input %, and suffix it with a % as well, putting in the between those two values the actual input y. In SQL, what does it mean if you have a % to the left and to the right? Nothing to do with Jinja today. Yeah, it's a wild card. So it means match 0 or more characters on the left or match 0 or more characters on the right. You have to do the concatenation as the second argument to this function. You can't do something clever like put it here around the question mark. Like the question mark is the placeholder that you plug these values into. But this just means, hey, SQL, show me all of the titles that have OFFICE somewhere in them. That gives me back a list of dictionaries. I pass that in as a placeholder for a variable called shows. And if we look at search.html, let's look at that. In my templates directory, there's something called search.html. Super simple. I mean, this is like the essence of google.com search results. I'm using an unordered list to keep things simple, but I iterate over every show in the shows list that came back, and I output an li with each of those shows' titles. And that's it. Now, Google has like blue links and like little previews and other text, the first sentence or so from each page, but like that's the idea. Like this is really similar in spirit to what google.com/search does for you. Now, how is this working? There's no API involved here yet. This is just very basic HTTP. I submit the form, I go to another route, and I get back the results. But check out this version. Let me close these tabs here and open my first terminal window. Let me go into shows 1 from today's source 9 directory and do Flask run this time. Let me go ahead and hover over that URL and open it here. And gone now is the submit button. Now I'm going to make a user interface that uses a technique called AJAX for asynchronous JavaScript and XML, which is somewhat of a dated term because we're not using something called XML anymore. But AJAX is a technique whereby you don't have to submit forms anymore to get more data from the server. You can use JavaScript per last week, listen for an event like the key press coming down or up, and as soon as you hear such an event, you can secretly, in JavaScript code, send a request to the server to get back more data and then plug it into the DOM, the tree in the computer's memory. And this just makes for more seamless experiences like autocomplete on any website. So now let me try typing O. OK, we got autocomplete super fast. F, And you'll see every time I add more keys to my input, I'm doing another search, another search, another search, and the data is changing. Now, how is this working? Well, let me go back to VS Code here, and in my other terminal window, let me open up app.py. And in app.py, you'll see that there's still a search route down below that returns a search template. But watch this. Let me go into templates/search.html, and notice here that we're indeed getting back an unordered list of shows again and again and again. And this HTML that's coming back, let me go here. Let me open my terminal. Oh, sorry, this is the wrong version. Sorry, I was in the wrong folder. Let's fix this. In shows 1, code of app.py, it's almost the same thing. In search here, OK, well, I changed this slightly. Let me show you this version of search. If I open up app.py, here's my search route. I'm getting a variable called q, giving it the value of whatever request.args has from the user, like q equals office. And then I'm checking. If the user actually types something in, execute this SQL query. Select star from shows where title is like that, using the same. And this time, just to keep things efficient, I limited the total results to 50 instead of an infinite number. Otherwise, if the user typed nothing, just to be super safe here, I'm setting shows equal to an empty list. So if you don't type anything, there's nothing to show. And no matter what, I render this template called search.html. Well, let's look at that. If I open up templates/search.html, this time there's no layout. There's no inheritance of that layout.html. I am literally generating just a whole bunch of li fragments. Why? Well, let's see what's happening in the browser. And this is the beginning of an API. If I wanted to make this API available, this application programming interface, I could tell the world that if you want to search for TV shows in my database, go to URL that's something something / search q equals office or cat or dog or anything else. And what I will return to you is this. Enter. I will just give you a whole bunch of li tags, which almost looks the same, but let me view the page source. Only am I going to hand you back a fragment of HTML. I'm not giving you an HTML tag, a body tag, a title tag, a head tag. I'm not giving you a web page. I'm giving you a fragment of HTML that you can now do whatever you want, including insert this into your own unordered list. So notice what happens in this actual app. If I go back to VS Code here, let me open up my index template here, and you'll see some JavaScript magic. So in JavaScript here, in my form that only had the text box and no button, what am I doing? In a script tag here, I am creating a variable called input. And I'm using this function called query selector that just gets me a reference to the input text box on the form. So I can see what the human typed. This is a little different today, but I'm using input.atEventListener, which is a way in JavaScript to tell it, just like in Scratch, listen for something to happen, like the green flag being clicked. But in this case, listen for an event that involves input. That is like typing on the keyboard, whether it's via copy-paste, manual input, or anything else. Then, whenever that happens, call this function. And async stands for asynchronous. This is a term of art, which means that this function might take like a split second, maybe even a second or two to execute. So it's going to do it behind the scenes, like in the background, so to speak. And what is it going to do? Well, it's going to call a JavaScript function that all browsers now support called fetch, which is a function that uses HTTP to go fetch more data from the server. It's going to fetch data from a route called /search, q equals, and whatever the value is that the user typed in. So I'm just sort of manually creating my own mini URL and telling JavaScript, go fetch me that HTML. When it comes back via this line of text here called response.text, and let me wave my hand at await. Await just means this might not come back immediately. Let's await the response. And when it does come in, then let's execute this code. I'm going to do this. I'm going to search the document, the whole web page, for this UL tag, which is somewhere in this page that we'll see in a moment. Change its inner HTML to be that fragment of li of all of those matching shows. And where does this all go? Well, if we scroll up here, you'll notice that there's my usual HTML up at the top, head tag, body tag, and all of that. There's the text box that we've talked about already. There's no button for submitting because it all happens automatically. But there is, by default, this empty UL that has nothing by default until we start using that API. And the final flourish here is this. This is kind of an ugly, sloppy way to get data from a server to just get back like a fragment of HTML. Like, what if I'm not using HTML? I want to store these TV shows in a PDF or in some other wet tag, in a table or something like that. It doesn't really make sense for the server to be presuming that I want li tags surrounding each of my data. Better would be to get a more generic format back. And that format is almost always nowadays called this, our final acronym, JSON, JavaScript Object Notation. And let me do this. Let me close these two tabs here and open my terminal window and cancel the previous version of Flask that was running. Let me close this version and look at our final version called shows2 and do Flask run. I'm going to hover over that URL and open it in a browser. And I'm going to manually visit, after zooming in, let's do again /search question mark q equals office, enter. And this is what JSON looks like. Now, at a glance, this does not seem like an improvement. Like, this looks crazy that it's just this big blob of text. But it's just enough text for the computer to be able to process it reliably. Notice that there's a square bracket here. And if I actually scroll to the bottom, there'd be a closed square bracket, like way down there. Inside of that square bracket is a curly brace, then ID, colon, and then a number, then a title, quote unquote, colon, and then the title, and then the closed curly brace. So what you're seeing in JavaScript object notation is a very standard, super popular format that's just text, that still uses square brackets for lists, aka arrays, that still uses curly braces for dictionaries, key value pairs. So what you see here is a massive list, up to 50, I think, shows that came back from this API, each of which has a dictionary, if you will, an object of key value pairs. What keys and values? An ID key and a title key, each of which has a value respectively. And this is the same data from IMDb, some of which you might be recalling visually. This is just a very raw, computer-friendly way of returning a whole bunch of data that we humans don't need to see. But I can use this data by going back into VS Code. Let me open another terminal window and go into source9/shows2. And in here, let me go ahead and open up, how about templates index.html, which previously just used that inner HTML trick. And this is not going to impress, you're not going to be pleased with this syntax. But let me just at least explain what we're doing. It turns out that JSON is just the better way in general, the more generic, multi-purpose, user-agnostic, language-agnostic way of returning data from a server, because it's just text. So it doesn't matter if you're using Python or C or C++ or JavaScript or Ruby or PHP or something else. Like, all of those languages can process JSON information. And indeed, here is some JavaScript that does just that. Same code as before initially. I declare a variable called input that gives me access to the user's text box. I listen for input, like keystrokes going up and down. And when they happen, I call this anonymous function. I fetch data from the server using the exact same code as before, search, question mark, q equals office, or anything else. And then this is just now new code that I use to convert that JSON data into my own HTML format, be it an unordered list, an ordered list, a table, or anything else. What am I doing? I've got a variable called HTML initialized to nothing. So I've got no HTML initially. I then iterate over every ID in those shows. So every one of IMDb's unique identifier, I iterate over them one at a time. And then I go into the show, add its ID location, and I grab its title. And this is, forget this for just a moment. I then take this HTML variable, concatenate or join onto it my own li tag plus the title plus the close li tag. And I skipped this because it got scary pretty fast. But it turns out that if some TV shows have actually angled brackets in them, that could break my HTML entirely. So it turns out, you might recall super briefly last week, we had the copyright symbol using an HTML entity using the ampersand and the hash symbol and 169 semicolon. It turns out there are other such cryptic sequences of characters that represent otherwise dangerous or untypable characters like this, which could confuse the computer into thinking it's at the beginning of a tag and an ampersand, which could similarly trick the computer into thinking that it's a entity, which it isn't. But long story short, there are libraries, thankfully, that handle much of this for you. For our purposes, the takeaway is that now that you understand a bit of HTTP, now that you understand a bit of HTML, CSS, and JavaScript, all of which they have their roles, you can use them ultimately to start assembling your own web applications, as you will for problem set 9, stitching together all of those languages and building full-fledged web applications, mobile applications, or anything more. And for that, I think we are all set. And if the first one up here can have these cookies as well. We'll see you next time for our very last CS50 lecture.
Good afternoon. My name is Sarah.
And my name is Grant.
And we are
the Harvard Crocodillos and the Radcliffe Pitches. Now, Sarah and I understand that today is the final lecture of CS50.
It's been a tough semester. We made it through P-Sets 4, 5, and even finance.
Now, I know this is an unpopular opinion, but I particularly enjoyed finance. I spent a lot of time with my flask.
The P-Set?
There was a P-Set?
Well, at least things are looking up. Today is our last lecture, and look how far we've come. If I were an emoji right now, I'd be the face with tears of joy.
Sorry about that. We're just trying to work some CS50 references into the intro. I mean, boy, I sure hope this Tide Man doesn't run off my Mario filter.
You could say that. For loop x equals open bracket 1, 2 close bracket.
Boy, I sure wish we had check 50 to see if these jokes were funny when we wrote them.
Anywho, we hope that you'll enjoy this brief serenade. Well, you lace up your boots and you walk on down to a knockdown shack on the edge of town. There's a Latin bean combo there that just won't quit. You walk until you see a blue light lit fall in there. Can you dig them sights down at the house of blue lights? Well, there's fryers,
broilers,
and Detroit,
barbecue ribs,
but the trick of the trade is when they're serving up those fine APs. You're gonna spend the rest of your brights down at the house of blue lights. Doobie-dun-doo-ba-doo-doo-doo, boy, doobie-dun-doo-ba-doo-doo, hi, 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 boy, 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 down at the house of blue lights. Well, you lace up your boots and you walk on down to a knockdown shack on the edge of town. There's a Latin bean combo there that just won't quit. Keep on walking till you see a blue light lit fall in there. Can you dig them sights down at the house of blue lights? Doobie-dun-doo-ba-doo-doo, boy, doobie da dooba dooba dwee, hi, hi, hi. Boy, 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 ga dooba 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 ba ba. Lace up your boots and you walk on down to a knockdown shack on the edge of town. There's a lot of people come over there that just won't quit. Keep on walking till you see a blue light will fall in there. Can you dig them sights down at the house? The house of blue lights. Do 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 ah. Be sure to spend your nights down at the house of blue lights.
Good afternoon, everyone. We are the Harvard Crocodillos, and it is such an honor to be here with the Radcliffe Pitches performing for CS50's final lecture. Congratulations to everyone, and we hope you'll enjoy this, our tribute to CS50. One, two, 3, 4. Da da you da you da 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 you da you da 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 da.
C is for the language I once knew. O is for O notation I must do. D is for dynamic, flask run and finance it. E is even more than David Malin can adore. So code is all that I can give to you. Code, debugging it since P set 2. Soon deadlines I'll make it. Hit compile and please don't break it. Code was made by me for you. C is for the language I once knew. O is for notation I must do. D is for dynamic, flask run and finance it. E is even more than David Malin can adore. So code is all that I can give to you. Code, debugging it since P set 2. Soon deadlines I'll make it. Hit compile but please don't break it. Code was made by me for you. C is for the language
01000100.
O is for O notation
010010.
D is for dynamic, flask run and finance it. E is even more than David Malin can adore. So code is all that I can give to you. Code, debugging it since P set 2. Soon deadlines I'll make it. Hit compile and please don't break it. Code was made by me for. Code was made by me for. Code was made by me for you.
All right. All right, this is CS50, and CS50, this was the Harvard Crocodillos and the Radcliffe Pitches. If one more time, we could thank them for joining us today. So this is already week 10, our last, and indeed among the goals for today are to hopefully give you all the more of appreciation of truly just how far you've come. Recall that in week 0 we began with this visual here, whereby it was described, this class, as a bit of a fire hose, whereby drinking from that fire hose, or really a fire hose from a water fountain, is not unlike getting an education down the road too. And so this is to say that if you're feeling like you didn't quite get it all down, like that's actually okay, and that's to be expected. And even if you felt that with each passing week 0, 1, 2, all the way up now till 10, it never really ever got easier, perhaps, just consider that what was once hard, like Mario and like getting Hello World to compile, is indeed the right measure of the delta between week 0 and now in week 10. In fact, you might recall that again in week 0, 2/3 of your classmates had never taken a CS course before. Now, of course, you all have. And indeed, if you think back to this final sentiment from week 0, that indeed what ultimately matters in this course is not where you end up relative to your classmates, but where you end up relative to where you yourself began. So I would take some pride, take some satisfaction, take some relief, even though a little bit more work does remain, at really just how far you've come since that week 0. And recall that in week 0, we literally started with just 0s and 1s. And by now, many of you might have gleaned that these 64 0s and 1s have been spelling something week by week. In fact, today is our very last message here in binary, encoded on stage. But then quickly we introduced Scratch, and we started to assemble some building blocks of programming, loops, conditions, functions, and the like, but without all the distractions of semicolons and curly braces and all of that, which admittedly we introduced the next week when we introduced you to C. But even now that we've transitioned to Python, hopefully even those kinds of curiosities or confusions are hopefully starting to just get more familiar. And so you finally start to see the missing semicolon as opposed to spending time on that kind of struggle. Recall, too, that in week 2, we started talking already about memory and like how you can manage things in arrays that later became, of course, in Python lists. The week after, we talked not only about debugging bugs in code, but how to debug those same programs. Thereafter, we started talking about algorithms. And we took a step back from code and looked at the bubble sorts and the selection sorts and the merge sorts and all of the searches as well that go hand in hand with that. And indeed, this ultimately is what a lot of problem solving moving forward is going to be about, just solving problems with some form of algorithm. And you have so many different languages in your toolkit now with which to approach problems like those. We talked thereafter about pointers, which are not likely to come back in any modern languages that you now use, but hopefully you have all the better of a sense underneath the hood of like what's going on inside of the computer, so that when you're designing something, you're using something, something crashes, you at least have a mental model for what's going on, and it's no longer that week 0 black box as it once was. I mean, you built things like this. Think back to week 5 when you built your own hash table, and those things are everywhere. Key value pairs, whether it's in Python or in C, or if it's now in CSS and JavaScript, and even HTML, like that principle of key value pairs is really everywhere. And so, of course, now code doesn't necessarily have to look like this. It now wonderfully looks a little something more like this. But eventually, you're probably not. I'm not going to use Python anymore. Something new and better is going to come along. But odds are, like a lot of the building blocks from these past 11 weeks are still going to be useful for wrapping your mind around those new worlds. And indeed, SQL, we introduced you a little bit too. And even if you don't feel yourself yet an expert, hopefully you have a sense of like what you can do with it and what problems you can solve. It's, of course, a better alternative to something simple like a spreadsheet. And now, of course, like web stuff is everywhere, whether it's on your laptop or desktop, or even a lot of the mobile apps that you use on your phone, even though they're native applications, like you install them from Google Play or the Apple App Store, like they're implemented increasingly with HTML, CSS, and JavaScript, but they're put in a little rectangular window so you don't even notice that that's actually really just an embedded browser. And then, of course, you can build things as you might for your final project that too might very well be web-based if you go that route. I mean, I'm still clinging to like the very first like web app I ever made years ago. But honestly, I do that in part because I was just so darn proud that like I taught myself how to do something and it actually worked and was used by other people. So whether it's just used by you or your classmates or your roommates or your family or your company down the line, there's a great sense of satisfaction that comes despite all of the pain that might be along the way when you just can't see or fix that bug. Now, of course, we'll transition, as you'll see in the coming days, to empowering you to code client-side as well. Up until now, you've been using our own VS Code installation in the cloud, which is nice because you got up and running super fast in week 1, focusing only on code challenges, not on technical difficulties. But among the goals now, if you so choose and want to program after this class, even if you never take another CS course before, you can use these same real-world, de facto standard tools on your own Mac or PC. And so pictured here is a screenshot of like VS Code on the Mac. And even though, yes, you're going to have to like jump through a couple of more hoops to just get Python or some other language working on your own Mac or PC, like that's what programming is ultimately going to be about. And we deliberately transition you to this at term's end so that now you have 11 weeks of more comfort under your belt with which to solve sort of silly technical support headaches that might have been deal breakers so many weeks ago. So there's still more to be done in the coming weeks. And indeed, a support structure, therefore, the CS50 hackathon, of course, will be this 7 p.m. till 7 a.m. opportunity to dive into your final project. Well, really, continue diving into your final project, ideally at that point, alongside classmates, perhaps your project partners if you're working collaboratively. And awaiting you will be such memories and excitement, hopefully, as these, even as you then turn your attention back to your final project. There, of course, will be several meals during the day, culminating with 5 a.m. Shuttles to IHOP, the local pancake place, if you are so awake at that point, or even if you get there, this is not an uncommon sight, as you might recall from week 0. And then lastly is the CS50 Fair, which is finally back after a couple of years now of it not being on campus. And this will be an opportunity for everyone to present their final projects to passersby, classmates, faculty, and staff, and really just delight in what it is you created on your Mac, your PC, your phone, in the cloud, or anywhere else. And indeed, it's just going to be an opportunity to bring your laptop to a shared space or your phone and introduce your project to passersby, such as might appear, and ultimately celebrate what you all accomplished. And indeed, will you be handed at the CS50 Fair your very own I Took CS50 t-shirt, which I dare say I'm still wearing all of these years later. And so you too will have that ahead of you as well. So for what's on the agenda today, we thought we would not only look back but look forward. But first, we wanted to thank so many of the team members that have been helping both on stage and off, who've made this course and these sections and so much more about CS50 possible. Of course, the building that we are now in, there's a whole team downstairs in Memorial Hall who helps us get set up and organized each day. Our thanks to them. There's the Education Support Services team who makes everything look and sound so well down here, especially when we have all of the more microphones as well. Our friends, the Harvard Crocodillos and the Radcliffe Pitches most recently. And then, of course, CS50's own team. CS50's own favorite restaurant, Chang Shou, down the road. Indeed, if you find yourself in Cambridge for the next 1, 2, 3, 4 years, or visiting from out of town, do pay a visit to our friends just down the road. And in fact, we'll have our very last CS50 lunch this Friday if you're able locally to partake. And then there's CS50's own team, both on stage and off. And my thanks truly, because not only do they make everything run so smoothly, they capture it for students here who might not be physically present here, for our friends down in New Haven at Yale, and certainly for anyone online who might be tuning in as well. And then lastly, wanted to thank, of course, the huge team of your classmates, your peers that make CS50 possible in sections and office hours, tutorials, and more. Allow me to share with you the outtakes so that even we, the teaching staff, sometimes struggle with computer science. Here are some of the clips that we captured when just passing packets via TCP/IP a while back. You saw the nicely polished version, but here are, if I may, if we could dim the lights, are some of the outtakes. Okay, good. Buffering, okay. Josh, nice. Helen, oh! It's Monica. No, oh, wait. That was amazing, Josh. Sophie. Amazing. That was perfect. Tony.
I think I.
Over to you all.
Oh, nice.
Guy. That was amazing. Thank you all.
So good.
Indeed. And at moment, if we could, just one round of applause for everyone who's helped out this semester. So back in week 0, we introduced you, of course, to this idea of computational thinking, which is to think a little more methodically, a little more algorithmically. And by way of these various languages, hopefully that is something you notice, maybe not in the moment, but in the months and the years to come, that you do find that your thoughts are indeed a little more cleaned up. And you're just able to express yourself a little more precisely and even spot illogic in someone else's document or statements as well. But at the end of the day, really, a course like this is also about critical thinking. And indeed, rewind again to week 0 when we framed the the entirety of computer science as really just this, like problem solving. And any problem in the world, be it CS or otherwise, has some input, and we decided how to represent those inputs. It needs some output, the solution there too, and then all of what you focused on doing and learning and applying these past several weeks is in that proverbial black box, which hopefully is not such an abstraction anymore, but is indeed something that you know how to harness and know what could be going on underneath the hood, even if it's in some technology or some language that maybe we ourselves didn't cover, because a lot of those first principles remain the same. Now, along the way, we talked about the quality of solutions to those problems. We happen to focus on correctness, just does it work, design, which is a bit more qualitative and subjective, and then style, the aesthetics of it all. And these two are characteristic, maybe not with these same words, of just how you might write or evaluate other creations in life, be it physical or written or the like. So think about, too, as you solve problems, just how you can sort of frame for yourself, like, am I doing a good job or not, by quantizing it along these or perhaps other axes as well. And we thought we'd highlight just two topics from that week 0 that have really been manifest for the past several weeks, namely abstraction, like taking complicated things and ideas and trying to simplify them so that we can sort of operate at this level and like solve problems we care about without getting into the weeds of implementation details, so to speak. But there's this tension because you know now from all of these different languages that code is fairly unforgiving. I mean, even omitting a stupid semicolon sometimes breaks everything. And so precision is sort of at odds sometimes with this idea of leveraging abstraction. And so we thought we would try to tease this apart, especially all these weeks later here, but with a bit of a live demonstration. So on the way in, you probably all received a sheet of paper. If not, but someone near you did, just tear theirs in half and borrow half a sheet if you can, or any piece of loose leaf paper or the like will suffice, so long as you have a pen or a pencil. And for this, allow me to propose that we invite up maybe 2 final CS50 volunteers this semester. And like a lot of hands are going up in this. OK, a lot of hands. How about, I saw the first hand there. Yes, who's pointing at herself now? Come on down. We just need the one hand for now, but come, oh, wait, you'll be our number 2. Well, OK, we have way too many volunteers now. No, please, come down. Yes, in the black shirt. And if you guys, we'll do pair programming in just a bit. If you want to hang out in the wings here, we'll have our second demonstration as well. So, OK, now maybe a round of applause for our 3 volunteers. Oh, come on up first. Oh, no, second and third. OK, you come first. We'll do order of, nope. This is a Q. OK, Q, here. OK, what's your name?
I'm Danny.
Danny, OK, take this mic. OK, so we will DQ you momentarily. All right, so Danny, come on over to the middle here. And in a moment, I'm going to hand to Danny a sheet of paper that has a picture on it. And this picture is going to be something that I'd like you to verbally program the audience to draw. You can use any words, any abstractions, any level of precision that you want, but you just can't make hand gestures or sort of show them what to draw. But first, do you want to tell us a little something about yourself, including everyone here?
I'm Danny, and I took CS50.
OK, wonderful, wonderful. So I'm going to reveal the picture only to Danny. And if each of you would like to take out that sheet of paper and just make sure that no one else can see this, if you want to hold it up this way, everyone here is now holding their pen or pencil, and in some number of steps, give them a verbal algorithm for drawing what you see. And you can say anything you want, but no hand gestures.
OK, so you're going to want to draw a square in the center of the paper with the diagonal pointing to the center of the edge. Wait, no, actually, I scratched that. Draw a rhombus in the center of your paper.
And for those who forget what a rhombus is?
For a diamond, a square that's on its side. And then from the bottom vertex, draw a straight line down, but not all the way to the edge of the paper. OK, and then keep your pencil or pen at that point, and you're going to want to draw a line that's parallel to the line of the original rhombus, to the right. And then keep your pencil or pen at that point and draw a line straight up connecting to the side vertex. Yes. And then go back to the line that you drew from the bottom vertex to the bottom of the paper, and then draw a line parallel to the left edge of the rhombus. And then keep your pencil at that point and draw a line up to the vertex of the rhombus again.
The end?
The end.
All right. Well, thank you to Danny. Hang on to your paper. Thank you so much. And if you want to step off to the stage there, we will reveal. Thank you. A round of applause, if we could, for Danny. That is not an easy task, I'm sure. And if Carter wouldn't mind just grabbing a few samples here, let's actually take a look on the overhead if we could. I'm going to pop down over here real fast. We don't need to collect them all, but if you're feeling either good or bad with what you drew, happy to collect a few of them. Okay. Oh. Okay. Thank you. Thank you. Okay. Hope you won't mind if I can't reach everyone. Just a couple more. Okay, over here. Okay. All right. That's okay. This one's really funny. Okay, I'm going to go with this one, if I may. And Carter has some, too. Okay. Thank you so much. Okay, so just a random assortment here. Let me turn on a camera so I can show you what I see. Here, for instance, is one classmate's drawing, which might resemble perhaps what you drew here. Here is the beginnings of a house, it seems. Nice. This one, okay, this one is larger. And how about a couple of others that we're getting closer, I think. Okay, so more edges and vertices there. This one seems a little similar in spirit, if not proportional. This is Zach's, the best one. But it turns out, if I may, Zach, you're not all that far off. Here, Danny, is what you were reciting to everyone algorithmically. Indeed, it was this here cube. And so, Danny, can you come on back up for a moment? So, if you'd like to share for just a moment, like, what were some of the thoughts going through your head, and why did you choose the words that you did?
Okay, so what was going through my head when I saw the cube? I didn't know if I could say draw a cube. So I decided to start with the top, and so draw a rhombus in the center of your paper, and then draw a line down, and just like do the first part, then the second part, then the third part, and then you would get a cube, like Zach.
Yeah, and so had you said, and you could have said, draw a cube, which would be more of an abstraction, even that's not necessarily sufficiently precise, right? Because you don't necessarily know what the orientation of that cube is, the size of it, the positioning on the paper. So you instead took a lower level approach, which is not unlike Scratch. If you think about Scratch being able to move up, down, left, right, turn 90 degrees, turn 15 degrees, and the like, I mean, that is ultimately how a lot of graphical programs and games even might be implemented, by really focusing at the level you do. But of course, there's this tension with us humans, whereby we prefer often to think at this level, but even that might not be sufficient. Which is to say, here in week 10, like, these are still going to be and are hard problems, but a hand, if we could, one more time for Danny for getting us that far along. Thank you so much. Let me give you a stress ball here. All right, and if we could have both of our volunteers come up here. We're going to have, yes, come on up. Come on up, and let me have you guys introduce yourselves in the middle here.
Hi, I'm Evan.
Hey there, I'm Sadiq from Turkey. Nice to meet you all.
Wonderful, welcome. And this time we're going to flip it around so as to have the audience do what Danny just did for us. The only catch here is that the only means we have for showing the audience what they need to tell you to draw is like literally right above the chalkboard. So on our system here, that your eyes must stay on the chalkboard and not look up. And in just a moment, if you guys want to both stand in front of the chalkboard back to the audience, and as you're talking with each other, verbalize it through the microphone, if you will. I'm going to show everyone else in the room a second and final drawing, and we'll just go rapid fire around the room, give us one step at a time collectively, and we'll see if these guys can't draw exactly that same outcome. So,
is there another chunk?
What's that?
Is there another chunk? Oh,
just the one. So you'll have to collaborate, and let's give you a clean slate here, literally. All right. So, no looking up. That's the only rule for you guys. Here we go. For the audience, here is what we'd like them, ironically, to draw. Step 1 from anyone in the audience. Yes?
Draw a circle.
Draw a circle. Anywhere. Not anywhere. Okay, that's step 1. Step 2, someone else. Yeah, in the middle. Draw a line down from the bottom of the circle about halfway down. I think there was a hand in front of you, too. Number 3?
Okay.
Okay, the overarching goal here, for those unable to hear, is to draw a person.
Okay. It may be a stick figure.
Draw the left leg of the person, of this person. Okay, good job. All right,
Okay.
Next, step 4, yeah.
Go to the vertex of the line going up in the circle.
Okay.
And to the left, to the right, draw a V.
Okay, to the right of the vertex at the bottom of the circle, draw a V.
A V.
Like what V?
Nope, not interactive. Draw a V.
Well, he would.
Right about it.
Yeah, it seems weird.
Draw a V.
Like,
Let's get ready for
maybe something like
step 5. Okay, we'll go with that. Step 5, someone else? Step 5, someone else? Someone else, yeah. Draw the right side of the leg.
Okay.
Nice. Step 6. Step 6.
Happy face.
6. 6, yes. Erase the line that you have on the left.
On the left. Okay. Yeah.
Okay, step 7, yes?
Instead of like that line that was before going up, make it go down.
Instead of that line before going up, make it go down. Okay, step 8. Step 8. Step 8. Yes? Connect that line to the hip. Not touching.
Something like this, maybe.
Okay, compromise.
Hip.
Okay.
Yeah, not touching. Okay.
All right.
Something
Step
like that.
9, almost there, I think. Step 9. Step 9. Step 9. Yes, and back. Write the word high on the top left of the circle. Okay. And step 10, almost there. Draw a line pointing to high.
Okay, so it's like a speech bubble, basically.
Okay, and step 10, 11. Yeah? Erase the exclamation point. Nice. 12. Do we want to give them one more? 12, or are we good? Yep, last one. Erase the right arm. Okay, I think we're going to need a 13 then. And then? Yeah. Repeat the left arm, but rotate it by 90 degrees.
Okay. That feels wrong. Wait, how would you like, as an organic human being, how would you put your arms? Because like, would you ever structure your arm like that?
That would not be a stick figure.
Would you do this or would you do that?
All right, little hint maybe.
Give me a step 14.
For step 14 and final. Step 14? I think we just got to tell them what to do. Step 14. Yes? Think of a walking man and and have the right hand walking to your right.
All right, so like, it's like.
Where could the hand go? Where should the hand go on that arm? But
what?
Yeah, okay, yes, no. Yeah, I mean, look right here, look right here, look right here. Yes, sorry, thank you. 14 steps. That's pretty close. So congratulations to you guys, and thank you as well. All right. So, I mean, these things too are not, yes, a round of applause then, sure. So This is to say that these ideas of abstraction and precision and really every other term of art that we explored this term are sort of omnipresent and can be easier or harder to implement depending on exactly what the problem is. But what we thought we'd do now in our final day is try to now similarly prepare you for life after CS50. And this is really going to be a list of really potential to-dos so that you can stand on your own after the class's infrastructure, write actual code, and then we'll come full circle one final time with our friend Jennifer 8Lee to look at the world of emojis and how they relate to all forms of representation that we've talked about up until now. So one, how can you go about programming after CS50? So one, you can actually install command line tools on your own Mac or PC. Perhaps unbeknownst to you, Windows has what's generally called a command prompt. Mac OS literally comes with a terminal program in your applications utilities folder. And so even if you've never run those programs, you've actually had a sort of blinking cursor, black and white prompt available to you. Might not have all of the same software installed as your code space in the cloud, but you have that command line interface even within today's graphical tools. And among the tools you can install within that command line interface would be something called Xcode on the Mac, which comes not only with a GUI, IDE, integrated development environment, but also those command line tools. And Microsoft for Windows has something similar as well. Learning Git. So we've used Git only unbeknownst to you underneath the hood for the most part, but Git is a very, very popular tool, if challenging to pick up for the first time, that makes it easy to push code to a website called GitHub or any equivalent, and then collaborate more effectively with classmates. There's definitely a bit of a learning curve, but thanks to CS50's own Brian Yu, you can start, for instance, with a video like this, and this indeed is going to be one of these de facto standards in the real world, at least for the next several years, that you'll probably encounter if you work in tech or really any company where you're doing some programming. VS Code itself will walk you through this process in the coming days, but you can indeed install it on your own Mac or PC. And what can you do when you write code? Well, you can certainly write software for your Mac, for your PC, for your phone, or of course, per week 9, you can host your own website, be it static, as in week 8, hosting it at websites like these, which generally have free or student-friendly accounts via which you can put something statically on the web at a real domain name that you might choose. Or you can host a full-fledged web app. And using student tiers on Amazon and Microsoft and Google's cloud services or others, you can sign up for, being a student certainly, a whole lot of free software, free hosting, so as to, if nothing else, experiment and perhaps maximally get your own app or website up and running. So know that those are resources available to you. And this is by certainly a non-exhaustive list. If you'd like to geek out in the coming months, in the coming years, these are just some of the places that people who take computer science classes, who write code, might tend to hang out and ask and answer questions of each other. So keep an eye, for instance, on these here. And then CS50 has its own communities, as you'll see. If you go to this URL here via the OpenCourseware version of CS50, which is open to the world, is there a vibrant community, thanks to time zones, that's pretty much active 24/7, 365, talking about not only CS50 goings on and problem sets and projects, but really technology more generally as well. So certainly feel welcome to partake, either asking or answering questions. Now, speaking of asking and answering questions, a couple of weeks ago, you kindly gave us a whole bunch of review questions, which we culled through and picked out our favorite 20 of them. These, of course, were multiple choice questions. And in preparation for this week, in preparation for life ahead, we thought we would choreograph a bit of a quiz show here. And indeed, as you came in at the start of class, you might recall being invited to go to this URL here, cs50.ly, either here in person or if you're watching live from home at this URL here. You can use a phone or a laptop. And if it's easier on a phone, you can point your camera at this 2D barcode here. We'll give folks a moment to pull that up. And again, that URL was cs50.ly/poll. And once it looks like most folks have it up and running, our friend Carter here will help us dive into this review session, if you will, with a bit of fun along the way. All right, Carter, if you'd like to take it away. What do we have as our first question? You should see on your phone or laptop this same question being asked. The first question is, how do you print, quote unquote, hello world in Python? So among the possible answers are these here. Buzz in on your phone or your laptop. We've got a few hundred responses already. 7 seconds to make your decision. This is question 1 of 20. Go into it with some confidence. I think we're down to 0 on the clock. And Carter, it looks like 98% of you indeed said hello world. And Carter, per the check mark, that's indeed the correct answer here. Now, to make things interesting, know that you'll see some number of points. And we've deliberately anonymized it, so only you know what number you are. So a whole lot of guests have a perfect score of 1,000 at the moment. Hopefully, we'll see over the next several questions things start to bridge out. But know that the speed with which you buzz in will also factor into how many points you now get. So the faster you move, the more points you get. Question 2, if we could. What does DNS stand for? From just a couple of weeks back, domain number system, domain name system, data numbering structure, or there's no such thing as DNS. A few hundred responses are in. 8 seconds remain. Fewer points now, but still a chance to buzz in. And now, as we hit 0, the responses are these: domain name system, which is indeed correct. And 84% of you got that one correctly. And indeed exists. We talked about it a couple of weeks ago. So we're still seeing a whole lot of ties at 2,000. We'll see if someone starts to pull away before long. Question 3. What is the upper bound of merge sorts runtime? So that escalated quickly. Big O of n log n, big O of log n, theta, or omega of log n, or big O of 1. What is the upper bound of merge sorts runtime? That was the last of the algorithms we saw for sorting. And in 1 second, we'll see that the correct answer is just edging out everyone else. Indeed, 46%. It is n. I know, it's n log n. Now, if I may, as the teacher, it can't be log n, because log n is strictly less than n. And you can't possibly sort n elements unless you minimally look at or touch each of them. So it's got to be at least greater than n intuitively. We still have a whole bunch of ties. Let's move on to number 4. What is stored in argc? Back to the language C. Is it an array of arguments, the maximum size of an array, the count of arguments given to a program when first run, or how much memory is allocated to a function? Again, you wrote all of these questions, and we have 5 seconds for the reveal. argc is indeed the count of arguments given to a program when first run. Think back to C. When we did command line arguments, there was argc and argv. Argv was the array, but argc was indeed the count, the C in argc. All right, we still have a whole bunch of ties at the top here, but let's move on then to number 5. What is the duck debugger's favorite hobby, according to one of your classmates? Dressing up like Dracula, swimming across the stage, filling up the entire bathroom of a guy's house, and sitting quietly on stage. The third, of course, is a reference to a YouTube video that was on the course's website that week. But according to your classmate, number 2, seconds remaining, sitting quietly on stage is its favorite pastime. So a little harder perhaps than the others. 5,000. Now we're starting to see some spread. So we only have six guests in contention for first place. And the next question now is 6. What is the function used to open a file in C? fopen, open, file. What is the function used to open a file in C? 7 seconds. There's some differences between C and Python here. And the reveal, it is indeed fopen. It's 77% correct, too. All right, let's see the rankings now. If you are guest 15, 9715, 6171, 3753, or 3273, you're now in the lead as we move on to question 7. How does Stirling compute the length of a string in C? It looks at how much memory the string uses. It counts the number of characters until it reaches \0. It counts the number of bits in the string, or it creates pointers for each character and counts them. 10 seconds. Stirling in C. Recall that we implemented this ourselves in class, but then we used the library thereafter. And indeed, with 85%, it simply counts the number of characters until it reaches that sentinel \0, aka null. And in this case, we have 5, 4 of you tied now for first. All right, question 8. Where does malloc allocate memory from? The stack, the heap, the pointers, or the temp? Where does malloc allocate memory from? Responses are coming in. 8 seconds. A good review question at that. In 2 seconds, we'll see that malloc allocates memory from, close one, the heap is correct. The heap is correct. The stack, recall, is where functions store their local variables and their arguments, and that just happens automatically. The heap, represented in our pictures up top, is where malloc draws from. Now we have guest 15 has made its way to the top here, but others can catch up if they don't buzz in fast enough. So number 9. How many people flew from 50ville to New York on the day of the crime? 16, 29, 8, or 3? Anyone with a laptop perhaps has an advantage here? 5 seconds. And the answers are, but the answer is 16. Let's see if guest 15 got this. They did not. Goodbye to guest 15 at the top. All right, question 10. We're about halfway there. What are meta tags used for in HTML? To describe a web page, to define parameters for an element, to group elements together, to translate content into machine-readable format. What are meta tags used for in HTML? We saw a few of them for different use cases. And with 1 second, we see that indeed the number 1 answer was to describe the web page, be it for a mobile device, be it for screen scrapers like Facebook and Twitter and other such apps that grab images and descriptions thereof. All right, we're in the second half now. Guest 4669 has edged ahead. Guest 15 is now in 6th place. All right, number 11 is, how do you find the address of a variable in C? Think back a few weeks. Star, $, ampersand, or ask. From one of your own classmates, how do you find the address of a variable in C? And the number 1 answer is ampersand, which is indeed the address of operator at 62%. Nicely done. Let's see who's atop the list now. Guest 4669 has retained their lead, so we move on to 12. What does the arrow operator mean in C? A hyphen and a greater than sign. Nothing, starts a comment, replaces a star and dot operator, declares a pointer. What does this arrow operator mean in C? Again, from a few weeks back. 3 seconds. Harder assortment, perhaps. And it, replaces a star and dot operator. The number 2 answer was indeed correct. This was just a cleaner way, syntactic sugar, for collapsing what would be a star and then some parentheses and then a dot into quite simply something that looks like an arrow itself. All right, Carter, who's in the lead now? Still that same guest. And let's see what 13 has for us. Which of these is not a data type in SQLite? Blob, string, integer, text. We used a few of these more commonly than others, but not all of these are for real. It's 5 seconds to make your decision. And the results are blob is a thing, string is not in SQLite. It's, of course, called text, as we've seen it. Blob, as goofy as it sounds, is just binary large object, but indeed it's how you might store a binary file in your database. All right, the rankings now. Guest 8444 has eked ahead, so we move on to 14. Which of the following is a valid way to print exclamation point, exclamation point, exclamation point, exclamation point in Python? And I'll let you read these yourselves. Which is a valid way. Everyone got quiet and is thinking. All right. 6 seconds. A few hundred responses in so far. All right, and yes, nicely done. 78% is correct. You can use the star operator to essentially multiply the character at left. All right, who's in the lead, Carter? We now have still guessed 8444, and so we move on now to 15. What does the free function do? Deallocates memory from a primitive, deallocates memory at the given pointer, terminates a loop, or returns a value from the function. What does the free function do? All right, 5 seconds. What does the free function do? It's the opposite, essentially, of malloc. And it deallocates the memory at the given pointer as well. And in C, that's on you. In Python, you don't need to worry about allocating or freeing alike. All right, we now have at the top, still guessed 8444 and seeing more and more spread, 16, which is not a step of compiling. Think back now to week 2, compiling, preprocessing, linking, or threading, which is not a step of compiling. We use it as a catch-all, but it technically means a few different things collectively. All right, and threading is indeed not on the list. That is a technical thing, generally meaning a program can do multiple things at once, but that is not related here to compiling. All right, guessed 8444 is still at the top. We have just a few questions left, and so 17. What was the surprise at the beginning of the Halloween lecture? According to your classmates, someone scared me, someone hid candy under every chair, someone dressed up as me, the entire staff dressed up as Carter. It's an interesting litmus test of who came to or watched lecture, perhaps. Let's see which guests got this correct. Someone's really dressed up as indeed me at 64%. So I think we have attendance here, essentially, from that lecture. So let's move on now to the final few questions after seeing that guest 8444 is still doing well. Can anyone dethrone them? Why is it incorrect to use the equals equals operator in C to compare strings? It's computationally inefficient. You're comparing the locations of the strings. Strings don't exist. Using equal equals will lead to buffer overflow. Why is it incorrect to use equal equals in C to compare strings? 3 seconds. We saw this live, and it motivated like an entire week because you're comparing the locations, that is, the addresses in memory of those same strings. All right, let's see if this leaves the rankings the same. Guest 8444 is still at the top and pulling ahead. 2 final questions. 19. What is the difference between null, 1L, and null, 2 Ls? Null and null mean the same thing. Null refers to \0, whereas null, 2 Ls, is the 0 address. Null is the 0 address, whereas null, 2 Ls, refers to \0. Null is null, but lazier. 5 seconds. Subtle, not the best design, perhaps, to have in technical terms. But indeed, 62% of you got that. NUL is the first thing we talked about when we talked about \0, and NULL is a pointer. It's the 0 pointer. Same thing, same number, but different context. All right, Carter, guest 8444 is the person to beat with our final 20th questions. What do the binary bulbs on stage spell today? And these are your 4 choices. Different from usual. We usually use 8-bit ASCII. Today we are using UTF-8, which is a form of Unicode, which is the larger subset that uses 1 or 2 or 3 or even 4 bytes to spell a single character. And the answer, wow, close, is indeed a cupcake. Indeed a cupcake. Well done. And let's see the final results. 8444 is the winner. Are they here in person, perhaps? 8444? You're 844. Come on down. Thank you. Here you go. Congratulations. All yours. All right. So today, if we may, give me just one moment. All right. All right, so today we are so pleased to be joined by Jennifer 8 Lee, who's an alumna of the college, a dear friend, and is actually really the reason why there's evidence of Muppets in CS50. In fact, some years ago, I was visiting her, and she had on her shelf like this custom Muppet. It wasn't one that appears on TV, but she had somehow gone on a website, a former toy store called FAO Schwartz at the time, and you're allowed to configure your own Muppet whatnot, choose the eyes, the nose, the face, and the torso, and I just thought this was the coolest thing. And so in the taxi on the way home, I was like going on the website trying to purchase our very first Muppet. I then sort of woke up the next morning thinking, why did I just buy a puppet in the back of a taxi? And so it sat on the shelf for really 2 years. And then a colleague of mine within CS50's team decided, after I brought it into the office to sit on a shelf there, to actually bring it to life. And indeed, if you Google around CS50 Muppetry and puppetry online, you'll see, in fact, these as characters, not only over the past couple of years in COVID times, when really there was next to no one actually here, and so they were instead, but indeed, she's brought not only this educational element, this pedagogical element, this playful element to CS50, and we have her here today to speak to exactly the sorts of encodings that are here on stage. Jenny is the former vice chair of the Unicode subcommittee on emoji, which is to say that she and her colleagues have been influential in taking emoji from what was a very limited character set early on and by far unrepresentative of much human emotion in speech into really an initiative now to capture digitally all of the world's languages, past, present, and future, as well as the range of emotions that we might see here in the form of that pillow or even in the cake that awaits. So allow me to introduce Jennifer 8 Lee.
Thank you. I much drink. OK. Clicker. Hi. All right, hold on. I have to hide my drinks. I might need more water. All right. I'm really excited to speak here. Last year I was here. One, I was wearing a mask, which is like a real bummer if you're lecturing, and then the entire front part was all Muppets. So I'm really happy to see humans actually. And it's always an honor to speak at Sanders. And then Dave and I were actually classmates way back when. So I do remember him when he was an undergrad, much like you. So I'm going to give a talk on the world of emoji and how I kind of became an emoji activist. So it kind of all starts with my friend Ying Liu, who is a designer who's well known for doing the Twitter fail whale, which was kind of laid to rest, except now this week it seems like it may be necessary again. So she and I one day were texting, this is back in 2015, we were texting about dumplings because we are Chinese-ish women and we like to text about food. And so I sent her this picture of dumplings and she was like, yum, 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 yum. And then she was like, oh, Apple doesn't have a dumpling emoji. And I was like, oh, that's kind of interesting. I didn't really think anything about it because people will point things out to you all the time and then you just forget. You just move on. But then half an hour later, on my phone appears this dumpling with hard eyes, and you don't see it in because it's a still shot, but it actually had blinking eyes, so she liked to call it bling bling dumpling. So she, as a designer, had decided to go in and make her own dumpling emoji because she was like, I'm a designer, I can fix it. But that actually got me thinking. I was like, where do emoji come from? And how is there not a dumpling emoji? Because from my perspective, dumplings are this kind of universal food. Right? So, and there are a lot of Japanese foods on the emoji keyboard. And I was not, this was back in 2015, I was not a big emoji user at all. So, I mean, you have things like ramen, you have bento boxes, you have curry, you have tempura, you even have kind of obscure kind of foods like this things on a stick turns out to be fish things on a stick. Then this pink and white swirly thing is also a fish thing. And there's even that triangle rice ball that looks like it's had a bikini wax, all well represented on the emoji keyboard, but no dumplings. And it's very strange because all cultures kind of have their dumpling, right? Whether or not it's khinkali or ravioli or empanadas, essentially everyone sort of discovered the idea of yummy goodness inside a carbohydrate shell, whether or not baked or fried or steamed. So I was like, okay, I literally Googled, I was like, who controls emoji? And you discover that they're actually regulated by a nonprofit called the Unicode Consortium. And it is, and I just like went on their website and I discovered that they had 12 full voting members as of 2015. So this is 2015. And they were like mostly US multinational tech companies. It was Oracle, it was IBM, Microsoft, Adobe, Google, Apple, Facebook, and Yahoo. And of the 3 that were not multinational US tech companies, they were, let's see, a German company called SAP, a Chinese telecom company called Huawei, and then like the government of Oman. Like those were basically the 12 full voting members of the US multinational tech companies. So they at that point paid $18,000 a year to have full voting power on the Unicode committee. And I was like, oh, that's a lot of money. And I kind of felt indignant about this. And but then, like, if you kind of keep on digging on their website, you found like there was this kind of interesting loophole, which is you could join as an individual for $75. You don't get voting power, but it gave you the right to put yourself on the email list and also to like attend the quarterly Unicode meeting. So I was like, I'll do that. I had no idea what I was doing, but I'm like, I'm going to go fight for this dumpling emoji, because from my perspective, dumplings are universal, emoji are kind of universal. So the fact there was no dumpling emoji meant like something was wrong in the universe, and I was determined to fix this. So, I was on this email list, and then a couple of maybe even a couple of weeks later, I got, they kind of sent out this note that's like, hey, who's coming to the quarterly meeting? And I was like, I looked at the calendar, I looked at my schedule, I was like, oh, I'll be in Silicon Valley at that time. So I basically RSVP'd, and I was like, I will be there, and took Caltrain to an Apple building. It's a legal building in, I think it was Sunnyvale. So I just show up. And I don't know what I was sort of expecting, with the Unicode. I think maybe thought it was going to be a baby Congress, with a little, very formal seats, people with gavels. That is not what I found. Basically, it was a conference room full of people who skewed whiter, skewed older, skewed male, skewed engineers, and this is basically the room where it happened. So this is 2015. These were the people who decided your emoji. All very nice, and there was, one even had a daughter who had a sense of humor and made him a shirt that said, "Shadowy Emoji Overlord." So I just kind of listened to them debate things like milk emoji and beans emoji, and it just seemed not quite right to me that it would be this global visual language that were basically decided by a small group of people inside a conference room in Silicon Valley. So I decided to form a group called Emoji Nation, whose motto is emoji by the people for the people, and it basically advocates for more kind of representative and inclusive emoji. We started with a Kickstarter campaign, dumpling emoji process, trying to right the wrong in this world, and made this little cute video sort of advocating.
Dumplings are one of the most universal cross-cultural foods in the world. Georgia has khinkali, Japan has gyoza, Korea has mandu, Italy has ravioli. Poland has pierogi, Russia has pelmeni, Argentina has empanadas, Jewish people have kreplech, China has pot stickers, Nepal and Tibet have momos. Yet somehow, despite their popularity, there is no dumpling emoji in the standard set. Why is that? Emoji exists for pizza, tempura, sushi, spaghetti, hot dog, and now tacos, which Taco Bell takes credit for. We need to right this disparity. Dumplings are global. Emoji are global. Isn't it time we brought them together? Oh yeah, and while we're at it, how about an emoji for Chinese takeout?
So I did put together a dumpling emoji proposal. I wrote this, I remember Thanksgiving Day 2015 on a plane. And and we got it passed. Basically, dumpling, takeout box, chopsticks, and fortune cookie. I have to say, I don't think fortune cookie would have made it on its own merits, but it kind of slid in on the coattails of the other ones. And so these were the proposals as we submitted them, and then these are the ones that kind of exist now on the Apple keyboard. And I have to say the dumpling looks really, really realistic. Oddly realistic, and whereas the fortune cookie I think is a big fail, because first of all there's it has no gap. It looks like a dead 3D Pac-Man. So I'm very disappointed in the manifestation of that, but that's okay. That's okay. And so it's kind of interesting. What is the process of getting an emoji passed? And I will sort of walk you through it. So first of all, you come up with your idea, right? And then you kind of write this proposal, and then you submit it to the Unicode Emoji Subcommittee, who then kind of gives you comments and then sends it back to you. And you kind of go around and around in a circle. So these are things that we consider. So somewhere in there, I also like fought my way on to the Emojis Committee, and then also became a vice chair. It's sort of a extracurricular that's like completely run amok in my life. So things that matter. Popular demand is a frequently requested emoji. Multiple usages and meanings. So that's actually kind of very important for something like, certain animals have meaning. So we did, sloth a while ago, and it also has not only the literal meaning, but sort of like connotations. There are visually distinctness, it can be recognized. So this was a blocker for one of the emoji that I have worked on before, which is cave, which is kind of hard to do. I think, meaning-wise is pretty good, but it's really hard to get a cave down in emoji sizes. And then filling a gap, completeness. So a good example for that is like, for some reason, for many years, we had red heart, yellow heart, green heart, blue heart, purple heart, and no orange heart. So you would do the rainbow, but people would substitute the pumpkin in. So you would have a rainbow heart thing with a little pumpkin stuck in the middle. So orange heart obviously should be added and give a sense of completeness. And then something else is existing vendor compatibility. And so a good example for that was many years ago, WhatsApp decided to add the gender non-binary emoji. And then once it did that, then all of the other kind of vendors jumped on. So what kind of knocks out an emoji? So too specific or narrow. So we'll often see that with like very specific animals or a very specific group. It's redundant. So 1 year, oh my God, who makes the Butterball? Butterball makes the turkeys. Butterball submitted an emoji proposal that was like a cooked turkey, but we already had a live turkey. So it seemed kind of redundant to have both like a cooked turkey for Thanksgiving and a live turkey. So not visually discernible. This is a struggle for things like, I don't know, my friends have kind of proposed kimchi. Kimchi is really hard on emoji sizes for many reasons, and part of that tension is because it's not visually discernible. Then there are no logos, brands, deities, or celebrities, so no Nike swoosh, no McDonald's M. And then this is one that we kind of decided in the last year or so, which is no more flags. Flags are a very complicated thing. And as a result, Unicode does not want to be in the business of deciding what is a country or not a country. So like, when you get a proposal from like Kurdistan, you're like, yeah. So right now, the way that the emoji flags are decided is they kind of depend on what the UN recognizes. And then those get passed down to the International Standards Organization, and then Unicode just does that. Like, it does not want to be in the business of kind of, the geopolitical affairs. So once it comes out of the subcommittee, it goes to the full Unicode Technical Committee, UTC. Those are the people that were in the room that I showed you. And they vote once a year, basically, to pass all the emoji. And it takes a while. There's a lot of like coordinating with the International Standards Organization and like a lot of working with the companies. And eventually, it takes a long time, but it ends up on your devices. And that historically has taken about 18 to 24 months from when you put in a proposal to when you get it in. It's going to be a little bit longer going forward, probably, is my sense, as Unicode has decided to sort of space out some of the Unicode releases. So Emoji Nation, kind of has done its thing. So one of the weird things is like, how did Unicode, this like kind of nonprofit organization based in Mountain View, California, end up controlling this like global visual language? So a lot of it has to do with the fact that emoji started in Japan back in the late 1990s. This set from Docomo in 1999 is widely considered sort of like the first like color emoji set. It has been collected by the Museum of Modern Art. And so the Japanese telecom companies would have their own sets of emoji, and then there were different companies, so they would have different sets. So you could basically only send these like visual characters with someone who was on your same carrier. So it's like basically equivalent of if you were on like Verizon, you could only text people on Verizon with like emoji, or if you were on T-Mobile, you could only do that. So at a certain point, they decided they were the Apple and Google came into Japan. They wanted to start selling smartphones, and they realized that it was a hodgepodge of systems, and they wanted to unify it. And so in 2007, they went to Unicode, and they're like, okay, help us unify the emoji, basically all the emojis so that we have one standard system. And part of the reason is why Unicode? Because Unicode basically has this mission is to enable everyone speaking every language on Earth to be able to use their languages on computer and smartphone. So it basically unifies all written languages into one ginormous set. And that was not the case actually when I was growing up. There was a point where if you were Japanese on Apple, that would be different than Japanese on DOS, or like Chinese or Arabic. So it drove everyone crazy, and they basically decided around the late 80s or early 1990s that they were going to come up with one standardized system that sort of encoded all characters in one ginormous set. So there's 3 main projects for Unicode, if you care. So one is encoding characters, including emoji. Now there are about 100,000 characters assigned. So that includes like Chinese, Japanese, Korean, Arabic, Cyrillic, actually all the hieroglyphics, all of the emoji, a lot of things like the Bitcoin symbol or like copy left or whatever. Those all assigned were about 100,000 characters, even those languages that are basically out of use. So the other thing it does, it creates localization resources. So things so that you know, like, oh, if you're in this country, you're using the euro, or you're using the pesos or something. So there's a lot of localization that data that is needed depending on which geography you're using your device from, or like that, you know that the time is used this way, or dates are shown that way. So that is called the Common Locale Data Repository, or CLDR as they call it. And the other thing they do is they kind of maintain libraries for developers in order to do all so they are not building everything from scratch, and that is called ICU. So it's very funny because it's called CLDR, and then one day one of our friends' girlfriends made him this thing which she called a seal deer, because whenever he talked about CLDR, she thought he was talking about seal deers. So now this is his little mascot for Unicode related things. So how does Unicode do this? So it basically assigns code points, and each code point is a unique number assigned to each Unicode character. So face with tears of joy can be written like this with a code point, or it can be written like this in terms of decimal numbers, and it can also be written this in binary numbers. So these are all basically the same. And the key thing to know, at least about emoji, is that when your device, if you're talking your iPhone with someone who's on a laptop or an iPad or on an Android device, it's not sending the images back and forth, it's sending just a number back and forth. And then locally, your phone or your laptop decides oh, this number correlates with which image in terms of our emoji font, and then pulls it up. So this is really key to know why different emoji look different on different platforms. So 2007 to 2010, it took about 3 years, but Unicode 6.0 came out with our first little baby set of emoji. And it just kind of hung out there for a year. It wasn't doing anything. So 2011, though, Apple starts adding the emoji keyboard, and it just explodes. I feel like in some ways emoji were not invented, they were discovered. They obviously touch something very, very primal to our human desire to communicate in little colorful glyphs on electronic devices. And you kind of have, what's kind of really interesting is the ambiguity that comes with what emoji kind of mean. And so one of the, this is one of my favorite emoji. It's sort of like an upside down smiley face, very, very ambiguous, clearly very ambiguous, because if you start typing into Google, the top hits are what does it mean from a guy? What does it mean from a girl? It's clearly something that a lot of people are using in complex situationships between each other. So, so one of the fun things is who can propose emoji. Technically, anyone can, anyone here can, normal humans can. We have basically Google Doc, or Google form that we throw up historically between April and August in the last 2 years. So this is one of our favorite examples. This is Rayouf Al-Humeidi. She was a 15-year-old Saudi Arabian girl who was living in Vienna at the time that she proposed hijab emoji. And then, then she was like Time Magazine, like, coolest teens. She got like a whole bunch of different things. She got into Harvard and Stanford, and she went to Stanford. So this is a proposal we got. Then there was a group of folks from Argentina who got the mate emoji, kind of, sort of similar to their national drink. Then we worked with, there was a nonprofit that really wanted to like get a menstruation emoji, and so what they proposed to begin with was like bloody underwear, and I was just like, no, so many different reasons why this is a terrible emoji. But so we did get blood drops, and then you could do moon and blood drop, or underwear and blood drop. There's a lot of different ways. Actually, it's really funny because I was polling my friends beforehand what they would use to indicate menstruation before there was a blood drop. So there was like red wine. There was like kind of that rose with the like falling petal. And then my favorite is actually my friend who used the Japanese flag as a way to indicate that she was having her period. So one of the biggest contributors, this skin tone emoji, appeared I think in 2015. It was amazing. And it was proposed by a mom, Katrina Parrott. She is an entrepreneur and a mom who was just like at home one day, and her daughter comes home and is like, I wish there were emoji that looked like me. And her mom was like, that's great, honey. What's an emoji? And so she, like me, I guess, Googled and just figured out that Unicode-controlled emoji, and she just came up with a proposal saying we should not only have the yellow, skin tones. At that time, everything was sort of Simpsons yellow. It's really interesting to see how race and like nationality are like depicted in different parts of the world. So originally in Japan, everyone was yellow, but these were the so, by default, everyone was just like human or Japanese, but they had like a couple things that were like not. Like one was you had a blonde person, so there's an emoji called like blonde woman or whatever that represents all Westerners. Okay, so that was one. And then they have one that's like an Indian guy with a turban, so that's supposed to represent Indian people. And then there's like a guy with a little little hat that's supposed to represent like Chinese people. So that was the Japanese view of race, which was like default. Then you were like blonde Western, Chinese, or Indian, and that is all there was. And obviously in the United States, we care a lot about race, and then so she came up with a system with 5 skin tones. Just like normal people. Some guy in Germany decided that he wanted to do a face with one eyebrow raised, or as we call it, the Colbert emoji. Oh, this one's fun. So woman's flat shoe. I have to say, not highly used statistically at this point, but I really kind of appreciate it because it was a mom who was very offended that all women's shoes had heels, even the sandals. So this is her. She had like 3 kids at the time. She now has 4. She was very fertile. And she also did the women's flat. Okay, she also did one-piece bathing suit because she was also offended by the fact that the only kind of bathing suit you had was like this like little itsy bitsy polka dot bikini thing, which is not great if you're like taking your 6-year-old. So I have to say that got passed, but like it didn't go over like super well with everyone. So Unicode, because it's very public, submits things for comments. And we got this comment back. So one-piece bathing suit. Why? A person wanting to indicate the use of swimwear can't use existing bikini? Is this really necessary? What about a Victorian bathing costume or a wetsuit or water wings? This is like literally in like the records. And I do not encode. And so the person who did this is actually very impressive. He's actually the person who created the middle finger emoji. And actually, if you've ever seen the Vulcan emoji, the Vulcan hand emoji, he's actually very active. And I have to say, this is actually, I think, one of the more impressive emojis. So obviously, we have a lot of active debate. Sometimes you get like whole countries submitting. So literally the government of Finland, as in like their equivalent of the State Department, their diplomacy kind of thing, submitted a proposal for sauna. And these were so creepy and so weird. So much is wrong with this. But I felt where they were coming from. First of all, like, they're naked. They have club feet. And so we decided to help them. We're like, okay, we see where you're going with this. Let's see if we can like help you like come up, like we had the spoon, like should there be like steam around them, like should they be naked or wearing a towel? It was like super like dicey, but we wanted to help them because it was like literally a foreign government coming in front of Unicode advocating for the sauna emoji on behalf of their entire country. So then this is, it sort of evolved into just basically person in steamy room, which is the most sort of like the PG version of sauna. No, and there's no spoon, they're all dressed, it's very odd. But so you can see the evolution of what it started out, what we submitted, and what it ended up. So there's a lot of like evolution throughout the entire process. And like companies can submit emoji proposals too. So Google actually worked on this one. I love this one. Okay, so just to give you some context, as of 2015, there are many ways you could be or have an occupation as a male on the emoji keyboard, right? Like for example, you could be a police officer. You could be a detective, you could be a Buckingham Palace guard, you could even be Santa Claus. Like these are so many jobs that you could have. But if you were a woman, as of 2015, there were 4 things that you could be. You could be a princess, you could be a bride, you could be a dancer, or you could be a Playboy bunny. These were the sum total of all the occupations that we could have. So there was sort of this movement at that time. There was like this like video on YouTube that like went viral. There was like a New York Times op-ed that was like, where are the women with professions? So basically they came up with a set of emoji for professions. And what's nice is not only did women have these professions, now men have them too. So of Emoji Nation emoji, these are some of the ones that we've worked on. I think about 130 of the emoji on your keyboard probably came through, touched our system in some way, including, I have to say, microbe or virus. I think I have the opinion that every emoji has its day, right? Like it might not be like today, it might not be next year, but I have to say virus was not doing anything. Then came 2020, and that was like such a good moment for it. Along with soap, we had also done soap. So, among the other emoji that we have worked on are starry, mooncake, llama, like teddy bear. There were no toys. I felt really sad for toys. We have like giraffe. There was hut. Bubble tea. Bubble tea was very controversial, actually. I have to say, we tried to slide it in originally with the takeout box and the dumplings, and people were not happy. And I understand that because there's not a lot, like compared to like beer or wine, like bubble tea does not have a long history on this planet. But I will say that they submitted again, actually kind of originally proposing that it was not just bubble tea, but like a black ball and milk and tea. It was kind of cool. And I have to say there was definitely a generational divide between like the Asian women who sit in that room and are like, this absolutely is a thing that we consume like almost like every week of our life. And people who are a little bit older who are like, that looks like a parfait. How do you not know that's a parfait? And we're like, we absolutely know it is not a parfait. And so it got in eventually. So it does sort of influence, it kind of shows like who is in the room influences, the decisions that get made, or sometimes in the room, now sometimes more likely in the Zoom. I actually have to say beaver emoji. If you see beaver emoji, that's one of the ones I'm most proud of. So that is actually co-authored by a professor here at Harvard who is both lesbian and was married to a woman from Canada. So it was very important to her to get the beaver emoji passed. And she promised me it would always be the first line of her bio. So, and indeed, if you go to her Twitter handle, it's like Joan Donovan, creator of the beaver emoji, comma, is head of research at the Shorenstein Center at the Harvard Kennedy School. It's pretty impressive. And then we did greens. Actually, greens was really interesting because this was also like a generational cultural thing. People were like, why do we need greens? We have salad. And I was like, we're Chinese, we don't eat raw greens because like you don't know where it's been or if it's clean. So we cook our greens, so salad is not something that we have. So eventually I got my greens, and so that was kind of fun. And then, so these are some of the people who sort of have contributed to our little Emoji Nation things, including a number of Native Americans who helped get feathered. So why do I care? So part of it is because I'm Chinese. I grew up speaking Chinese and English at the same time. And it's really interesting to see like Chinese and English characters in terms of emoji and Chinese together, right? So this is fire, you have like fire characters, and now you have the emoji things. And it kind of shows that there is a longevity in the human experience of something that was designed 4,000 years ago as the same visual cues in the human experiences as now. So mouth, tree, moon, sun. You can mix and match them, which is super fun. So, 2 trees, kind of make a forest. Oops, sorry. Oh, well, okay. Then the moon and sun together means right, which I like. I like this one. So if you stop and you think about this, so this is basically a pig under a roof. And what does that mean? It does not mean farm, as you might think. It actually means home or family. So in the Chinese kind of structure and outlook on the view, it's like where you keep your pigs is actually where your home is and what your farm is. So it gets kind of weird in all kinds of ways. So one of my favorite radicals, so this character means woman, ni, and as I was learning Chinese, you kind of notice like how it shows up. So this is a woman underneath a roof, and you're like, oh, it means mom or wife or like whatever, like home. It does not. It means peace, because things are at home when the woman is, or things are at peace when the woman is at home underneath a roof, which I always thought was a little bit odd. Then there is also woman plus child. So you're like, oh, and actually specifically boy child, the connotation there is a little bit unclear. So you're like woman plus child, family, mom, you know, whatever. It is not, it means good. So the standard for goodness in ancient China was a woman who had a male child. So that kind of just like kind of irked me growing up. And then, you know, 3 women together means evil, which is like very like Macbeth. This character means greed. This character means slave. This marriage, let's see, I think this one is jealousy, and this means adultery or betrayal. So, like, definitely not loving the way women were portrayed on the emoji keyboard. So, in case you're wondering, we just came out with a kids book called Hanmoji that kind of compares emoji and Chinese, and I think they sent out a bunch of books so that you guys can do some kind of contest, like later on with CS50. But the mixing and matching is really interesting, right? For example, the skin tones are actually the same yellow character plus a layer of skin tone on top of this. So I kind of took my lessons from Chinese in terms of seeing how things can be bind. So there's something you should know about, which is zwij. This is also an invisible emoji character. It stands for zero with joiner. And it was actually originally created mostly for, I think, Arabic, where you would basically kind of force something to have like be in the beginning of a word or an end of a word by kind of having this like invisible character. So the rainbow flag, for example, is actually a rainbow plus the white flag. And we could have all kinds of fun combinations. If you look at polar bear, it actually is, if you have an older device or it breaks apart, it is bear plus snow, which is really cute. It was, originally I had bear plus white, and then we decided that bear plus snow made a lot more sense. So another one, this is new, I think you guys should have it if you've updated your phones in the last year or so. So mending heart is heart plus Band-Aid. What is this one? Oh, this is interesting. There was a breastfeeding woman for a long time, and people felt like there was not gender parity. It was actually really interesting. All the people who wrote in and were like, I want to be a dad showing that I'm holding my baby. Why is there only a woman holding my baby? So we kind of created a whole set. So this is man plus bottle. Ta-da! And so this is, and all of these occupations are actually oftentimes a woman plus, like, you know, the fried egg, or like a school or a tractor, and that's how you got the occupations. If you send an emoji over into an older system, sometimes it'll break apart. So one of my kind of favorite kind of contributions in this world is interracial couple emoji, which we did with Tinder, which is super fun, because then you could have, you know, different couples that are, and like so many combinatoric. This is a fun, if you guys ever have to do a combinatoric test, this is really fun, because you have 2 genders plus a third neutral gender plus 2 people plus 5 skin tones plus yellow. Like, how many emoji couples can you come up with when you introduce this factor? So this is, and underneath it, it's just a zwij sequence. It's like 2 people standing together that are like glued together. Now, this actually gets interesting from a CS50 perspective, because in many cases, even though you only see one character, underneath the hood, depending on how your system works, they're counting each one of these as an individual character. So your string length actually might be 5 instead of 1. And this kind of became a problem with things like Twitter, where things had a hard skin length. So gender inclusivity is actually one of the things that we've been dealing most with in the last couple years. So it's kind of interesting if you think about both what a pictorial language looks like versus the abstractness of a spoken language. So, because we had boy and we had girl, but there was no way to say generic child, right? Like if you want to say child, you had to pick a boy or a girl, but not a way to say like just some little person. And that's really key because in English, at least, there is no gender implied by child. So how do we mimic that? And it also is key for something like doctor, right? Doctor and teacher, those don't have gender implied, but when we have them on the emoji keyboard, you have to pick a male teacher or a female doctor or whatnot. So there was actually a guy at Adobe who considers himself non-gender binary. Also the man behind the orange heart, he fought and got basically the first three non-gender binary emojis. So child, adult, and older adult. So those are created. And then we started having to propagate them through actually all the occupations. So these are the gender neutral versions of many of those. But then we got into this whole thing where every emoji that had a gender originally had to be mirrored. So originally we had bearded man, and then we're like, okay, well we actually have to get bearded woman. So that is on your keyboard. There is pregnant woman. There is now pregnant man, which is interesting. There is, woman in a bridal gown. There is now man in a bridal gown. And then there were ones that actually had to be created that were neither man or woman. So this is a mer person. So there was merman, there's mermaid, and there was mer person. It was really interesting to figure out, like, how do you draw a gender neutral mer person? Like, a bunch of them in the beginning actually had the arms crossed around sort of the chest. Monarch, so there was prince and princess, and now there is monarch. And one of my favorite actually is there was Santa Claus, and there was Mrs. Claus, and now there's MX Claus. Like, the name of this character literally in Unicode is MX Claus. So I feel like it's sort of like a very official enshrining of gender non-binariness in like the world. Not everyone loved it. New York Post did not love this. They're like, we're getting into like emoji woke wars. So some emoji stats for you. This is very fascinating. This is sort of like the general distribution. By far, the single emoji that you use more than anything else is the face with tears of joy. About 10% of all emoji sent is that one character. And then number 2 is heart, red heart. And then it kind of goes down. So there's a frequency of emoji use. This is sort of done by order of magnitude. So 1 is half of 2, 2 is half of 1, da, 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 da. So it's really interesting. It's a very, very steep drop off after the first couple. In case you ever want to go onto the emoji kind of Unicode website, you too can see all the frequency things. So I think it's really funny. So basically, if it's green going this way, it increased in usage between 2019 and 2021. If it's red going this way, it dropped. And so pleading face, which was a relatively new emoji, just sort of shot up on the charts. And whereas actually like smiling face with heart eyes actually like kind of slipped, which is interesting. So we just closed our emoji proposal round for 2022. These were sort of the breakdowns. People love submitting smileys and food and beverages, animals and nature, da da da. I mean, these are very googly colors. So what is the future of emoji? I will tell you because we just had a meeting 2 weeks ago, so I can now publicly talk about it. So historically, there was this whole idea like Unicode doesn't want to be in the world of like encoding glyphs for like devices everywhere. Like there was very controversial when I started doing that because mostly what Unicode used to do was we take an existing language, could be dead, and then it would just take it and digitize it, right? It took languages that existed and just digitized them. And then when it kind of wandered into emoji world, suddenly it's like deciding what deserves to be, like an emoji decides to be digitized. So trying to get out of it, and they have proposals over time where it's like, oh, maybe we should like come up with a way to just send pictures back and forth where it's a fixed picture and you like use a hash so that like we would look at the picture and then like go do a lookup somewhere. Like that did not go over well. Then there was actually a really interesting proposal I kind of like, didn't go over well, which is using something called a QID, which is in the Wikipedia world. So in Wikipedia world, items all have numbers across the different language Wikipedia. So Obama, human Earth. They will have an ID number so that the page in English and the page in German and the page in Chinese all know that they're pointing to the same thing. So so one idea came up, like, why don't we use a numbering system? So we can use like Eiffel Tower and, see the number, and then like, oh, people know like, oh, you're trying to say Eiffel Tower. That did not go over well. So those are both of those proposals seem dead as of yet. And it's too bad because you'll see kind of what's happening. Okay, so what's coming in 2022? So these are the emoji that I actually sort of thought they would be on your phones by now, but because we're in mid-November and they usually update early November. So 3 more hearts. People love hearts, like wing, blackbird, goose, birds also, purple flowers, jellyfish, moose-faced donkey. Donkey was a little bit late for the kind of elections. Ginger, pea pod, wireless, conda, shaking face. Folding hand fan, that one was interesting because when people first proposed it, they proposed it as like an electric fan, and that didn't, like, who knows what electric fans will look like in 100 years? Because the thing is, once an emoji, always an emoji. They never retire, so they're always looking for things that have a visual longevity. Floppy disk did not actually do that, so there's always like, we don't want another floppy disk. And then hair pick is interesting. So there was a whole debate about how to convey like African hair. Like the curly hair that they introduced a couple years ago was supposed to do that, and most of the vendors actually have it in a sort of Afro-y way, except for Apple. So there's a lot of complaints, but hair pick was sort of an interesting way. It means both comb, but also has sort of an interesting historic connotation, and it's been around for about 2,000 years. A couple of music things, maracas and flute. Beyond 2022, one of the things that's gonna die, oops, can I go back? No, I can't. Oh well. We're going to retire the family emoji. They didn't go over so well. There were so many of them. Combinatorically, if you had everything in all the races, because you wanted to have skin tones, because you didn't want to imply that families can only be one race. It was such an ordeal. Essentially, we're all like, no one uses them, and there's so many, and it's like the fonts, like in terms of the load, is like too large. So they're just going to make them all into like basically little like bathroom symbol type folks. So I think those will disappear. What's actually really interesting about the family emoji is they had when they introduced the family emoji, they had gay family emoji, and the Russian government went berserk. And actually, you can Google this in 2015. You'll see a bunch of articles about like the Russian government considering it homosexual propaganda to youth, and there was a big debate about whether or not they were going to ban Apple devices and whatever. So you can see a lot of the media coverage from that time. But I thought it was really interesting how upset a national government can get about little pictures on your phone. Another thing that's on the agenda as of a couple of weeks ago is directionality in terms of emoji. So as you know, most emoji kind of just flip one way or another. And the reason why it matters is because not all languages run in the same direction. So for example, Arabic. So we are used to left to right, but a lot of languages go right to left. And this kind of changes the meaning of emoji. For example, right to left. I send this a lot to my friends when I'm flying from the Bay Area to New York. If you do it from left to right, however, that is what it looks like. So it looks like you're in the Bay Area, but the plane is still going that kind of up and to the right, and then now it looks like you're going from New York to the Bay Area. The other place is like, oh, it's a girl and she's running really fast, right? That is right to left in our world. Wait, left to right. Sorry. That's supposed to be left to right. And in here it would be she's like behind like pollution or something like that. So sorry about it. So an example. This is actually in the proposal. Like in one case, if it's left to right, you're running away from a line of cars. In the other one, it's a warning to not run behind car fumes. So they are trying to figure out like how do we mirror a bunch of the emoji. But the main thing that I think sort of, I don't know when it's going to happen, I'm really hopeful it's going to happen, is trying to come up with a system that supports little stickers in line that don't need Unicode. So this is like Slack or on Twitch. You can embed little pictures in line, and all the vendors have to get together and agree to come up with a standard way to do that. They have not yet come up with that, but that is sort of one of the ways that Unicode wants to back away from actually being like a global regulator for like little colorful glyphs. And so if you ever need to reach me in my emoji world, you can find me, Jenny at emojination.org. There will be it will be actually a while, I think, before we see a next generation of emoji showing up in keyboard. It used to be like every year they would get new code points. It might be a little bit less than every year now as they work on things like directionality over time. So that, if anyone has questions, you can ask questions. You can find me afterwards. I think I feel like there's supposed to be some hubbub right now about maybe microphones, but maybe not. But maybe I'm just done. And if there are questions, or if David is around, I'm happy. I'm happy to answer any questions that folks have. Yes. Yes.
I was wondering, what were your thoughts on like the Emoji Movie?
So the question is, what are my thoughts on the Emoji Movie? You're talking about the Sony animated one. Yes. Okay. My thought on that is it is better than a 6% rating on Rotten Tomatoes would lead you to believe. So that's my one thought. And my next thought is that that was a rush job from an animation perspective. That was about 18 months of, whereas a typical animated movie takes 4 years. So in my spare time, I also produce movies and documentaries. So one thing that is key to know about movies and animated movies, and this is very important, they take a very long time, but you can always fix it because you haven't shot anything. And a very good example of that is, I assume you guys have seen Frozen. If you haven't seen Frozen, you seem of the age that you would have seen Frozen. I do not understand like how huge and a phenomenon, or why it was such a huge phenomenon, but they actually did an original cut of Frozen, and it did. So I don't know if you guys know the sort of Snow Queen thing, but she's like super dark and like not fun and like kind of evil and like not someone you want to like get behind as a character. So they actually did sort of a rough cut of that, of Frozen, and they came out of that with it's just storyboarding, and they were like, that is not good, and they killed it. So they were like, we can't go with this, and then started from scratch, more or less again, starting with the song Let It Go, which is actually written by a kid from my elementary school, Bobby Lopez, or co-written by Bobby Lopez. I also, actually, fun fact, I took the school bus with Lin-Manuel Miranda. So I was a 4th grader when he was like a kindergartner. So we had a very musical elementary school in New York City. But the thing is, they could fix it because they had enough time and have enough money. Not like movies where you shoot humans, much harder to fix because you have the footage that you have and you can do little pickups, but you can't fix it. So essentially what happened in that case, I think, it's 18 months, and it could have gotten better. And a lot of the movies that you see with Pixar, like it's actually sort of emotionally similar to the movie called Inside Out. And but Inside, they just have more time, and so it's better. So as opposed to 18 months, which is not long enough to make animated movie good. But the other fun thing is, it was so weird because they sold sponsorships. It was like. Oh my God, here comes the bots and the malware. Let's go into Dropbox and protect ourselves. And so I think that it got a lot of like bad kind of vibes from the press for doing things like that. But from a kid's perspective, it's fine. I think if I don't know that I would like put it on my top 10 of animated pictures, but it's better than 6% on Rotten Tomatoes. And then actually, if you guys ever care, we have done, I did a documentary about emoji, and all the people that helped create emoji. And we did a CS50X movie night, I think, during the pandemic. Was it during the pandemic? Everything's sort of like blurred together, but it was during the pandemic. Yeah. Are we, more questions? Yes. Or there's demand, yeah. Yeah, that's a very good question. Yeah, so the question is, one of our criteria of getting an emoji accepted is to sort of demonstrate demand. And how do we demonstrate demand? And I would say it's in a pretty clumsy way, actually, at this point. So the main thing that you have in our current proposal process is we have a median emoji, which is elephant. So elephant is like, if you stack ranked all the emoji for popularity, elephant is like right there in the middle. And it's also a concept that's like universally understood across all languages. So elephant shows up somewhere between 500 million and 700 million in Google search results. Like if you type it into a laptop, you'll see, elephant, 500 500 million search results. And generally, you're trying to, when you're comparing your term to elephant, you want to see very roughly how many Google search results, Bing search results, sometimes Instagram. So actually, something that was really surprising to me was someone proposed hummingbird. I think hummingbird is a good proposal. And but if you look at hummingbird, it's only like 21 million in terms of the stats, so which I thought was like very surprisingly low. So that's one of the main ways that we kind of see, like, is it also visually used and all of that. Yeah. Any other questions? Are we good? I didn't even need my water or anything. Oh, can I take? And I'm going to take a picture. I'm going to take a picture because now you guys are actually human and not Muppets. So I'm very, very excited about this. So I will send this to like my blockmates and be like, I just lectured at in Sanders Theater.
Well, my thanks to Jenny Lee. Thank you. Yeah, you can stay up here if you want. Give me 1 second. So if up until now, thought it would be appropriate to toss this up on the board. If up until now you've not yet gotten a CS50 stress ball on the way out, please do grab one. We got some extras as well off to the side. But I would also keep in mind back in week 0, where again we began, we asked you to categorize yourselves as to whether you are among those less comfortable, those more comfortable, or those somewhere in between. Please know now that you are officially all Please know now that you are all officially among those more comfortable. And indeed, even though a couple of more milestones await, we cannot wait to see what you accomplish with your final projects. In the meantime, as always, this is, and now, this was CS50.
Mr. Sandman, when I enrolled in CS50, I'll say truth be told, I thought I'd be a real coding hero because I did so well on B-Set 0. Sandman, it picked up so fast. Turns out that C is harder than Scratch. Hello world and goodbye sleep, because this is CS50. Mr. Sandman, I was on the Val grind, trying so hard to not fall behind, attending section and wanting a tutor, stuck in the inch-main void of my computer. Sandman, finally getting ahead, then Malin switches to Python instead. Why we spend 5 weeks on C? Because this is CS50. Mr. Sandman, we completed each task, JavaScript, SQL, CSS, and Flask. With every language, our minds had to reset. Don't get us started on that finance preset. Sandman, now on week 10, my friends asked if I would do it again. I replied, obviously, because this was CS. No more presets, because this was CS50.
right, so this is CS50. My name is David Malin, and this is Harvard University's Introduction to the Intellectual Enterprises of Computer Science and the Art of Programming. And this, of course, is our special family weekend, wherein not only are CS50's own students here in the audience, but also some family members as well. Now, you're showing up in the semester a little bit late. We've just tackled week 8, which is really our 9th week since computer scientists start counting from 0. So we've done a whole lot of work over the past few weeks, as you might have heard via emails or text messages home, including a language known here as binary. So on the screen here, of course, is a lot of zeros and ones. And suffice it to say, let me sum up the past 9 weeks with this is what's going on underneath the hood. But of course, today we thought we'd make things a little more accessible, a little more broadly applicable. And indeed, our focus today will not be on what these patterns of zeros and ones represent, which an astute eye might notice are replicated visually with these light bulbs being in a pattern on and off. And as your child might have hinted before class, or perhaps now, this might very well spell a word up to 8 characters long, because you can encode, even in the real world, things digital too. But today we'll focus on things much more high level, this notion of cybersecurity, like the security of our data, our privacy of our systems, particularly on the internet nowadays, because presumably all of us are carrying technologies around in our pocket, using laptops and desktops every day. And so the goal today is to stipulate that this is what's going on underneath the hood, but let's solve some problems at a higher level so that your homework, when you go back to wherever you're visiting from, can actually be to apply some of today's lessons learned. So with that said, perhaps the most common familiar defense of one's systems and data, phone and laptops and desktops would just be these simple passwords. Unfortunately, you and I are, frankly, as humans, not all that good at choosing passwords. And this is in itself a relatively weak form of defense, even though each of us has dozens, hundreds of passwords nowadays, or at least dozens or hundreds of accounts, maybe 5s or 10s of dozens of passwords. Indeed, if you're in the habit of reusing passwords, we'll see today, probably among our first lessons learned. So for instance, if we look back at the past year, 2021, thanks to security researchers who take a look at data that has been hacked or leaked online by way of public databases, we have a sense as computer scientists of what the most popular, or equivalently, what some of the worst passwords are that you and I are choosing for our system. So as of this past year, according to one measure, the most commonly used password in systems everywhere was 123456. All right, so number 2 password in our top 10 here list was only slightly longer, 12345678 After that, we took a turn in the other direction, 12345 alone. After that, got a little more interesting, QWERTY, which might sound pretty cryptic, but not if you look down at your US keyboard and it's the top left-hand row of the keys on an American keyboard. So also not all that hard. Perhaps not surprisingly, a little disconcertingly, number 5 was password. Meanwhile, number 6 returns us to digits, 1, 2, 3, 4, 5, 6, 7, 8. After that, really less effort, 111, 111. After that, a little more variation, but not all that much. 1, 2, 3, 1, 2, 3. After that, it's getting even less interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then lastly, topping the list is just 1, 2, 3, 4, 5, 6, 7. So this is not a good top 10 list to be on. So among today's first takeaways is if you see your password on the screen, like you didn't make the list in a good way, this means hundreds, thousands, millions of other people probably have that password of yours. Now, in and of itself, that's not necessarily worrisome because I don't know who has these passwords in a room as large as this, but just intuitively, why is this a bad thing? Either parent or child. Welcome to raise a hand here. Why might this be intuitively? Yeah. So access to it, like, I mean, we literally, as computer scientists, now have a database of really common passwords. And your thoughts? Yeah, you can just find it out quickly. I mean, you could imagine trying to guess someone's password by just typing in random letters, random numbers, random words. But not if you have a top 10 list. Like the adversaries in the world might as well just start with this list. Now, you'll notice that even absent from this are slight variants. Like some of you might be thinking, I'm not on the list because I do something clever. Like I use an exclamation point for the number 1, or a 3 for an E, or a 5 for an S. And based on the smiles in the room right now, you're not all that clever, it turns out, out because other people are smiling too, which is to say that an adversary can take those same heuristics that you might think are making things more secure by just tweaking some letters to numbers or vice versa. But if you're doing it and other people are doing it, the bad guys, so to speak, are going to be doing it as well. So unfortunately, when it comes to passwords, better is longer and random and really unguessable, but that's not what most of us have. In fact, case in point, on our phones, whether you have an Android device or an iPhone nowadays, odds are you have something relatively simplistic protecting it, if you have anything at all. But at least Apple and Google are pretty good at least nudging us to choose these kinds of passcodes now. And a 4-digit passcode is quite common nowadays. And so here's where we have an opportunity, thanks to the URL that you saw on the screen earlier, to conjecture as a group just how long might it take an adversary, someone out there who's out to get us or get one of us, how long might it take an adversary to figure out your phone's 4-digit passcode? This is CS50's own Carter. Carter, if we could switch over and poll the audience here. If you take out your phone or laptop, whatever device you might have used a few minutes ago to scan that QR code or to visit that same URL, you can see these questions on your browser. And if you can't, that's fine. We'll share some aggregate data nonetheless. But you should have an opportunity to tap one of your answers. And we'll give folks a few more seconds if you'd like to play along at home. And here, in just a moment, probably have many people reporting. But why don't we go ahead and take a look at some percentages. It looks like most of you, 67%, are proposing just a few seconds. So that's not all that good news if it's a 4-digit passcode. Some of you are hoping it's a few minutes. 8% are hoping a few hours. More than 4% of you are really hoping perhaps it's a few days. Well, let's actually consider how we can answer this question and make today not just conceptual, but a little quantitative too, and see if we can't slap some numbers on questions like these. So ultimately, you can make more informed decisions with your system's security. So for instance, when it comes to 4-digit passcodes, rather than just consider how secure it is, well, let's make it a more precise question. Like, what are the forms of attack? Well, the simplest attack might be just someone grabbing your phone, be it in your family or maybe at Starbucks or the airport or the like, and just starting all possible combinations, maybe 0000. Then 0001 and 0002. We could maybe automate this a little bit. So for instance, I might potentially be able to do something like roboticize this here. Let me go ahead and full screen a quick video here that's just going to paint a picture in just a moment on the screen of how, if we're a really clever adversary and know how to build things, well, at least maybe we could automate some of that process. So here's an Android phone sitting on a counter. Here's a very simple tripod and a little touch device robotically doing all of that hacking for you, starting at 0000, probably all the way up to 9999. Now, that too wasn't necessarily all that fast, but at least the adversary can step away and doesn't actually have to be bothered with the time involved, the cost involved in actually hacking that particular device. Well, let's go one level deeper, a little more interestingly, and consider here how much time really this so-called brute force attack would take. And that's actually a term of art, much like in yesteryear when maybe there was a battering ram trying to brute force their way into a castle or something like that. A brute force attack digitally is just someone trying manually all possible codes, or maybe robotically trying all possible codes, but generally automating the process in some way to go through all possibilities. Well, if you've got, for instance, a 4-digit passcode, let's ask maybe a follow-up question here. Not how long it will take, but how many possible 4-digit passcodes are there? Because then maybe we can do some quick math. And if every passcode takes me a second or a few milliseconds or the like, then I think we can try to extrapolate from that whether the first answer was seconds or minutes or days or hours or something else. So how many 4-digit passcodes are possible? If you take out your same device, it should have just changed automatically. If it doesn't seem to have, maybe reload your browser with some menu option. And then tap in here. How many 4-digit passcodes are possible? 4 total, 40, 9,999, 10,000, or unsure is OK too. So let's see. We'll give you a few more moments. How many 4-digit passcodes are possible? And shall we reveal the results? So now it looks like a few of you, 2% of you are saying just 4 passcodes. 40, 9,999. There's definitely some contention here, and 6% are unsure. Well, how do we wrap our minds around this? Well, let's just kind of do this real simply here. Let me switch back over to doing a bit of math. And if we have here 10 possibilities for each digit. If there's 4 digits, each digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 possibilities. So if you think about the number of permutations, that's 10 possibilities for the first digit, times 10 for the next, times 10 for the next, times 10 for the next. And so if we do that out, 10 times 10 times 10 times 10, or 10 to the 4th, there are indeed, as 66% of you found, 10,000 possibilities. And so now we can kind of work backwards and decide how long is it going to take for an adversary to hack into this phone, because if it's one attack, one guess per second, well, that's going to map out to 10,000 seconds. But maybe not if the adversary isn't a roboticist or a human. What if they're like a software programmer, someone who's taken even a class introductory like CS50 and learned a little bit of programming? Well, a little bit frighteningly, it's not all that hard to hack into systems if you just know how to code too and really have the computer do your work for you. So in fact, let me go ahead and change over to another screen on my computer here. This is different for students in the group from VS Code. This is just a black and white version of it that we've used briefly in the past. And I'm just going to go ahead and create a program called crack.py. To crack something just technically means to figure out what it is, figure out a password in this case. And .py means I'm going to use a programming language that we here in CS50 have been dabbling in the past couple of weeks, with more to come next week as well. So it turns out, and you need not understand each of these lines of code, if I want to try maybe generating all 10,000 possible codes, I'm not going to bother with a robot. I've got all these cables coming out of my computer, and odds are one of them is a USB cable or a lightning cable. Surely we could figure out how to connect like laptop or desktop to phone and just like automate the process nowadays by just sending all of the numbers into the phone until one unlocks the trick, just like in the movies or TV. Well, in Python, I could write a program that does this as follows. I can import, so to speak, all of the decimal digits, 0 through 9. And this, for students in the room, is just a slightly better version of typing out 10 different numbers manually. I can also import from a library, so to speak, called iter_tools, for iteration tools, which means to do something again and again. I can import a function called product, which means the cross product, like combine this with this some number of times. And then it's just 2 more lines of code. I can use what's called a loop in programming. So for every passcode in the cross product of all 10 of those digits repeated a total of 4 times, let me go ahead and, rather than bother connecting my phone and hacking my own phone, let me just print out every one of those 10,000 codes on the screen, and we'll see how fast the hacker could do this. Let me go ahead and print, and with an asterisk, which is a little trick to format it nicely, I'm going to print out each of those passcodes. And that's it. 4 lines of code, maybe 40 seconds of talking, but maybe really 4 seconds of coding if I actually did this without the audience. And now let me go ahead and save the file. And I'm going to run, as we do every day in class of late, Python of crack.py. And when I hit enter, I should see on the screen all 10,000 possibilities from 0000 to 9999. So let's see. Is it a few seconds, minutes, hours, or days? Done. So barely even seconds, plural, if that. So that should be a little disconcerting, because all that adversary needs to do is grab your phone off the counter, plug in a cable, and boom, they're done. Like there's no ticking clock or worries, as in the movies or TV, that maybe you're going to come into the room. You don't need that much of a window of time. So what would be better than this? Well, let's consider what our options might be if we don't want to just use 4-digit passcodes. Some of you indeed might have better passcodes than that, and maybe you use 4-letter passcodes instead. So A through Z, maybe uppercase and lowercase. That starts to make things a little more interesting. So should we poll this question too? If we upgrade from 4 digits to just 4 letters, English letters, A through Z, uppercase and lowercase, why don't we go ahead and poll the group here and ask how many 4-letter passcodes are there instead? So this time the range starts at 4. Still not the right answer, though, this time. How many 4-letter passcodes are possible? Not just yet. Just take a couple more seconds. All right. Almost a couple hundred responses in already. Few more seconds. And why don't we go ahead and reveal now the answers, which are, OK, so we've solved a couple problems at least. So OK, someone's just messing with us now. All right, so it looks like most of you, 76% of you, have claimed it's 7 million plus possibilities. So that's encouraging, because that's a whole order of magnitude more than before. Well, let's figure out how we might do this mathematically. So if we've got 26 lowercase, 26 uppercase. That's 52 possibilities now for each of those 4 digits. So that's 52 times itself 4 times, which indeed, either off the top of your head, a good guess, a calculator on the same device you're using right now, indeed gives us 7 million instead. Well, what might be slightly better than that? Well, maybe 4 characters. And this indeed is what your Macs, PCs, and phones are urging us to do nowadays. Not just numbers, not just letters, but like really annoying punctuation. So it really looks cryptic, not just to the adversary, but also to you and me, unfortunately. And that's the downside. But here now we have a mental model and really a computational framework via which we can evaluate the security of these. And I'll go ahead and spoil some of the math here. If we've got 52 letters of the alphabet, uppercase and lowercase, 10 digits, and if I count them out on my keyboard, about 32 punctuation symbols in typical English grammar, that actually gives us 94 possibilities now, which is up from 52, which is up from 10. So now we're really moving, and now that would give us 78 million possibilities. So another order of magnitude. Now, it's still going to be relatively fast because you know what? I can actually do this. Let me go back into my code here. Let me reopen the same program, and I can point out just how easy it is to make these changes. Instead of importing digits as before, I can import, as your child might know, ASCII letters, which are A through Z, uppercase, lowercase. And I can just change this here, ASCII letters. And so this was that first version where we just changed to letters. Let me now rerun the code. And instead of seeing numbers, we'll see letters flying across the screen. And if I walk over here to the screen, we'll see that by the time I get here, we're halfway through the entire alphabet lowercase. If I now start walking away, I think, yep, we're already done now with uppercase as well. If I upgrade this slightly further, let's go ahead and take it one more level and perhaps do, let's say, ASCII letters and digits and punctuation. And this would be the Pythonic way to say that. And I'm going to add to those letters those same digits, those same punctuation symbols. Let me shrink my font just so the code still fits on the screen. And what we now have is, with 2 seconds of changes, a program that if I run this version, whoops, without the typographical error, this is what we call in CS50 a bug. So now we run the same, this is what we call in CS50 a second bug. Punctuation. OK. This is where I cross my fingers. OK, so now it's going to be a little hard to see as it flies across the screen, but you probably are seeing glimpses of some weird punctuation characters as well. And I won't waste our time trying to talk through this because this is going to take longer. We're still in the lowercase. I'm still over here already. We've not even gotten to N, now O, then P. So this is going to run longer. But let's end with one final question on the security of all these systems. I'm going to cancel that by hitting Control-C on my keyboard. And let's ask the question instead, if we use 8-character passwords. So twice as many characters, but even that is not terribly long, right? This is 8 characters alone on the stage. 8 characters using letters, numbers, and punctuation might be better. Let's do one final vote here, if we could. On your same device, how many 8-character possibilities are there now for these passcodes? And now 4 didn't even make the list this time. All right, a few more seconds, about 100 responses so far. How about we go ahead and, Carter, if you wouldn't mind, let's reveal the results based on the vote. A pretty decent spread here, although the quadrillions are quickly buzzing in and they're contending with the others here. Looks like 44% of you said quintillion, 34% said quadrillion, and this time, for the first time, you overbid. So indeed, if we go back to the math here, at least the majority overbid. If we have 8-character passcodes, that gives us 94 times itself 8 times, or 94 to the 8th power. And in fact, that gives us roughly 6,695,385,410,816 possible passcodes. Now, what does that mean? Well, the adversary's algorithm, the step-by-step code that they write to try to hack into your phone is no different. And honestly, if your passcode is 8 characters long, but they're 000000000, you're no more secure fundamentally. You really want to be somewhere in the sweet spot of that massive range of values so that if the adversary tries this brute force attack just running through all possibilities, they will eventually reach your passcode. Just mathematically, it will be there. Hopefully, though, well, maybe not hopefully, you and I and they will be gone from this world because that much time will have passed. And if we do out the math here, this number of seconds, for instance, is long past when we will no longer be here. So that's the sort of measure, is we don't sort of fundamentally change the equation for the adversary. It's still the same risk, it's still the same attack, but you significantly drive down the probability of success on their part, or conceptually you drive up the cost to the adversary. And indeed, even in the physical world, this is true. You just want your passcode in the digital world really to be better than someone else's, because you want someone else's passcode to be the one that the adversary does something with. Just like in the physical world, even though it's a bit uncomfortable to consider, your house doesn't need to be 100% secure. And indeed, it's difficult to make it such. There's always going to be a point of weakness. Maybe it's that window, the door, or something like that. But if your home is more secure than the next door home, just probabilistically, you are more secure. You're not secure. And indeed, any website you see down the road that says, we are secure because we do X, Y, or Z, like, that's nonsense. Security is really about comparisons and evaluating things, if quantitatively, relative to some other system, relative to some other code. So what's the takeaway here? Well, hopefully a non-trivial number of you will go home this weekend on Monday and change at least one passcode. But there's going to be a trade-off here. And we talk about this all the time in CS50. Anytime we improve something, we pay some price in time, in performance, in cost, somewhere else. So what's the downside then of this advice, that you should use minimally 8-character passcodes? Why might you want to say nay and not do this? Say again? You have to remember it, right? And so here there's sort of some sociology, there's some human behavior. You know, some of you might have colleagues if you're working in the real world, at least back in healthier times when you had colleagues with desks and cubicles, and there's probably one person in the office with like a Post-it note on their monitor with their passcode. You know, it's a bit of a cybersecurity offense, but it's also a sort of real world side effect maybe of corporate policies that aren't really calibrated for human behavior. So we'll see if there's some other defenses. And indeed, let me propose that we talk briefly about one that actually tends to kick in automatically. Even if your passcode is not as strong as we've just seen, one of these 6 quadrillion possibilities, well, what could we do instead? Well, has anyone, and I'll zoom in on this here, accidentally locked themselves out of their own phone before? Like, when does that happen? Yeah, when you try the password. Yeah, so too many times. Maybe your finger's slightly off, maybe you're slightly off, and you just don't input the same passcode correctly after like 5 times, 10 times. There's some reasonable threshold. And why does that happen? Well, Apple and Google equivalently figure, just probabilistically, if after 10 guesses you still haven't typed in the right passcode, probably you're not you. You're someone else who's picked up your phone, so we're just going to go ahead and lock you out. Now, what's the effect of this? Well, this means now that each of those possible passcodes no longer takes roughly 1 second. Now it takes roughly 1 minute. So the attack is still the same, but if it's now 1 passcode or 10 guesses per minute, we have significantly, by a factor of 60 in this story, slowed things down. And unfortunately, does anyone know what happens if you screw up again after a minute? Yeah, it goes longer. It's like 5 minutes and then 10 minutes. And Google is kind of obnoxious about it. They don't even give you a time frame. They just say, try again later. And so that keeps not only the adversary out, but also potentially you. So therein lies that trade-off. If you've forgotten your code, if nowadays your finger is slightly wet so the screen isn't responding correctly, these could be usability downsides too. So security is really just about finding the sweet spot among these various trade-offs here. But there's other mechanisms too, and some of you might recognize this screen from Gmail, via which, of course, you log in. But after you log into Gmail, or similar websites, or apps, or systems at work nowadays especially, you might be presented with what's called 2-factor authentication. And what is this in a nutshell, in layperson's terms? Many of you, if you do anything digitally at work, might have to do this now. Yeah? Exactly. You get texted at your phone an additional code that's not your same password. It's typically a numeric code, maybe 6 digits long. It expires after a minute or 10 minutes. But why is this a good thing? Well, one, it's no longer just a piece of information that you know or that you might have written down. It's information that changes every time you try to log in. But more importantly, it's a fundamentally second factor, which means it's not just something you know. Now it's something you have. So you, for instance, are the only one, theoretically, that should be receiving that code. And so now the adversary, if they want to get into your account, not only have to guess or brute force or maybe read off of a Post-it note your password, they also have to physically have access now to that phone. So there's still a threat, absolutely, but it's not everyone on the internet with an internet connection. Now it's only the people in Starbucks. Now it's only the people at work. Now it's only the people in your home who might have access to that second factor. So there, too, it just raises the bar to the adversary, making it harder, more time-consuming, more geographically impossible for them to attack you. But what's the downside of two-factor authentication? Whether it's a device or even nowadays it's in software, whether it's on your keychain or on your phone, where you're prompted for this code, what's a downside? As some of us have probably experienced too. You forget your cell phone. Absolutely, right? The factor that you don't have with you, or maybe you're in a basement somewhere, don't have reception, you're on a plane, you can't get the code. And so there, too, are these trade-offs. And even IT departments need to keep that in mind, because what does that mean for them? Well, if you don't have your phone with you and you are in the habit of calling IT to help you fix this now, there's a cost, a human cost, maybe even a financial cost. And so IT policy nowadays is really just about finding the right balance and where we want to spend our resources, but at least raise the bar to the adversary. But of course, there's other ways too. And this is going to be one of our homework assignments, if you will, after today. There's this software called password managers. And no need to buzz in on your phone, but maybe with a physical hand. How many folks here use a password manager? OK, let me ballpark this at 10, 20% perhaps. OK, so we've got 80% upside here and a lesson learned potentially. So a password manager is just a piece of software on your Mac, your PC, or your phone nowadays that manages your passwords. Well, what does that mean? When you go to a website for the first time, or you download an app for the first time and you have to create an account, you can still use your email address or David as your username or whatever your name might be. So you don't have to change that methodology. But instead of typing in 1, 2, 3, 4, 5, 6 as your same password for that website or app as well as for every other, now you use the password manager software to generate something difficult to guess for you. That is, you tell the password manager, give me an 8-character random passcode, not 0000, but something with punctuation, with numbers, with letters. And better yet, the password manager, as the name suggests, remembers that password for you. And the next time you go to another website, you do it again with a completely different password, maybe same username, maybe two-factor authentication, but different password, different password, different password. And it doesn't have to be 8. I mean, I'm in the habit of using a dozen, 24 characters in total. And at that point, I can't even pronounce the number of possibilities because it goes well beyond the quadrillions. So the probability that someone's going to get into one of those accounts for me now is very, very, very low. And they're going to take less interest in me and maybe more interest in someone else that's not using as good of a password. Now, what does this mean in real terms? Well, when you go to log into that managed site, you don't manually type your password anymore. In fact, you don't generally even need to know it. Nowadays, I probably don't know 99% of my passwords. I entrust them to this password manager. Now, of course, you'd like to think that the password manager itself is secure. So what might that mean? Well, those of you who do use a password manager, how do you access that software itself? What's protecting your data in your understanding? So maybe biometrics, like your Face ID or maybe your fingerprint, or maybe more simply, what else? Maybe just a password. And hopefully that password, that primary password, that gatekeeper is not itself 1, 2, 3, 4, 5, 6. Otherwise, it doesn't matter how secure all of the others are. But if you're willing to put in the effort and pick one pretty long, somewhat random, very unguessable password that you just promise to commit to memory, and maybe for backup, you literally print it out and put it in a safe deposit box or a safe, or just kind of hide it somewhere physically that there's very low probability someone's going to find the backup copy, that might be alone. But of course, the flip side is now, if you forget that primary password, you've now lost all of the eggs in the basket. If someone gets that primary password, now they have access to everything. So that's rather the trade-off. But I dare say you're probably less threatened, depending on your family, by the people immediately around you than the billions of other people on the internet that have access potentially to those same systems. So there, too, it's a trade-off, and it's up to you to decide whether or not to manage your passwords in this way. But if you were on that top 10 list, or even if you're not, but you can think of several accounts that all have the same password, you're probably going to benefit from something like this. And why is it bad, to be clear, to use the same password on multiple sites? In case that's never sort of dawned in thought. Why is that a bad thing, to reuse a password on different websites, different apps? Any intuition? Yeah, and back? Exactly. Once it's attacked, you can the adversary, presumably by transitivity, can see, oh, well, if this user's username is mailin@harvard.edu on this website and their password is foolishly 123456, or even something way more complicated, they can probably just assume with high probability that if I'm being a little reckless, let's try accessing mailin@harvard.edu's other accounts, other apps, using that exact same password. And so by transitivity, essentially, you're putting your other accounts at risk. So what's maybe a takeaway minimally here? I would start to reconsider your passcodes on your most important data. Maybe it's medical, maybe it's financial, maybe it's email, anything remotely personal that you really wouldn't want to have accessed. Do you necessarily need the same level of security on e-commerce sites or sites that you don't really care about or that you signed up for once and after that, that's it? Probably not. So you can decide for yourself. But again, software like a password manager, and these are just some of the possibilities out there, are probably to be your friend. A couple of these are free. They come with Windows or Mac OS. A couple are commercial. Harvard has a site license for students for one of these as well. So there are options out there. But what else do people use? What else can people use to keep their system secure? So most of us nowadays have probably heard of encryption, this technique for just kind of scrambling information. So when you want to send a message, an email, or upload a photograph, or use your credit card, hopefully it's not just being sent out for all to see, but there's some kind of scrambling going on. And some fancy mathematics ensure that encryption ensures that only you, the sender, and someone else, the receiver, can theoretically see what that credit card number is, what that message is, what that photograph is instead. So encryption is sort of commonplace nowadays, both in websites and apps and ATMs and other such devices. But how does it work? Well, back in week 2 of CS50, your child learned a little something about encryption, otherwise known as cryptography. And one of the algorithms we talked about was quite simply something like this. This is what we might call not only CS50, but plain text. So very plain text that in this case is English, and obviously everyone in the room can read it. But what if I wanted to send this message out to someone in this room or out on the internet, or maybe equivalently back in the day, maybe write a message down on a scrap of paper in grade school and pass a secret note, a secret love note to someone in class with hopes that the teacher or any other students in the class can't intercept it and read it? Well, you probably don't want to say this is CS50 or I love you or anything remotely sensitive, but rather maybe you want to encrypt it. And let's change the T to a U. Maybe change the H to an I, the I to a J, the S to a T, the I to a J, the S to a T again, the C to a D, the S to a T, and we'll just leave the numbers alone, even though I worry someone could probably guess what this now does say nonetheless. But what was the algorithm as I rattled those changes off, whether student from week 2 or parent from week now? Yeah. Just a one-letter shift. And this is more sophisticatedly called a rotational cipher or a Caesar cipher after Caesar back in the day. It's relatively simplistic. But back in the day, it's not so simplistic if you're the first person in the world to ever use it or think of it. But nowadays, this is not actually what we use. But it's similarly mathematical in nature. It's not quite as simple as just adding 1 or subtracting 1 to go from now what we'd call ciphertext to plain text. But it's similarly math that's involved. And let me just stipulate that the way the math works is that the sender and the receiver just have to have in mind some kind of secret. And the secret in this case would very trivially be 1, but it could be a much bigger, much more unguessable number, or maybe some other secret we share. The presumption being that my classmates, my teacher in that grade school classroom, if they don't know what that secret is, that number is, yeah, they could try to brute force it and try all possible mathematics, +1, +2, +3, but that's going to take them some time, and they probably don't care enough, and so my data might be, and therefore, relatively secure. But we use encryption all the time nowadays, and so for instance, this is at the start of most URLs nowadays, even if you don't type it yourself. With that said, Safari and even Chrome now are kind of simplifying, if not dumbing down, user interfaces to just hide details that you and I, as sort of normal users, don't need to see 24/7, but it is there. And if, in fact, on your phone or laptop, you click on the URL, even if it's super short initially, you'll probably see the whole thing starting with this. And the S means secure. The S means that encryption is being used. But there's other forms of this, not just when you visit websites. There's this, end-to-end encryption, which is being talked about more nowadays, especially during COVID times with so many more of us on video and talking about more sensitive things, telemedicine, talking to doctors, things that you also wouldn't want to verbally or visually get out into the wild, just like text. What's different about end-to-end encryption versus HTTPS and the type of encryption that most of us use every day on websites alone? End-to-end encryption is sort of a better feature that you want to increasingly seek. when using services like Zoom or Microsoft Teams or WhatsApp or the like? Any instincts here? Yeah, over on the right. Good. So the encryption, the scrambling of information happens in the source, the sender, and the destination, the receiver, without a so-called middleman in between. And this is actually very different from most contexts nowadays that use just HTTPS, because when you're using HTTPS to buy something on Amazon securely with your credit card, well, of course, Amazon needs to be able to decrypt the message at the end of the day, and so that's fine. But even when you're using services like video conferencing or maybe text messaging nowadays, well, if you're using WhatsApp, that's owned by Meta. And if you're using Instagram, that's owned by Meta. I mean, there's a lot of middlemen in these apps that we're using. And if they were only using encryption, period, or only using something like HTTPS, yes, your connection from you to WhatsApp and in turn to the recipient might very well be secure on each end of that channel. But Meta, in the between the company and any other company in between, could theoretically, for better or for worse, be looking at that data, whether it's to mine it for advertising purposes, whether it's to snoop on data that you're sending. That is not end-to-end encryption if the middleman, a company typically, has technically access to that data. Now, Zoom and Microsoft Teams and WhatsApp and iMessage and other services with which you're familiar increasingly are offering stronger guarantees of encryption, whereby it's indeed between parties A and B and not the one in the middle. Now, there's downsides here, and you can actually see this kind of functionality manifest in certain settings. For instance, besides iMessage, which just does this for you on iPhones or Macs, besides Zoom, you can actually fine-tune these settings, indeed, within Zoom itself. So here's a screenshot that I took last night of just what the user interface looks like today to create a new Zoom meeting with the latest version of Zoom software. And maybe unbeknownst to you, there's a choice of buttons down here. And most likely, yours is by default on enhanced encryption, which is brilliant marketing speak, because it's just encryption. It's not enhanced. It actually, ironically, means worse than this. But they want you using it most likely. Why? Well, it's a little easier to implement. It's a little less expensive for them computationally. And to be fair, enhanced encryption does scramble the data, but not in a way that Zoom can't see it. Zoom can indeed see it, but that's actually a plus in some contexts, because if you want to do like cloud recordings and you want a meeting recorded not on your Mac or PC, but like let Zoom deal with that. If you want automatic transcription nowadays, so the words to appear, whether it's English or something else on the screen, well, you can't really lock Zoom or any other middleman out of that, because someone needs to save it to the cloud. Someone needs to translate the voice to those English or some other language words. So enhanced encryption enables those features, but they also allow a bad actor, malicious employee, someone who's just nosy at Zoom or the equivalent middleman, to just kind of poke around your video conference and hear what you've said or see what you've typed as well, unless you instead check this box as well. So increasingly look for mentions of end-to-end encryption, or give that some thought when you choose a technology via which to communicate with someone, whether it's within your family or without as well. Now, last but not least, there's other applications of encryption too, and this too might be a lesson learned as well. Full disk encryption. So a disk is like where your data is stored in your Mac or PC or even your phone. And full disk encryption just means ideally that all of your data is encrypted, that is somehow scrambled. Now, hopefully your password for your computer or phone is good enough that even though the device is encrypted with that password, at least you'll remember it, and your phone or your Mac or PC will automatically decrypt it for you. Of course, you can't scramble the information and hide it from ourselves. One of us, at least for these devices, needs to have access. But full disk encryption typically means that at least when you close the laptop lid or power down for the night, that even if someone else steals that device, opens the lid, unless they have your passcode, they can't even plug in fancy cables to the device and just rip the zeros and ones off of the device and see what's actually there. Full disk encryption means they could do that, but they would just see seemingly random zeros and ones. Now, there's a downside here too. This might slow things down potentially, but it is a feature increasingly that's offered and is absolutely something you should consider enabling in general, especially if your laptop or phone travels with you, and certainly your phone does, or if you plan to donate or sell or give away a device. You don't want to leave all of the zeros and ones, the remnants of your own sensitive data, passed on there. So Windows has has a feature called BitLocker. Mac OS has a feature called File Vault. There's commercial options as well. But generally, we're at the point now in 2022 where clicking a button is sufficient to enable these features. With that said, don't rush into all of these decisions. I would make backups of your data and don't maybe email CS50 if something goes wrong with that process. But I would do your own due diligence. But this, too, would be a menu of possibilities. And now the bad side, the downside of what seems to be great, this notion of full disk encryption. Unfortunately, just as we can encrypt our data to protect it from the adversaries, so can the adversaries, if they get into our devices, encrypt our data and do what? Not tell us that secret key. And so this is generally applied in the context of ransomware, which tragically you increasingly hear about in hospital systems, school systems, municipalities, where systems are getting attacked. And the data is not just getting stolen, because what does the adversary typically need with like local, municipal, or even hospital data? The value to the adversary is encrypting all of the hospital, all of the municipality's data, preventing them from accessing it if they have no backups or the like. And so ransomware is literally about trying to convince someone to pay you money or pay you Bitcoin or something like that to give you that secret key. And this key in this case is surely more sophisticated than the number one, but it's really the same idea. So here too, yet again, a trade-off. Just as we sort of invent something for good, it can also be used for evil, in so to speak, as well. But it's really the same underlying principles, even though we keep seeing it and hearing about it in these different forms. And lastly, if only because folks are generally familiar but don't necessarily know what it is that it's doing for them, browsers nowadays have what's often called incognito mode or private mode, which has nothing to do with encryption but does have to do with cybersecurity, or really cyber privacy, keeping your data from prying eyes. Incognito mode, if you open it in Chrome, for instance, looks a little something like this. And we use it in CS50 when introducing students, as we did last week, to web programming, because it, in effect, lets you start with a clean slate, like a brand new browser that has never visited any websites before, which is good for just diagnosing problems. But it's often commonly used if you want to log into maybe your Gmail account on someone else's computer and you don't want your password being saved, or you want to visit some website where you don't want the URL or the search terms ending up in your autocomplete history. So there's multiple uses for incognito mode. But what does it really do? Well, it doesn't stop your company. It doesn't stop your university, your internet service provider, be it Comcast, Verizon, or the like, from knowing what websites you go to. Because ask your students. A couple weeks ago, we talked about, actually a week ago, we talked about how the internet works. And unfortunately, every computer has an IP address, which is a unique identifier, which goes out anytime you go anywhere, incognito mode or not. So this isn't really covering your tracks outside of your office or outside of your home or outside of your company, but it is at least throwing away local information. And so we'll talk, in fact, in CS50's week 9 this coming Monday about cookies, which you might generally know about, and what are called sessions. And so long story short, what incognito mode does is it throws away, when you close the window, any locally stored information, these things called cookies, which are sort of like virtual hand stamps that just remember what you've logged in as or what's in your shopping cart or the like. But it doesn't hide any information from anyone outside of your own Mac or PC. It only prevents those local prying eyes. So there too, even though we have tools that many of you are probably in the habit of using or thinking you should use to be more private, be more secure on the internet, what we do really in CS50 both weeks past and future is talk about how these technologies work so that ultimately we have all the more of an educated citizenry here among undergrads and here as well as online, so that you can apply these same lessons learned to problems you'll encounter in the future. So as promised, the homework. One should probably use a password manager. It doesn't have to be one of those ones on the list, but at least starting that conversation maybe with someone who does, maybe it's often the student in your family perhaps who can advise you on some of these technologies. Consider using a password manager. 2, using two-factor authentication, whether it's your phone or some key fob or the like, but at least seeking out that feature, at least for accounts that you really care about. Your email, social media, financial, medical, anything where you'd be embarrassed at best or really violated at worst if that kind of information got out. And then increasingly using not just encryption, which you kind of get automatically from most technologies today, but increasingly choosing technologies that offer stronger guarantees that keep those middlemen, those companies out of the way, if only so that you can trust with higher probability that only party B knows what party A has said or sent. Now, this, of course, was a whirlwind tour. There's so much more that you can do online. Indeed, this course, CS50, can be taken for free online via platforms like edX at edx.org/CS50. I thought it might be appropriate to end on this note. If anyone would like to conjecture before we start playing music and adjourn for lunch, what our final message here is. If we reverse the +1 and maybe start -1 here, -1 here. And indeed, thank you so much for coming. This was CS50.